If you're thinking about entering into the world of IT to become a system administrator, network admin, security admin, or something like that, then you need to start here. This is CompTIA's IT Fundamentals. This is a video that covers the entire CompTIA's IT Fundamentals exam. It covers every single one of the objectives. And in this video, I'm going to show you how to pass that test. But most importantly, I'm going to give you the knowledge you need in order to succeed in the other classes. You see, I've been teaching CompTIA classes for over 20 years now. I hold over 60 different certifications, and I've met thousands, tens of thousands of people entering into the field of IT. And one of the things that a lot of people lack is just basic IT skills. Like, do you know the difference between how we measure the speed of a computer versus the storage? Do you know what's the difference on a computer motherboard? What does the hard drive do versus the RAM? Do you know how software is built? Do you know what are drivers? If you do, you know what? Maybe this course isn't for you, but you should still go through it to see if there's any gaps that you're missing. Again, by the way, this course is 100% free. You don't need to pay for anything. The entire course is in this video. So what I recommend is before you study your A+, before you study your Net+, your Security+, before you study your CISSP, maybe you need to brush up on the technology. Watch this entire course. It's about 6-7 hours. So go through it. Now, I did record this course about 2 years ago, and we have used it to give to all students that takes classes with us because it's just useful for them to learn basic computing. Everyone should, by the way, should know this. So enjoy this course as I go through it. I have the exam objectives listed below. There's some links below for practice exams if you actually want to take the certification exam. It's not mandatory, but just in case you want another certification, I have a link to some practice exams that we did also. So enjoy the course and have fun learning or entering the world of IT. Before we get started in this course, let me give you a brief introduction to me. I'm Andrew Ramdial. I've been teaching IT courses over the last 20 years to tens of thousands of students around the world. In my full-time job, I was a system administrator, network administrator, and a pen tester in the world of IT security. I worked on that blue team and red team in IT security. Right now, I hold over 60 different certifications, and I teach mostly IT security classes. You would find courses, things like Security Plus, Certified Ethical Hacker, Certified Information Systems Security Professional, Certified Information Systems Manager, and Systems Auditor is mostly the courses that I teach. But I am happy to teach some basic IT concepts because I believe if you don't have the basic IT understanding, studying for things like your A+, your Net+, or your Security Plus could be very difficult. So I'm really happy to present this course. Let's get started. In this video, I'm going to be covering the actual exam. What's the exam number, how many questions you have, basically what to expect on exam day when taking this particular certification. So I got a little slide here that I want to go over this information with you. So the first thing up I want to talk about here is going to be the exam code. Now this is an important number. Right now the exam code for this current IT fundamental exams you're taking is FC0-U61. That is current exam code. Previous exams was like FC0-U51 would have been the previous code to that. So FC0-U61, why do you want to know this number? Because when you're registering for the exam at Pearson VUE, the people that administers the exam, you need to make sure you see that code and make sure you select the right exam. Because many years from now, or soon there may be a new exam, and sometimes they have two exams running concurrently, an old one and a new one, and you got to know which one you're selecting. Okay, this exam came out in September of 2018. Now, that is a good time backwards, considering I'm doing this video in 2022. The CompTIA exams can last 3, 4, 5 years before they're updated. We do expect an update to this exam relatively soon. One thing I want to point out, though, is when you're certified in one exam, you're basically going to stay certified basically for life if you keep getting what's called continuing education. So, for example, if you're certified in A+ certification and you're certified in a certain series, like let's say you're certified in the 900 series, but then the 1000 or the 11,000 or the 12 or the 1100 or 1200 series exam comes out, you don't really need to retake the exam again, as long as you maintain what's called continuing educational credits. So it doesn't really matter what exam you take, as long as you take it, you're certified. As long as you keep renewing it, you don't have to take the exam again. So it really doesn't matter what version of the test you're taking. Now, let's talk about the actual exam itself. So this is a 60-minute time limit, and you have a maximum of 75 questions. and they're all multiple choice. Now, I want to talk a little bit about the timer here because the timer is important. The exam itself is not incredibly long, okay? Most of my students that take the certification is able to finish it within 30 minutes to 45 minutes. I've never heard of a student taking this exam that actually ran out of time. And I don't think you will too. Expect to be there for about 45 minutes. If you read the question relatively quickly, you do all the practice questions in this course, I think you're going to be able to finish it in 45 minutes. Multiple choice. Now this is important because other CompTIA exams has a variety of questions, such as you have to select multiple answers, or there are simulations or what's called performance-based questions. None of that. This is a straightforward exam with just multiple choices, no fill in the blanks, nothing. If you get A, B, C, D, you select one of the choices. You do need 650 out of 900. Now CompTIA uses a scoring system of between 100 to 900 to grade your exam. You're going to have to accomplish 650, which is 72% on that test. So you need 72% of the 75 questions that they're going to give you in order to pass this exam. Now that score isn't super high, but it is not very low either. You know, some exams are like 60%, it's not like 80%, so it's right there in the middle, which I think is a decent, fair grade. Exam fee. This number never comes down. This number only gets bigger. The exam fee is $134 as of today. You watch this video a couple of years from now, it's going to be much more than that. So something to think about. As time goes on, this exam will get more and more expensive as time progresses. Okay, so this is your exam information, things to know about here. Hey, 60 minutes, 75 questions, all multiple choice. You need 72% to pass, and if you can get that, you're going to ace your exam. In this video, I'm going to be going over a brief description of the 6 domains that makes up the actual exam. Now, to follow along with me, you should download the CompTIA exam objectives. If you're watching this on this platform, I probably would have attached it as a downloadable link here. And the objectives is something that you can get from the CompTIA's website. What the objectives does is that it goes through all of the different topics that's going to be covered on the actual test. And that's what we're going to be taking a look at right now. So here is the 6 domains that we have. And I'm also going to be laying out the course like this. So as you go through the course, you'll know this is what I'm expecting right now. So let's get into this. So the first thing up, domain 1, it's going to be what's called IT concepts and terminology. 17% of your exam. What are you going to learn here? Well, I'm going to teach you some basic conceptual terms, like what's a bit versus a byte? What exactly are binary, right? You have to know binary is a base 2 or decimal is a base 10 system. There's actually questions on this. You have to know simple, not complex, simple theory on troubleshooting, like troubleshooting steps. You're going to get questions on that also. The next thing we'll move on to is infrastructure. 22% of the exam. You got to have basic knowledge of things like connectors, motherboards, RAM, CPU. If I show you an S-video connector versus a DVI connector, which one supports a higher data rate? Things like that you're going to need to know. You should also have an understanding of certain networking gear, like what does a router does or a switch do. We're going to cover that in that section. The next one up is application and software. Now, there's going to be a variety of application and software that you should be familiar with. For example, you should know that a word processing is like Microsoft Word and what we use it for. Microsoft Visio is a diagramming software. How does that work and what do we use it for? Productivity software. You should know operating systems and all the different forms of it that is out there. Linux, Windows, and so on. The next thing up we have is software development. Not a lot of questions here, just 12%, but the other one was 18%. In software development, you got to understand simple concept of how software is made. You should understand, for example, like what is a loop, what is a variable when you're programming codes. Now, you don't need to be a programmer to pass this particular exam, but you do need to know certain scripts that are out there. And as an entry-level technician or people getting into this, you should be able to read some of these scripts, like an if-then statement that is used in software development. We'll cover that. Database fundamentals. All data in today's world is stored in some kind of database, whether it's an unstructured storage or a structured storage, something stored in a SQL database, also known as a relational database. What exactly is the difference? We'll take a look at that in that section at 11%. Now, security is a big topic in this world. Comes in as the second biggest domain that you have here at 20%. You're going to need to understand basic security concepts and basic security controls, confidentiality versus integrity versus availability, different types of security control that are out there to help secure, like different forms of encryption, different forms of Windows permissions, and so on. You should be familiar with. Really not complex security stuff, but more basic things. Add up, you get 100%. So when you're going through your exam, you're going to get 20% of your questions on security, basically. You're going to get 22% on infrastructure. So that's what this is telling us when we sit down on the day to take your exam. Now, ITF, you got to remember, it's not a very in-depth certification. You don't need to get in-depth into these things. For example, security is something you can get in-depth into, and you can spend a career doing it. People that work in software development can spend their entire lives developing and coding software. In this course, I want to get you just a basic understanding of what these things are. And your exam is basic and conceptual understanding of these topics. So don't go study in depth. Just get a high-level overview of what these topics are so you can ace your exam. In this video, I'm going to be covering notational systems, in particularly the numbering systems that we use in technology. Now, in the world of technology, we're basically going to use three numbering systems: decimal, binary, and hexadecimal. For your exam, don't expect really complex questions on this, but I do want you to understand that they may ask, what's the base of this system? Oh, let me show you what this is and tell me, is this a hexadecimal? Is it a binary or is it a decimal? So that's really all you have to know. So don't bust your brains on this. Let's get into it. Let's take a look at it. So the first one up we're going to talk about is, of course, a decimal. Why? Because decimal is what we use. All of our lives we have studied in decimal. Whether you're doing math in grammar school or you were doing calculus in college, it's all based on decimal. Humans mostly read decimals. It's the computers that mostly read binary and hexadecimal. Now, one thing you have to know for your exam is that decimals are known as a base 10 system. Now, what does that mean? Well, it means that in a decimal system, there's 10 possible combination of numbers. 0 to 9 is what they are. So in any number that you've ever looked at, whether it's 1, 32, 56, 1,000, 2,000, 3,000, 1,000,000, and 56, they're all, the digits within them are going to be 0 or 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is known as a base 10. Why? Because there's 10 possible combinations of digits that are out there. The next one that we're going to want to know is what computers read. Binary code. Computers read binary, and binaries are basically zeros and ones. And they read this because of the way the processor works. Now, when I get into hardware and we're going to talk about processors, I'm going to show you what a processor looks like and why they read binary, because they're made of transistors. And I'm going to show you that when we get there. So binaries are just ones and zeros. So when you see somebody writes a binary, it's going to look something like this. It's either going to be 0 or 1 and 0 or 1, 0, 0, 1 or 0, 1, 0, 0, 0, 1, 0, 1, 0, 1. Now, there are ways to convert binary to decimal and back and forth. I covered that in the A+, Net+, and so on. You don't need to know that here for ITF, but it's something that you should be familiar with coming up later in your career. So binary is known as a base 2. Why? Because there's only 2 numbers in each binary. The next one we have is a hexadecimal. Now, hexadecimal is something that we use, for example, in representing the hardware address of your computer, known as your MAC address. Hexadecimal is a base 16. How do you get that? Well, first of all, it's 10 numbers, 0 to 9, and then it's A to F. So A, B, C, D, E, F. 6 letters, base 16. So 10 numbers and 6 letters creates this hexadecimal. Hexadecimal is famous for displaying very large binary digits in very small number of characters. For example, showing like let's say 2A in a hex can be lots of digits in binary. So depending on what you're looking at, whether it's an IP address, which would be in a decimal notation, depending on a MAC address, an IP address is your logical address, right? Your MAC address would be your hardware address, that would be in a hexadecimal. We're just looking at just the computer codes, what the computer read, that would be in binary. So these are going to be your three main notational systems that you're going to see in all the world of IT. So once again, decimal 0 to 9, it's a base 10. Binary, it's a 1 or a 0, it's a base 2. And hexadecimal is a base 16. It's the digits of 0 to 9, A to F, and hexadecimal is represented. You know what? We didn't look at the examples on it, right? Forgot that one. Where is my trusty slide here? So things like 2, 26, 2A, 49F, BB, AFF, 3, any combinations of this that you can come up with. So these are going to be your examples out there of the different types of numbering system we use in technology. In this video, I'm going to be talking about data representation. Now, when you have a keyboard, as I have here on my desktop, when you have a keyboard on your desktop and you press a key on this, how does the computer interpret this? Well, the computer doesn't read letters like we do. It doesn't read K and L and O and the open brackets, close brackets, open parentheses, close parentheses, the @ sign, and so on. It just doesn't read any of that. The computer wants to know, hey, what number is that? Remember, a computer reads data in binary. A computer, the processor, processes data in binary. And again, I'm going to talk more about this when I get into the hardware section of this class. So how does the computer actually see these numbers? Well, these numbers, these letters, numbers, and all the symbols on your keyboard is encoded. And it's then fed through the computer in an encoding standard or what's called a code standard or a standard code. And the way we're going to talk about this is basically two of them. There's something called ASCII and Unicode. So let's get into this. One of the most famous coding standard for encoding things like your letters on your keyboard is going to be ASCII. Now, ASCII stands for the American Standard Code for Information Exchange. It basically supports 128 characters. It's 7 bits in its default nature, but it could go up to 8 bits and support up to 256 characters. There is a link there that I'm going to show you in a minute. I have that link open to show you an ASCII connection table. So, or I should say translation table. So anytime you press a letter on your keyboard, ASCII will take what you typed in. Let's say you put the ampersand. Let's say you put the $sign, the number 5. Or every time you press that, what it's going to do is that it's going to take that and turn it into a number because it knows that this, you know what, this ampersand is this number. The letter A is this number. Then turns it into a binary and boom, the computer reads it. Because remember, a computer only reads binary. Now ASCII only supports up to 128 of these characters. Something even bigger is called Unicode. Now, Unicode includes ASCII plus a whole lot more. In the English language, and we use this keyboard that most of us use, but other languages, such as Arabic, Greek, more mathematical symbols that's not on this keyboard, is stored in Unicode. Now, Unicode supports very large amounts of digits and can support everything in almost every language that is out there. Now, to make this presentation a little bit easier, what I'm going to do is I want to show you guys the ASCII table. And this is going to be the link you just saw on there. So here's an ASCII table. So this is the ASCII translation table. So I'm going to show you what I mean. Now, I got this right off of Wikipedia. So look at this. If I type on the keyboard, if I type the number 0, that's represented as the number 48, which would then be turned into a binary and fed through the computer. So every time you press 0 on you put 0 on your keyboard, the computer reads it as the number, the decimal 48, and reads it as a binary of 48. If you press the equal sign on your keyboard, that's the number 61 in decimal. If you press an uppercase A, it's 65. If you press a lowercase a, it's 97, and so on. You could literally see every single key on the keyboard is listed here, or every single symbol we have. You can see all these different, from the space bar all the way to the shift, backspace, and so on. So lots of different things that are here. Now, for your exam, when it comes to knowing these code and state, it's good to know for your exam in real life. If you're studying like computer programming in real life, this is good to know. This is good to know when you are programming different types of applications or looking for translation. Other than that, just know the definitions of what they are for your test. In this video, I'm going to be covering some more codes that you should be familiar with for your exam. Now, you don't need to know how to run codes for your exam or type codes, but you should be able to understand it, like I said before. And one of them is called a Boolean expression. Now, Boolean expressions in coding standards is basically an expression that outputs basically a yes or a no, a true or false, or 1 and 0. Boolean expressions in the world of programming is basically outputs one of two possible options, 1 or 0, yes or no, on or off, true or false, and anything else that can be put out as either one of two outputs. So, for example, let's say there is an application that when you put in your weight, and it tells you whether you're overweight or not. So I'm 6 feet 220. Am I overweight? The application would say yes. If I put under, let's say 190, it says no. That's all it does, yes or no. That would be a Boolean expression. If there was a checkbox to say, does this function work, yes or no? Will you execute the function? Did it work? Yes. Okay. Did it work? No. That would also be another example of Boolean. Now, actually, I'm going to take this a step further, and I'm going to show you a Boolean expression in Java. This might scare the hell out of you, and basically what I just told you there is all you need to know for your exam. But I just want to show you what they look like when you start writing codes. Now, you don't need to know this part for your exam. If you want to shut off the video right now, you're okay to do that, but let me just show it to you. So I'm going to go to Google, and I am going to type Boolean example in Java, and one of them I found is called Java Booleans at the W3 schools. Now, I'm going to read the code for you, and I found one here that's pretty easy, and I want to show you because this one includes the integer. So I'm going to go here. I'm going to say try for yourself, and I want you to see this because you're going to have to know how to read expressions later in the class. They're saying that an integer x is a value of 10. Let's make this bigger. Integer y is a value of 9. The system should print out. It should print basically what happens when x is x greater than y. It returns true. That's what it should do because 10 is greater than 9. So if you run this code here, it should basically return true. It already ran it already, but it's basically going to return true. Why? Because 10 is greater than 9. Is this a true or false? Yes or no? You see, if I go in here and I change this to, let's say this is 8, and I run this, well, is 8 greater than 9? You'll see in a second here, this always takes a while because the website just gets a lot of codes. False. 8 is not greater than 9. But the number 15, that's greater than 9, so that should be true. The point of this exercise is that you notice in the Boolean expression there can only be one or two outputs. Either it's true or it's going to be false. That's all this thing does. It's either on or it's off. Is the system on or is the system off? That's all I need you to know for your exam. You don't need to go and type Java codes in here, although you need to know how to read some simple scripting coming up later in the class. And if you enjoyed this one, keep going. I'll see you next video. In this video, I'm going to be covering some basic terminology with you when it comes to using a computer. So the 4 terms that we're going to be covering is input, processing, output, and storage. Know the definitions for your exam. Let's get into it. So when you give data to a computer, that is called input. Input is when you sit on a keyboard and you type stuff in, more than likely. It can also be importing documents or importing data from another system, such as a company upgrading a database to a brand new one, so they would import data from the old database to the new one. So it's when you give or input data into a system. What does a computer do with the data? Well, it has to process the data into a format that it can understand, and then it will store that data and output that data. So it inputs it, it processes it, and it outputs it, and then it stores it. So the way this works is, let's say you have a document. You open up a document, like I'm about to do right now. You open up a document. So let's open up Notepad. We give it some input. So this is my text. And what I'm going to do now is that I am going to output it. Now, before it can output it, it had to process my inputs to know the letters I'm typing. Remember those ASCII things we covered earlier? It processed the keyboard keys that I used, and it outputted the text on the screen. Now, I'm going to output it into a physical paper. That's why I have this printer here that's not installed. So if I did have my HP LaserJet installed, I would click on my printer, I would say print. Now, I'm pretty sure you guys have all printed something before. So that would be more of like a physical output. If not, the output is just displaying it on the screen. When I'm done, I want to store this data. So I would go to File, Save As, and let's say I store it on my desktop as just the word doc. Okay, so by doing that, it should appear on my desktop right here. So with that in mind, now I'm storing the data on the hard drive. So just to do a quick recap, we have when you type data into a computer, it's called input in. When the computer gets it, it processes the data, then it outputs it. You can output it to a screen, you can output it to a printer that I have here. And then you save it into the computer's memory, such as its hard drive. If you store on a hard drive, it's going to be more of a permanent storage, so you can access the data later on. The most valuable resource that we have on the planet today is time. What do you think I was going to say? Because it is something that is not infinite for our lives anyhow. But the second most valuable resource on the planet, it's not gold, it's not money or currency. It is known as data. Data is the most valuable human-created commodity that exists in today's world. A company is worth what its data is worth. A company makes decisions based on its data. And that's what I want to talk about in this video and coming up in the next video of how to secure it. So one of the things we want to understand is that data and information are assets to a business. And information like what? Well, for example, let's say you go to Amazon and you purchase something. Your name, your address, your ability to be contacted and sold to, your contact information, what is known as your PII, your privately identifiable info, is an asset to Amazon because they can potentially sell something to you. The analytics or the data that's being analyzed by Amazon of how you purchase and what to be sold to you is also an asset to Amazon. Amazon values this data. A list of customers and their privately contact info like emails and phone number is an asset that can be sold and companies value it. The secret information of how a company builds its particular products or redesign a product is an asset and it has a big value to them. Imagine if all the secret codes got out behind how Windows works, like the source code to Windows. That would destroy pretty much all of Microsoft. So data and information are assets. Companies invest tons and tons, billions of dollars every year spent by major businesses in order to secure data from being breached. I'm pretty sure you've heard on the news about data breaches. I'm pretty sure you've heard, oh, this company was hacked and the data of all the employees were stolen, their names, their social security numbers, their credit card data. This is going to be massive data breaches that cost companies millions of dollars that they lose. You may have heard of something called ransomware. If you ever heard of that before, that's when hackers come in and lock up or steal the data and then hold the company ransom to give it back to them or not to release it to the public. And they end up spending millions of dollars on paying hackers. One of the things that I want to talk about in this one, when you're thinking of just data, there is something we call digital products. What are digital products? Well, digital products are basically not tangible, not like a physical product like this phone or this cup that can be sold. That reminds me, let me take a drink. Coffee, the essence of life. Digital products are basically things that you purchase that is stored in a digital format. Like what? Well, if you download an ebook, that's a digital product. Music. If you're listening to Spotify, internet radio, internet television, so these are all considered different forms of digital product. Now, anything that you go out and you purchase on the internet that's sent to you in a digital ones and zeros or binary format is considered some form of digital product. And companies sell that. In fact, here at TIA, we make quite a lot of money from our digital products. This is going to be all the digital courses that we sell on platforms such as Udemy or selling it through our own websites. It's just an e-learning course that you watch. So it's a digital product. The other term I want you to know for your exam is what's called data-driven business decisions. What this is that it's using facts, metrics, and data to guide strategic decisions that would align with your goals, objectives, and initiatives. So what do I mean by that? Well, let's talk about this a little bit. In a business, decisions has to be made. When do we redesign a product? Do we make a brand new product? Do we redesign the current product? Is our marketing strategies working? Should we increase marketing budget? Should we lower marketing budget? Should we hire more people? Should we fire more people? Anytime a business makes decision, are they making an educated decision based on good data? For example, if they released a product into the market space and it used to sell very well and now it's slowed down. Why did it slow down? Is it because customers don't like it anymore? It's starting to malfunction? Is it because there's a new competitor in the space and it's taken away your sales? What's causing people not to purchase the product? That's a decision that has to be made. What are we going to do? Are we going to redesign the product and fix the problems that we have? Or are we going to make a brand new product to compete with a competitor? But before we make this decision, we got to know what the hell is happening. Is it the product is bad? Is it new competitor? Well, we have to grab data. We have to go out and we have to speak to the customers and obtain the data from the customers. We have to do research and obtain data on new competitors in the market space. This is called data-driven business decisions. It's going to be using all types of facts that are out there, metrics such as measuring customer satisfaction, and then make a business decision. Now, the other part here we want to look at is data capturing. How does it capture the data? Well, if it wants to do it for the customers, it will probably call and talk to them, or maybe send them a survey. It'll collect all of their information. It'll correlate this data into some kind of giant database systems, and then it will produce a report. And the report will say, oh, customers are dissatisfied, or the customers that has it is satisfied, but they're leaving to purchase a new product. So that would be a data business decision. Now, these things are used all over the place, all right? Whether a business is determining how to guide itself because of stock prices and looking at stock charts, if you ever looked at those before, that's using good data to make good business decisions. In today's world of business, guys, data drives all business. The data of our marketing campaign working. The data of what's happening in the stock market. We may have to release employees due to recessions. The data of what's happening with major world pandemic. Is it getting worse? Is it getting better? We're always capturing data. And it's from that data we're going to make decisions in our business of what to do next. When a company creates certain things, whether it's creating a brand new invention, creating a new logo for itself, or even writing manuals internally or writing a book, the company has to be able to protect their quote-unquote intellectual property. Intellectual property are things that are going to be owned by the businesses that they're probably going to be making money off of, and they don't want me or you to steal it from them. For example, imagine the iPhone and the operating system that it is. Imagine some other person just steals it and puts it on their device. Now they're selling something exactly like an iPhone. I don't think Apple would be too happy with that. So we have to find a way to secure our stuff, we should say, And then if anybody ever tries to steal it from us or use it without our permission or not giving us quote unquote feedback or kickback, in other words, we're not making money if they're using our products or our services or our digital products, we're going to sue the hell out of them. And in this video, I'm going to talk of 3 things that organizations do: trademark, copyrights, and patents. Let's get into it. Now you notice I have a book on my desk because I'll get into that in a minute. The first thing here we're going to talk about is going to be a trademark. Now, trademark is going to be a way to register your basically sometimes company names, logos, like this company's name and logo is actually registered with the trademark office. So if somebody comes out and uses Technical Institute of America and then utilizes our logo, as you see there, we can basically take them to court as trying to impersonate us. The ITF logo at the bottom is a trademark logo by CompTIA. If I try to steal it and claim it's mine or make something similar, maybe I make another certification, CompTIA can take me down. So trademarks, when you file a trademark application with the government and you trademark your name, your slogan, your logo, what happens is anybody that utilizes it, you can sue them. You can say, hey, you better stop before I take a lot of money from you. The next one I want to show you is called a copyright. So copyrights protect things such as original works, such as art, literature, or other created works. This is basically going to come out of somebody's mind. This includes pictures, music files, and books. This is where most people know them. This is my study guide. I am the best-selling PMP author currently in the world. This book has sold hundreds of thousands of copies to students around the world. You can actually find this book on Amazon. If you go right now, you type PMP, you'll see this book is the top-selling book. I don't want nobody stealing my book. If somebody wants to steal my book and claim that they're me, well, I'm going to sue them to kingdom come. How so? Well, as you can imagine, I went out and I copyrighted the book. And I want to show you that copyright certificate. What am I doing here? I want to show you this copyright certificate. This is a certificate of registration with the Copyright Office that I filed in 2021. And this is, it says the title of work, see, PMP Exam Prep Simplified. It was completed in January 4, 2021. And it is copyrighted to me, Andrew. Now you know the year I'm born. So I own the copyright to this book. All right. So people should, if they write books, if they create manuals, if they have pictures, should upload that to the Copyright Office. It's really easy. It's like $60 to do this. And basically you own the copyright. Everybody ever wants to take it, you can sue them. Now, the next thing here we're going to talk about is something we call a patent. Now, what is a patent? A patent protects inventions, mostly. Processes, compositions of matter, such as medicine, can be patented. Most technologies, most medicines that you find, most compounds of different types of blends of different things, whether it's making yogurt or it's making the next vaccine, they're all patents. Companies, when they create new inventions of things that they're going to sell, they're going to patent it. Now, patents are valid for about 20 years, I believe, and then it goes into the public market. So let's say I make a brand new invention, all right? Let's say this pen was an invention that I created that writes out of thin air. Like you can go like this and it'll write. That's my invention. I will own this invention for 20 years, and anybody that ever tries to mimic it will have to pay me, or I will sue the hell out of them. After 20 years, it goes into the public domain, and then anyone could make the invention. And you're going to see that you see this a lot with drug makers. When a drug is made, the company that made the drug owns the drug. They have 20 years to sell it as high as they want, as big a price as they want. Because after 20 years, it goes to the public market, and anybody could make the drug. It becomes like then you have those generic brands making the exact same drugs. Copyrights are generally valid for the life of the author plus 80 years. So valid for me, it's 80 or 100 years. It's valid from, you don't need to know this part for your example. I'm just going over that. It's valid for how long I am alive plus, I think, 80 years. Trademarks are valid. You have to renew your trademark about every 10 years. But you can renew them as many times as you like. So that's generally how they're valid. Okay, make sure you're familiar with these terms, because don't be surprised. On the exam, they give you some kind of scenario and they said, oh, what should the company do? Are they going to trademark, copyright, or patent that particular thing? In this video, I'm going to be talking about storage measurements. Now, storage measurements is how we basically measure how we store data. And this is really important for your exam, as you will get a question on it. And the knowledge you're going to learn in this video is knowledge that you're going to be using throughout your entire IT career. Now, what this video is really about is like, so when you pick up something that looks like this and it says 1 TB on it, and you pick up this one here, this one says 200 GB. I know hard to see, but we're going to take a look at these more in depth later. And I pick up this one here and it's like, oh, this one is 128 G. Like, what the hell does all that means? Is which one here, you notice these two drives has the exact same, basically physical dimensions. But this one is 1 TB and this one is 200 GB. What does that mean? How much, is this bigger or is this bigger? We'll find out in this video, and that's what we're trying to take a look at. So let's get into this. I have a slide here of terms that will show up on your test. Number one is the storage units. Now I want to point out something to you. Data, in the world of IT, when you store data, it's stored as bytes. Data is transferred in bits. What is the difference between bits and bytes? Because this is something you're going to hear quite a lot of. So a bit is represented as basically a 1 or a 0, a single character. A single bit is either it's a 1 or a 0. Now that's important to know because a computer reads data as bits. It transfers data as bits. Why? Because your processor is made up of something called transistors. I'm going to get into the hardware section. We'll cover that. And the reason that it reads 1s or 0s or bits is because the 1 tells the transistor to be on or the 0 tells it to be off. So computers read bits. But when we store data in a computer, we store them as a byte. And a byte is basically 8 bits. 8 bits in every byte. So if a bit is 1 or 0, then a byte basically looks like this. It's basically going to be 8 of those bits, any combination of them. So look, I have 1, 2, 3, 4, 5, 6, 7, 8. 8 bits is basically, that's 1 byte. So 8 bits in a byte. Now I want to point out something to you. This is important to know for the real life. Anytime you see data being listed or storage being listed, notice the big B and the little b. On these drives, they'll say, hard to see this, but it says 1 TB with a giant B. Big B, that's a byte. This is 1 terabyte. But sometimes you see in data transfer, and we'll see this in the next video, it'll say 200 megabits per second. Notice that little b. So if you're ever reading something and you notice it'll have the little b, that's considered bits. If it says the big B, it's bytes. Remember that for your exam. The other thing here we want to know is the unit of storage. What does it mean? Well, when somebody says K, it means kilobyte or kilobits. K just means kilo, just means 1,000 of something. Notice this is a big B, so this is 1,000 bytes. So 1 kilobyte is equal to 1,000 bytes. 1 megabyte is equal to 1,000 kilobytes. So a megabyte is 1,000 kilobytes. 1,000 kilobytes is basically 1,000,000 kilobytes. 1 gigabyte is basically 1,000 megabytes. This is also known as a billion, right? Because if you think about it, 1,000 million is a billion. So a gigabyte, if I have 1 gigabyte, I'm basically saying I have 1 billion bytes. A terabyte, well, it's bigger than a gig. It's 1,000 gigabytes. So what comes after a billion? Well, a trillion. So this is going to be a terabyte. So terabyte is 1,000 gigabytes. And then petabytes is really big. Nothing much is going to be stored in this yet. That's 1,000 terabytes also is 1 petabyte. I've never seen a hard drive that big. Okay. So we want to know these conversions well. And on your exam, they may give you something that looks like this to trick you. Watch. They may give you something that says, oh, this is 4 megabytes. How many bits is this? Well, did you get it? Did you say 4 million bits? Nope, because this is 4 million bytes. 4 million bytes has to be times by 8 to get 32 million, not big B, but little b. So I was about to write that big B there. That's 32. So 4 megabytes is 32 million bits. Did you understand that? Why? Because meg is a million. Okay. And so that's 4 million bytes and 8 bits in a byte. So 4 times 8. Let's try one more. Let's say I give you, I don't want to give you too much of big numbers. Let's say 6 kilobytes is how many bits? Well, this is going to be 6,000 bytes times 8 is going to be 48,000 bits. Easy enough. See that? They might give you something like this on your exam. Make sure you know how to do the conversion. Now, I want to switch this up and I want to show you, when you're looking at this in real life, when you look at especially like hard drive storage, because we store data on hard drives. And when we store them on hard drives, we're basically using this bytes thing. And I want to show you when you're looking at these things. Let's take a look at the overhead cam. So I have 3 things here. I have this hard drive and I have this hard drive. So this black one and a blue one. I want you to take a look at this blue one. Now this might be a little difficult to see. And it's a little difficult there to see, but it's really hard to see that. But that says 250 GB. What does that mean? Well, that means that it is 250 gigabytes, right? This one is very easy to see because it just planted right there on the drive. 1 terabyte. See that big B? We know this is byte because that's a big B. This is a memory stick, and this one here has 128 G. So it's 128 gig. They're not going to tell you it's bytes, but this is basically bytes because it's data storage. Now, I asked you guys a question earlier. What has more storage? The 256 GB or the 1 TB? Well, this one, the 1 TB, has 4 times as much storage as this. You would need 4 of these blue drives to equal 1 of this black drive. Why? Because this is 250, and this is basically 1,000. This is 1,000 gigs. This is only 250 gigs, right? Because 1,000 gigs is 1 terabyte. So that's where these becomes important. So now when you're looking at hard drives in today's world, 1 terabyte, cheap. 1 terabyte, this is our old spinner type hard disk drives, and we're going to talk about solid state and hard disk drives later, but 1 terabyte hard disk drive, physical big drives, not solid state, is cheap. 50, 60 bucks, maybe less. I have one on my shelf here that's 8 terabytes. So if you think about it, 8 terabytes. If this is 4 times as much as this, imagine an 8 terabyte, how much more bigger it is than this. And this here was the drive from about 10 years ago. This one is from 5-6 years ago. And the 8 terabyte I just bought. So we got some seriously large storage. Even this memory stick at 128 gigs, it may sound like it's a lot, 128 gigs, but if you're moving like movie files, big movie files, like Blu-ray movie files can be up to like 50 gigs. Pictures, 4K video files can be very, very large. So this 128 is not that big anymore. Even a terabyte is starting to shrink as the media we're consuming starts to, especially when storing like 4K video, very high definition video, I should say. Okay, please review this video again because you're going to need to know these conversions when taking your exam and when working in real life. In this video, I'm going to be talking about something called throughput unit. Now, what is that? Well, throughput unit basically is how we measure the speed of data being transferred. And I got a little setup here. I want to show you what I mean before I actually get into it. Let's go back to the overhead cam. So I want you to take a look at this. This is a sonic wall. Sonic walls are basically, these are going to be devices that basically brings internet to your business. So this would be hooked up to the cable provider's network. And from here, you would connect a network cable. You can see this being connected right here. Network cable. This is a network cable. Pretty long one, actually. Network cable that is then plugged directly into this notebook's network port. Now, you could also connect it wirelessly because this is also a wireless device. So I want you to keep this in mind. So we got this cable that is connected to this wireless router that I have here. Oh, this is also a firewall. And this is going to give this notebook internet. So this notebook has to talk to this device. But how fast does the data coming out of this cable can get in to this sonic wall? Well, I'll give you. It's basically going to be 1 gigabit per second. And we're going to see what that means in this video. You know, anytime you deal with technology, I'm going to put this away here. Anytime you deal with technology, especially when it comes to internet and network technology, you're going to have to know what is called speed. Well, what I mean by speed is data transferring from one device to the other. Just like in that setup where we saw how fast would the notebook transfer data to the actual router. Other settings can be how fast does the notebook transfers data to the actual server on your network. So with this, I have a slide here of some measurements. And this is going to be very similar to what we did in storage units. Hopefully you watched that video. Okay, so throughputs is basically how fast data travels. If anytime you see something that says BPS, it's bit per second. Then we really don't have anything with bit per second. I've never seen something that slow before. When I started in computer world, we started at kbps, kilobits per second. This is 1,000 bits per second that's being transferred. Now, what does that mean? Well, let's say you have a file that's 3,000 bits big. If you have a file that's 3,000 bits and you're transferring it basically 1,000 bits per second, then this should take 3 seconds to do, right? A mega is going to be 1,000 of those kilobits. This is just like before. K, kilo, meg, million, G, giga, T, tera. So Mbps is megabits per second, Gbps is gigabits per second, and TBP is terabits per second. So for example, a gigabit is going to be 1 billion bits per second, and M is going to be 1 million bits per second. In today's world of transfer speeds, on a cable transfers can be anywhere from as slow as 100 megs all the way up to what I'm seeing 10 gigabits is some of the fastest interfaces I've seen on a wired interface. When it comes to wireless, you can go down as slow as 54 megabits on an old school wireless network to the newer wireless networks of a few gigabits per second. So those are going to be considered pretty quick. I've never seen something traverse a network at terabits per second. Even on fiber optic networks, they're going to be a few hundred gigs. So I want you guys to understand the storage speed, all right? Or what we will call the throughput speed of a network. Because whether you're ordering an internet connection, whether you are connecting something to a network, you're going to see something. 1 gigabit connection, 2 gigabit connection, 400 meg connection. You're going to have to see that. In fact, when you go out and you purchase internet, like here I am at Fios, I went to Verizon and I said, hey, I want to purchase Verizon's Fios. They're telling me that, you know what, the speed tiers they have is, let's make this a little bit bigger. The speed tiers that they come in, you can buy 100. So it's 100 up, 100 down. Notice Mbps. What does that mean? Megabits. Notice it's not a byte. If it was a byte, it would be a big B, not a little b, per second. So where this line traverses 1 million ones and zeros per second on this line. Decently fast internet connection. So at my house right now, I'm using a 1 gigabit. So I get 940 megs down Mbps every second. It actually is that fast. It really is that fast. So very, very fast. Okay, so I want you guys to make sure you understand this. Rewatch this video if needed. We will be using those hardware coming up a lot later as we get more into networking gear. I'll see you in the next video. In this video, I want to talk about processing speeds. How do we measure the speed of a computer basically and how fast it can process something? Now, before I actually get into that, I want to show you a processor so you know what the hell I'm talking about. Here I have an older motherboard. Now, whether it's an old motherboard or it's a new motherboard, they basically all look the same. They may have different functions, or one may be faster or slower than the others. But they basically all have the same set of components. And on this motherboard here, I have a processor right here. So I want to take this processor off and I want to show you what exactly does a processor looks like. So here I have a processor and I'm going to go through all of this setup and what processors are and how to remove them, how to identify all these parts in another part of this course. So let me just take this off here and we're going to talk more about, this is an AMD processor. I'm going to take this off. And this is a processor, okay? This little device is what powers up the entire world. When you think of devices or what's important to this world here, is it going to focus? There you go. Is it, when you think of what's important to this world, what makes this world go around right now, this device, everything in your computer will go through this device. And we're going to talk about more of what this does. But in this video, what I want to talk about is how do you rate the speed of this thing? How do we know which one is faster? So when you see multiple of these devices, how do you know, okay, that one is better than this one? And that is measured in what's called hertz. Now, hertz, and put this back here so we don't damage it, as we will need this in other videos. Hertz is known as a frequency of electrical cycles per second. So cycles per second. So if you have a megahertz, a megahertz is basically 1 million cycle per second of this processor. A gigahertz is 1 billion cycle per second. So basically, a gigahertz is 1,000 megahertz. Now, in today's world, in processing, we basically measure them by gigahertz. If you go back to the old days, in the 1990s, like when I got my first computer, it was an old IBM machine in 96, 97, something like that, was 233 megahertz. In today's world, we don't have megahertz anymore. We have gigahertz. So like, I remember by the early 2000s, I was up to a 1.1 or 1 gigahertz Athlon processor. So that was 1,000 megahertz, right? That was 4 times faster than my own machine. Nowadays, the processors are rated at gigahertz, 2 gigahertz, 3 gigahertz, 3.5 gigahertz, 3.7 gigahertz. So when you buy a processor, you're going to see that. You're going to see, let's go to a website here, my favorite hardware website. We're going to do Newegg. So Newegg is my favorite website when it comes to buying hardware. So we're going to go to component and storage. I'm going to go to CPU. And you'll notice whether you're an AMD fan or you're an Intel fan, these are going to be the 2 biggest providers of processors out there. If I scroll down and we start to zoom in and look at them, you'll notice that this is an i9. Very powerful, very brand new processor. But you see it says 3.2 gigahertz. This one is 3.7 gigahertz. This is an i7, 3.6 gigahertz. And you're probably wondering, this one is 3.7, but this here is 3.2. Well, this has a lot of cores. This is 6 cores. This is 16 core. We'll talk about cores coming up later. But cores just mean that it stores many of those gigahertz cycles in there. You notice this one here is an 8 core. All right, this is a 6 core, but notice the gigahertz, once again, 2.5 gigahertz. So the hertz matter. So when you are purchasing a processor, if you want the faster machine, go with the higher hertz. We'll talk about cores later in the class. But if you're comparing a 6-core 2 6-core processors, one is 3 gigahertz, one is 3.5 gigahertz. 3.5 gigahertz is faster. 3.5 is better than 3. Okay, that is how processors are rated in hertz. Remember, in today's world, it's gigahertz. We don't really use megahertz anymore in the world of processing. In this video, I'm going to be going over the CompTIA troubleshooting methodology. This is a seriously hot topic for your exam. Expect 2-3 questions on your exam about this. And all you really have to do is memorize the 8 steps that I'm going to go through and be able to apply them in certain scenarios. For example, one of the steps is identify the problem. The next one is research knowledge base. The next one is establish theory of probable cause. So the question might say, oh, the technician has researched the knowledge base. What should the technician do next? And the answer would be establish a theory of probable cause. They're going to use these exact words on your exam. This topic is covered in A+, it's covered in Network Plus also. And A+, the A+ exam actually has pretty much exact same questions. So just studying here, you're going to use it later. And you're going to use it in real life when you're actually trying to solve a problem for a user. Let's get into it. I'm going to go through all 8 steps. If you have the CompTIA objectives, you can follow along with me. Of course, you'll have the slides too. So the first step. All right, so here's a scenario. A user calls up and the user says, Andrew, there is no internet on my computer. What can I do? Well, let's see. The first thing we're going to want to do is we're going to do what? We're going to want to identify that problem. We're going to want to gather as much information about this problem as possible. All right. And by doing that, we may ask, can you duplicate the problem? Can you go to Yahoo? Maybe they can take out their phone and take a picture of their computer and text it to you. Remember, they can't send it because the computer is dead over email, but they can duplicate the problem so you could see, okay, this machine really has no internet. It can't even go to Yahoo. Question the user, such as asking, has anything changed on this machine? Did anybody install new software? Was any new hardware added to the machine? Identify the symptoms, such as, okay, they can't get to a network drive, they can't get to the internet, or maybe they can get to the network drive, but they can't get to the internet. All of these would matter. Approach multiple problems individually. If the computer has multiple issues, what if it has no internet, but it has pop-ups? It could be it could be the cable is out and the machine has a virus, or it could be the virus disabling the internet. Approach each problem individually because you don't know if one is causing the other. Okay, the first thing we want to do is identify that problem. Okay, the computer has no internet. The next thing you want to do is research your knowledge base, internet if probable, if acceptable. So what this means is the best knowledge base is Google. If you ever have a problem with your computer, the best thing you can do is go to Google and put the error in there. Put computer has no internet. Internet not working. Map drive not functioning. If you ever get an error code on your machine, what I do is I just Google the damn error code and somebody fixed it at some point and you'll get it from there. A lot of times the manufacturer like Microsoft actually comes out with a fix and they'll just post a fix for you and you can basically install it right there. The next thing is establish the theory of probable cause. So you go to the internet, you see what people said about it, you've been through the Microsoft knowledge base, you saw that, okay, these are ways to fix it. Then you come up, probable cause, okay, what's causing it? Okay, maybe it could be the cable is bad. It could be the internet is actually down in the office. It could be the local switch is not working. It could be the router has some kind of block on it. It could be the computer has some kind of virus. You have to question the obvious, all right? Consider multiple approaches. Maybe we'll check the cable. Maybe we'll check the switch. We'll check the router. Divide them into problems and then go through them one by one, or divide and conquer. So establish their probable cause. Maybe we'll say, maybe the probable cause here is that the cable may not be working. So that's my theory. Now we got to test the theory. If you're doing your theory, you determine, okay, everything on the internet works. Everybody has internet, so it's not the internet connection. Everybody has connection to the server, so it's not a network connection. It's something on the machine, something local to the machine. Maybe the person kicked the cable out, right? So test the theory. Once the theory is confirmed, you confirm the root cause. Maybe the cable is out. Determine the next step to resolve the problem. So test the theory. Unplug the cable. All right. Plug in a brand new cable and see, okay, is this the way to fix it? If the theory is not confirmed, establish a new theory. So maybe you change the cable and the internet is still dead. Maybe it's malware then. Step 5, establish a plan to resolve the problem, identify its potential effects. So if you change the cable and it works, then you're good. Then you know what to do. Your plan of action is to permanently throw that old cable out. Maybe something's wrong with the head. Maybe somebody broke the cable somewhere. Maybe a rat bit it in the wall. Something happens. I've seen that before. Throw the cable out, replace the cable. So this is what you're doing. Your plan is to replace the cable, throw out the old one. You're going to implement the solution of replacing the cable. Now, sometimes you may have to escalate it. Sometimes, not all the time, you may have to escalate your problem upwards the ladder. Sometimes it may be, what if the problem was with the switch or the router? Well, if you're a level 1 technician, you don't have access to fix that. You may need to call the level 3 help desk or systems admin or network administrators to fix your routers and your servers and so on. So you may have to escalate it. Once you change the cable, you're going to verify the full system functionality and implement any preventive measures. So plug in a cable, make sure it works. And then you got to say, well, maybe he kicked the cable out. A preventive measure would be to tuck the cable in the back of the machine, hide the cable so the cable is not on the floor so the user can kick it out. Maybe the user kicked the cable so many times it broke part of the head off. So put in preventive measures. So if you believe there was a user that broke the cable, then put in ways so the user doesn't do that. You're going to want to document your finding, your lessons learned, and put it. A lot of organizations have knowledge bases where you would, where you're actually going to put it into a what's called knowledge management systems or KMSs. So they have these internal databases that you store. Oh, I had this problem. This is how I fixed it. Why do we do this? Well, because when people later on, other technicians gets the same problem, someone else going through your knowledge base is going to be able to fix it. So that's why they have document your findings. The last thing you do on your exam, this is one of the most common mistakes, is people select this as what to do next. Document your finding. Okay, identify the problem. What do you do next? Document your finding. Wrong. Document your finding. Lesson learned comes all the way at the end after the problem has been resolved. You have shown the user that the problem is resolved. The user is happy. You're walking away. The ticket's basically closed. It's about to be closed. You're going to go in there. You're going to document it, put it into the company's knowledge base. Okay, let's do a quick review before I leave. Number one, identify the problem. You're going to question the user. You're going to find out if anything changed. Number two, you're going to do some research on the problem you just discovered. Look at the internet. Research knowledge bases. Maybe you have internal knowledge bases. Maybe you can look at the manufacturer's website. Tell yourself, establish a theory of probable cause. Tell yourself, this is what may be causing it. Okay? If I unplug cables, this is what happens. If there's a virus, this may be what, this could cause it. Then test the theory. All right? You can unplug a cable from another machine to see if that really does something similar. All right? You can pull in and replace the cable or tell the user to jiggle the cable a little bit. So test the theory. Is it actually that? If you realize, okay, that's probably going to be it, then establish a plan of action to resolve the problem. Implement fixing, putting in the cable. Implement your solution. Number 6. Number 7, verify full system functionality. Make sure everything works. Make sure all the internet works. Make sure the map drive works. And number 8, document your finding, your lessons learned. Okay, please review this video. Memorize. It's not going to be complex. If you memorize the 8 steps here, you're golden. You're going to be able to answer any of these questions because it's not that difficult to answer these questions. And we've all dealt with problems in our computers, and we should be following these steps when solving problems. In this video, I'm going to be talking about wired and wireless networking. Let's get started. So why do you want to set up a network, right? What exactly is a network? Well, by definition, a network is basically taking 2 computers or more and allowing them to share, quote unquote, resources. What is resources? Well, resources defined as things that they share, such as data or devices. Like you could share a printer, or you could share those pictures between one user and another. You could share text documents or Word files or PowerPoint information. When you share information across the internet, it's a giant network. When you share pictures in your house with your friends and your family, it's a network. So we set up network to share resources. So a network is a really simple thing. Here I have a laptop. If I take my other laptop and I take a cable, okay, and I connect one end of this cable to this switch. Now this is more than a switch, by the way. I know it's a firewall, it's a router, it's a switch, but it is a switch. You connect this switch, and then you connect it to the back of this machine. Then you take this cable, take another one like this, connect it to another port, and then you connect it to the back of this laptop, or the side of it, I should say. Now you would have these 2 laptops connected through this switch. And through this switch, we're going to allow this laptop to communicate to this laptop using a wire. That would be considered a wired network. Now, the other way to do it, instead of having all these crazy wires, is to connect them using wireless networking. So this is a wireless access point also, but it does allow you to connect wired to. So if I go into this access point and I configure it, and then I configure this laptop to join the access point, configure this laptop to join the access point, this would be considered wireless communication or wireless network. This is probably what you have at your house now that you're listening to me. By the way, if you're a gamer and you're playing games right now, you need that low ping rate, we should say, make sure it's wired. I always, in anything that's mission critical, I always use wire network. And in my house, most of it is wired. I'm not a fan of wireless because it's not very predictable. So we'll cover that in another video in this course. We're going to talk about how to set up wireless networking. So that's what we need to know. Today we need to talk about wired and versus wireless networking. Now, I do want to take a look at a slide here. So you'll notice that CompTIA gave us some exam objectives. We're going to talk about wired networking right now, old telephone connectors and Ethernet connectors. We need to know what they are. We're going to talk about wireless networking, which I covered a little bit, and then we're going to talk about Bluetooth and NFCs and see what those are. Let's get back to this. So with the wired networking, most 99% of the connections within your wired network, whether it's at home, whether it's at work, if something is connected into the one, that's how you get network connections, such as internet or access to those servers. You're basically going to be using Ethernet. So Ethernet is the standard of the networking. I'm not going to get into all of that because not for your exam, but in Network Plus will cover that. So I'm going to go back here to my overhead cam, and I do want to show you guys. Let's get this out of the way here. I do want to show you guys the actual wired connection. I did drop that cable. Let's pick it up. All right, so let's take a look at this. So when you want to connect device wired network, and you're basically going to use a cable like this. This is called an Ethernet cable. And Ethernet cable comes with a head or a connector we call an RJ45. An RJ45 is a standard connector. You're going to use this on almost all Ethernet cables. This is going to be for you geeks out there, Cat 5, Cat 6, and so on. Will you utilize this connector? This connector is what will allow me to plug in to the switch here. You can hear it click there, and then be able to plug it in to my laptop that still has a NIC card. Now, most laptops don't anymore. They actually don't come with NIC card. This is an older laptop. And plug it in here. So this one will be wiredly connected. A lot of laptops doesn't come wired anymore. A lot of them are just pure wireless now. So like this laptop here, this black one, it only supports wireless. Okay, the other thing I wanted to mention here is an older telephone networking. So here I have an old telephone, a VTech telephone that I found lying around. And connected to the telephone is a telephone cable. The connector on the telephone cable, this is known as an RJ11. And an RJ11 versus, where is that? An RJ45. So an RJ11 is actually, the connector is actually the same height. People think it's why it's not taller. No, it's pretty much the same height. Where it's different is the width. You can see, I don't know how much more you can see that, but the RJ45 is a much wider, it has more pairs in here than the RJ11. So the RJ45 is just supports more cables. This one supports less cables inside of what we call pairs. Inside of here are copper cables, by the way. So what I want you to know for your exam is RJ11 telephone cables. It's physically smaller than the RJ45, which is used in data networking. This is mostly used in old analog phone network. And they're probably saying, do we still need to know this for exam? The answer is yes. A lot of people, what people don't understand is this is still used. In fact, this is still covered on your current newest A+ exam, because you see, in rural areas where they don't have high-speed cable internet, in which case they ran cable lines from the cable providers to the houses there, they still have telephone cables. Telephone cable is widely used. And in order to get high-speed internet across telephone networking, you use what's called a digital subscriber line, or DSL internet, DSL lines. DSL, when you have a DSL modem, you're still going to need one of these cables to connect that. So people A lot of people in the United States, even in 2022, still uses DSL, and they still use an RJ11 cable. That's why it's still mentioned on your exam. Okay, so no, let's get this all off the desk here. No, the RJ11 versus RJ45. Now, the next thing we're talking about is going to be wireless. So wireless networking, I forgot to get back my wire out of here. You're connected right now to a wireless network. Maybe you're watching over your wireless network at home. Okay, this is known as an 802.11 wireless network, computer network. You're connected to a device, something looking like this. It probably have a bunch of antennas called an access point. And what it does is that it allows you to connect to this and share data across this device. So the internet is coming in here, and all the wireless devices are connected. You can all share data going through this device. Now, later on in the class, I'm going to go through a whole section on how to configure wireless networking. The other two I want to mention is Bluetooth. Okay? Bluetooth. Bluetooth is incredibly famous for things such as Bluetooth headsets. Everybody has one of those, right? You have a Bluetooth headset like an Apple AirPod or something like that. But Bluetooth is not just for music or connecting to music like a headset to your phone. Bluetooth is also going to be used for mouses. So here I have a Bluetooth mouse, and you can see this is my good old-fashioned Bluetooth. You can literally see it's blinking blue there. You'll know Bluetooth devices. Bluetooth device has a symbol. It looks like a line with a couple lines or X's going through it. Really hard to see that, but you can see it somewhere there. See it? See right there? So you can know it's a Bluetooth device. Now, Bluetooth is very good to use. It has a good distance. It's about 30 feet distance going around the device. So, you know, this mouse could work from across the room and still connect to this computer. So Bluetooth mouse. But remember, Bluetooth again, headsets, mouses, keyboards are done using Bluetooth. You can get into your car, take your phone, pair your phone to transfer music from your phone to your car infotainment system, utilizing Bluetooth. It's used there, popular too. Now, the other one I want to mention is something that maybe you haven't heard of. And I'm pretty sure you guys have all paired your Bluetooth devices together. The other one I want to mention is something called NFC, or near field communication. So near field communication is what you use in mobile payments. Near field communication is a type of a small near field. Actually means that there's a small distance. So let's say this is a reader, this is the device. It can't be more than 4 inches. It's about 10 centimeters, so it's about this much. What that means is that the two devices has to be really close to each other for them to communicate. Versus Bluetooth, the device can be 30 feet away. So let's say this mouse is controlling data on this phone. It could be upwards of 30 feet away before we lose connectivity. Versus near field communication, the device has to be very close. Near field communication, where do we use this? We use this in paying with credit cards on your phone. I'll show you guys something. I'm going to log into my Android phone here, okay? And I'm going to look at some of the settings on it. So where is my overhead cam? So look at my Android phone here. And in here, I'm going to swipe it. And you notice I have this icon right here that says NFC. See that? NFC, or near field communication. What exactly is that? Yes, I know. It's 11:15 in the night. I record videos very late. NFC, near field communications. So when this is turned on, what I can do is I can now go and set up like Google's digital wallet. So if you have Apple Pay, you would set it up on your Apple phone. You'd enable the NFC. So when I go to a restaurant, a grocery store somewhere, 7-Eleven to get some coffee, and I want to pay, I just enable my NFC. Boom, I turn it on because I have the credit card set up, and the actual reader itself, the credit card reader where you put your credit, I'm just going to tap it with my phone. The phone has to be, remember, near field. It has to be really close. So it has to be, let's say this is the reader, it has to go very close to the device. It then transfers the credit card information to the device, and boom, I pay. So that's what NFC is. The thing with Bluetooth and NFC is that their NFC is not widely used, but Bluetooth is. And remember for your exam that when you're using Bluetooth, you have to pair the device. Generally, that means you have to go through a searching process, search for the device, and then when you find it, you pair it, and you generally have to put in a code or a pin there to confirm that. Okay, so for this one, I know it's kind of a long video. Wired networking, it's going to be Ethernet or some kind of telephone system. With Ethernet, we're going to use those RJ45s. With the old telephone system, we're going to use RJ11. Wireless networking, we're going to cover 802.11 wireless computer networking in another video. But don't forget, Bluetooth gives you a good range of distance between devices, and it's used in a variety of devices. NFC is mostly just used for now, most of the time in just payment systems or paying with a credit card, and the device has to be very close. So make sure you know these topics because you're going to be seeing some questions on your exam about this. In this video, we're going to be talking about peripheral devices and basically how we connect them. This whole video is about what can we use to connect different devices to our computers. For example, what can I use to connect this mouse that I have that's really tied down to the desk there to my actual computer? I have a drawing tablet. What can I use to connect my tablet to my computer? My keyboard, my camera, my webcam, my microphone. What port can we use? Now, if you're saying USB, you're absolutely right because that is the quote-unquote universal serial bus. So CompTIA does give us some things that I want to mention in this video on this. The first thing up is USB. We're going to cover USB in depth. The good thing is, for this exam, you don't need to go into the different types of USB, like USB 1.0, 2.0, 3.0, and all the different micro, mini, USB-C connectors and so on. You don't need to know that for this exam. But what you do need to know is what's USB used for. It's used to connect a variety of different devices to your actual computer. And there's others. You know, most people know USB, but there's others. There's Firewire, there's Thunderbolt. We talked with Bluetooth already. And then we'll talk about something called RF, or radio frequency connectors. Let's get into it as I have a bunch of equipment here that I want to show you what these connectors are. Now, the first one is going to be USB. The Universal Serial Bus. This is basically a connector on your computer that you're basically going to plug almost everything into. In fact, when you don't have enough of them, ports on your computer, you buy a hub. USB buses can generally support about 127 devices if you put USB hubs, which is you connect a hub to it and then you get more ports. Now, USB. Let's take a look. So on the overhead cam here, I have my laptop, and your laptop, and of course your desktop, the back of your desktop, will come with USB ports. So you can see I have one right here. This is a normal USB port. You also have what's called, this is also a USB port, but this is what is known as a USB-C port. So they do come in different sizes and form factors, we should say. But for your exam, just know you can plug a lot of things in here. Whatever you want to plug in a mouse, you want to plug in a keyboard, you want to plug in a webcam, all of that will be plugged in to your USB. Almost everything that's purchased is connected to USBs. The other one I want to mention is something called a Thunderbolt port. Now, Thunderbolt ports basically compete with USB. You find them a lot on Mac, not so much so on Windows, although some Windows has. This laptop I'm using actually has, overhead cam, actually has a Thunderbolt port right here. You see this port here? That's a Thunderbolt port. Now you're probably saying, Andrew, how the hell did you know that was a Thunderbolt port? Well, if you look right there, you can see the Thunderbolt symbol. This is a Thunderbolt 3 port. It shares the same form factor as this USB-C. If you're looking at this and you're looking at this, you're like, hey, aren't those the same? Yeah, they say they share the same port, but this is a Thunderbolt USB 3.0 port. Other Thunderbolt ports that you have, you find them a lot on Apple machines. So I actually got a Mac here. See, for those of you guys that are going to say I'm an Apple hater, that is not true. I have a whole Mac right here. This is an iMac that we're going to be taking a look at a little bit, mostly in the A+ class. I showed them how to configure a Mac in this, so I have it. But on the back of this very heavy device, actually it's not that heavy, it's just that I'm old and my shoulders are bad. On the back of this device, we have a bunch of ports here. And I want to show you the Thunderbolt port on this one. Let's go back to the overhead cam here. And you'll notice that in the back of this one, we have a bunch of USB ports, quite a lot. This is the symbol for the USB port. You also have, notice these bolts of lightning. These are going to be the original Thunderbolt ports, because they share the same form factor, what's known as the old style display ports that Mac used to have. And you have an old, you can put an Ethernet cable in here so you can wire connection this machine. All right, that was pretty heavy. Let's put that back. So Thunderbolt ports you use to connect. I've seen a lot of people using them to connect external hard drives. Something we'll look at in another video, but that's where a lot of people use them to connect to. The other topic on this list was Bluetooth, which we covered already in the previous video. The other one I didn't cover that's a wireless connector is called RF, or radio frequency. Now you're saying, because people use that? You use it all the time. All the time you're using RF connectors. You probably just never thought about it, but here I have a cable box, a FiOS cable box. Verizon right here. FiOS, actually, it says right there. All right. So you're probably saying, RF? Yes, you use RF for this, because in order to control this device, you need a remote control, right? Remote control. This cable box is being controlled with this remote control, utilizing RF right here. So we'll go back here. You see this right here? This is the RF connector. And when the remote wants to talk to the cable box, the remote also has the RF connector. Now, RF connector needs a line of sight. So if this is pointed this way and the control is pointed this way, it's not going to talk. The control has to be pointed towards the device, like this, for them to work. Now, they can have a good set of distance between them, but the devices has to be pointed to each other for it to work. That's different than how you would have Bluetooth. When you have Bluetooth, you don't need that direct line of sight. But if you use an RF connector, you're going to need that direct line of sight. The one thing here I didn't show you, because I don't have a device for it, is something called FireWire. FireWire is a much older standard. I haven't seen FireWire in a minute. Okay? Like, I haven't seen it in a while. So in order to show you the connector of FireWire, I went out and I got a Wikipedia article on it. So just Google FireWire, see? It's known as the IEEE 1394 FireWire. And FireWire, this is a FireWire 800. This becomes one of the last development of FireWire. This is what the cable looks like. So the connector is what this would plug into. And on here, we'll see a picture of what FireWire looks like. So this is FireWire on a computer. This is what that cable would plug into. FireWire was mostly used, especially a lot for external hard drives. If you have an external hard drive, you wanted to connect to the machine and transfer data really fast, FireWire is one of your better options. FireWire was, when it came out, was faster than USB. So if you had a USB drive, it would take forever to transfer data. But if you have a FireWire, it would transfer at 800 megs or 400 megs very, very fast. Versus USB was, when it first came out, it was 12 megs, really slow. But as USB got faster and faster, you got 3 gigabit USB 3.0 now. So it's very, very fast. And as USB got faster, FireWire basically died. I haven't seen FireWire in forever. Now, Thunderbolt is getting faster. It competes with USB. You'll see some of your Apple devices has it. You notice this laptop is about a year old. This has a Thunderbolt port and it has USB ports on it. RF, Bluetooth, we talked about, it's going to be used for things like your mouses, your keyboard, your headset. And then RF is basically used on remote control. Back in the days, they used to have RF on computers to transfer data between mobile devices and computers. I haven't seen that in about 15 years, but it was there. Well, I did have a laptop with it. All right, so make sure you know how these peripheral devices are connecting to computers. In this video, I'm going to be going over graphic device interfaces. In this video, we're going to talk about the different interfaces that we're going to be using to connect our computers, basically to our monitors, or maybe connect your computer to your TV. There's a variety of different interfaces we can use to accomplish this, and we need to know those for our exam. So the exam says that we need to know what are VGAs, or at least be able to identify them. That's called Video Graphics Array, HDMI High Definition Media Interface, DVI or Digital Visual Interface, and DisplayPort and Mini DisplayPort. Or basically just say DisplayPort. So let's get into it. So I'm going to actually show you some of these interfaces that are out there. So we have them, I basically have them all on here. on my desk and around me. It's got a whole bunch of hardware around me. This section of the course drives me crazy as I have to go through all the hardware with you. Okay, so I got a monitor, big monitor right here. All right, I got a big monitor right here that I want to tell you guys how are we going to connect this monitor to this desktop. Now this monitor in the back of it has a port, a blue port. This port is known as a VGA. What I'm going to do is I'm going to get a very, believe me or not, guys, this is the shortest one I have in the entire house here. A very long VGA cable. I will connect it to the port on the back of this computer monitor, and then I'm going to connect it to the back of this desktop. So what I want to do is I want to get on the overhead cam here, and I really want to show you guys the back of the machines. So let's go, and this monitor is giant. It's the smallest monitor I have that's available in the house. So we'll take a look at the overhead cam. As you can see, you're just looking at a computer there. But let's take a look at this. So we got a big old-fashioned desktop. And in this desktop, you have a variety of interfaces that you can use to connect monitors to. And one of them is going to be right here. This is a VGA, Video Graphics Array. So you can connect this to the monitor. You take that cable I just showed you, you connect it right here, and then you plug that in to the back of the monitor. Let's see if I can get this over here. Right there. See that DV says D sub, you would connect that right to the back of this monitor, and you are doing super, and you are okay with that. So that would be what we consider a VGA. So VGAs were really popular back in, since I started IT, I've been connecting with VGA. VGA supports good graphics. It's about up to 1080p on your display. It's not going to give you a high or the best quality display, but it's still pretty decent. And it's still used quite a lot in a lot of connectors. The other one I want to mention in here, guys, is going to be HDMI. Now, let's talk about HDMI because it deserves to be talked about. HDMI is the most famous connector you're going to have on the back of a computer to connect to a monitor. HDMI, it's very unique. Out of all of the where's my slide? Of all of the connectors that is listed here, VGA, HDMI, DVI, DisplayPort, it's the only one that can pass sound, digital sound. So back in the days, we used to connect computers with, especially DVI was very popular, and DisplayPort was getting popular, and TVs mostly used HDMI. But as time went on and on and on, HDMI became more and more popular because it was you could pass sound. You don't need a separate connector to connect your speakers. And it went from the TV world into the IT world. And nowadays, basically, it's one of the only ports we use. Nowadays, when you're connecting something to a computer, to a monitor, you're probably only going to use HDMI or a display port. Very rarely you're going to still use that VGA, although a lot of monitors and a lot still comes on a lot. This is a brand new monitor, by the way. It still comes, oops, am I showing you the right one? It still comes with that VGA port. It's a brand new monitor that we have. Okay, so I want to show you guys HDMI. Now HDMI, let's go back to the overhead cam here. So HDMI, does this computer have an HDMI? It better have an HDMI. So here is the HDMI, and you can see it right around, somewhere around here. Here we go. That is the HDMI port right there. All right. So the HDMI port on that would plug in using what's called an HDMI cable. And the HDMI cable, you can see the head of it. You can see the screen. This is what an HDMI cable looks like. Basically what the head looks like on an HDMI cable, and it will just plug in. You plug one end of this to your monitor, one end of this to your desktop, or even your laptop has these types of connectors on them. So HDMI, remember, is you're going to use this a lot. That allows you to pass sound, different than the rest of them. The next one we're going to talk about, guys, is going to be what is known as a DVI. DVI ports are not very popular anymore. A lot of video cards that are coming out, a lot of computers don't have DVIs anymore. Back in the days, it wasn't uncommon to have just VGA and then DVI. But nowadays, you don't really find DVIs. Almost all computers are made with HDMI and maybe a VGA you get. So let's take a look at a DVI connector. So a DVI, we don't need that. DVI connector on the back of this very big desktop is the white one. Okay, so that's going to be that one right there. All right, so you can see that the DVI port is bigger than your VGA port, much bigger than your HDMI port, and it does allow for digital video versus VGA were more of your analog video signals. So this was a DVI port. All right. Now, in today's world, guys, you're going to find a lot of machines with display ports. All right. A lot of video cards, a lot of computers coming out the factories. If you have gaming cards, because DisplayPort is going to give you a very high resolution, as high as you're going to get with an HDMI. Now, this monitor does not support DisplayPort. Your higher end or bigger, larger screen monitors will. So I'm going to put this on the ground here. We don't need, this desktop does not have a DisplayPort. But what I want to show you in this video is going to be, I think I forgot to switch myself there. All right, I'm not redoing this video, okay? Don't ask, because dealing with these hardware is driving me crazy. To show you a DisplayPort, hopefully you guys were listening. To show you a DisplayPort, I have a video card. And on this video card, in this anti-static bag, lies a video card. Now, in another video, we're going to be doing computer hardware. But in here is my video card. This is actually one of my older video cards I used to have on my computer. This is a video card, and this is what you're in your desktop. You give it a big desktop. This is what you're going to plug in. This is what you're going to see on this outside of the machine. This is what you're going to plug your monitor into. And this particular one had supported quite a lot. In this particular one, it had supported 4 different monitors. And of course, this was used to play video games, so it was really good graphics. So you had 2 DVI ports. This is DVI, this is a DVI. Come on, focus, camera, focus. I'm never going to get this to focus because that's my luck. Ah, here you go. So these were DVI ports that we had on here. Notice an HDMI, but look at this one. It looks very similar to an HDMI, except it's wider. That's known as a DisplayPort. Now, again, I don't have the cable for it. This monitor is connected. I didn't want to disconnect it, but DisplayPort is still pretty popular. I do connect quite a lot of monitors on there. Not uncommon today for your higher monitors support just HDMI and DisplayPort and don't have any VGA on it. Okay, so we're going to talk more about this device coming up a little bit later when we talk about video cards and so on. But when it comes to monitor connections, there's quite a lot out there. There's also another one called a mini DisplayPort, which is basically a DisplayPort, but the connector is just smaller. All right, for your exam, I want you guys to remember, how do we connect to our computer? You could use a VGA connector, older style VGA connector. In A+, we'll talk more about this. We'll have to know the pins inside of them. HDMI allows you to transfer the video and the sound. DVI gives you good digital video. DisplayPort is very good. It allows high resolution. It's still being used popular today, and so is a mini DisplayPort. In this video, we're going to be talking about a variety of different peripheral devices that you can connect to a laptop or a desktop. And I got a bunch of them. Now, some of them are pretty easy and common. You're already familiar with, like keyboard and mouse. And some of them maybe you've never seen before. Let's get into it. So the first thing I have is a printer. Now, printers, you saw I had a big laser printer on my desk at some point. Printers are generally going to be connected to a computer using a USB port. Back in the days, they used to have something called a parallel port that we used to connect printers, but I haven't seen one of those in over 10 years. But most of the time, you get a printer, you're going to plug it directly into the computer using a USB cable. The other one are scanners. Now scanners, a lot of devices nowadays comes with both all-in-one devices. A scanner is where you put the paper on, it scans the document or the image, and then you could see it in your computer or a picture. Scanners are also going to be plugged into a computer using USB. Keyboard and a mouse. Now keyboard and mouse is unique because although we know them to be USB, or you can use infrared or Bluetooth wireless keyboard and mouses, back in the days they used to have an old connector called a PS2. PS2 connectors are still showing up on computers today. And for that reason, I have the desktop on the ground. I want to show you a PS2 port. So let me grab it. So I don't want to keep the computer on my desk because it just takes up whatever little space I have. Let's take a look at the overhead cam here. And you'll notice that now if you see that port that we have there, you see that purple green port, and I can't put my finger there because I'm holding it up. That's a PS2 port. Back in the days, we used to connect keyboards and mouse to that. You would have two of them. One purple and one green, one for the keyboard and one for the mouse. This one is telling you it's a dual port. It does keyboard and mouse. If you notice, it actually shows you a little picture of a keyboard and a mouse there. So those are called PS2 ports. Okay, the other things here, what else do we have here? Cameras. So a lot of times we connect cameras. Here I have a webcam to a computer. And a webcam is basically connected, like everything else. Remember, it's called universal for a reason, because it connects everything. There's another USB port connects into this webcam. We have external hard drive. So an external hard drive. Once again, USB. Here is a Western Digital. This one stores a lot. It's like 10 terabytes or something. Western Digital connects Western Digital external hard drive. I plug it in. I get more storage on the computer. Maybe I could put videos, music on it. This one here, USB also. Very high speed USB, USB 3.0, but a very high speed one. By the way, this is off topic. This is garbage. This is a brand new drive that came out the box a few days ago, and it's dead out the box. The drive doesn't spin. It mounts, but when you try to put anything, it doesn't work. You have to return it. Go figure. Western Digital. I thought it was better. Now, the other thing here I have is going to be speakers and display. Display I covered already in the previous video when we talked about connecting HDMI, DVI, and so on. The other one I have are speakers. Now, speakers, people know them as USB. You could connect speakers through USB, but a lot of time we connect speakers using audio cable or speaker audio cable. And I want to show you that as I have speakers here on the desk. I have some brand new speakers. I don't want to take out the packaging, but you can see they're basically computer speakers, and there's a wire that goes from this one to this one. But in the back of this one is where you would connect to the computer. And in here, there is a jack, and then it comes this cable. This is an audio cable. It's 3.5 millimeter audio cable that I'm going to plug into the back of the speaker, and I'm going to plug it directly into the desktop. Now, the desktop of itself, let me move over this. The desktop of itself is going to have a connector. Let's get that desktop, and I want to show you that. And this desktop has a lot of connectors on it, but this particular desktop, in the back of it, has a lot of cables. See this right here? These are all going to be speaker cables. This one has a surround sound system. You could connect front speakers, back speakers, but basically by using these cables, basically the green one, you'll be able to just get music right out of it, especially these two speakers. This one is a very specialized board. It has a bunch of music connectors on it, like a microphone in, you have your normal music out, you have another line in, and so on and so on. So you have a variety of different front channel, back channel, and so on. On this particular motherboard, let's put that down. You know what happens when you get old? Your shoulder gives out. I have like pain in my shoulders all the time. Getting too old for that. That's why hard to pick those machines up. That's why you young guys are around to do that for me. All right. So we have, hopefully we cover everything here. We have our printers, scanners, keyboard, mouse, camera, external. Basically everything here is going to be connected with a USB except displays. Those are going to have their HDMI ports. But speakers also can be connected with the audio cable I showed you. Printers used to be connected with parallel ports, a long, very old port. Mouse and keyboards used to be connected with older PS2 ports. Okay, know what these devices are for your exam, and I'll see you in the next video. In this video, we're going to be talking about installing the peripheral devices that was covered in previous videos. So when you get a device, such as maybe you got a mouse or a keyboard or speakers, or a webcam that you connect to your computer, sometimes it works and sometimes it doesn't actually work. And you're probably saying, Andrew, how is that possible? Well, because it needs what's called a driver. So let's get into this. So when you connect a device to a computer, in today's world, most of the time it will work. All right, most of the time it just starts working right out of the box. Windows or Mac will say setting up device, and boom, it's ready to go, and you're ready to use it. Like this webcam that I'm using, I didn't do anything. I just plugged it in, and all the applications picked it up. But some devices doesn't. Some devices is not quote unquote plug and play. So plug and play literally means what it says it is. That you plug it in and you start playing with it. You start using it. Some device requires a driver installation. Now, realistically, every single device that we plug into a computer, a mouse, a keyboard, my tablet, my phone, every device that's connected to a computer requires a driver installation. Now, plug and play basically means that Windows found the driver for the device and installed it. A driver is a piece of software that tells the computer how to use that hardware correctly. So if you install a hardware and don't install the correct driver, the hardware may never work correctly or never work at all. For example, if I take this tablet and I don't install the correct drivers, the tablet will never work. I'll never be able to write on the screen with it. If you install, for example, even when you put in any device that plugs into the motherboard, if you put in this big graphic card that I showed you, that I can't find right now, but somewhere over there. If I plug in that big graphics card, I still need to put a driver into it so the operating system knows how to handle that device. So drivers are basically software that tells the computer how to utilize that hardware correctly. That's all it is. And I want to show you that. So let's go to the desktop. Where is it? Oh, desktop. Where am my desktop? Here we go. So here I am at the desktop. Now where you can see your drivers is by right-clicking on your Start button, and we're going to go to Device Manager. This is a Windows 10 box, by the way. So here I am at Device Manager, and these are all the drivers that are installed on the computer itself. If I go here, I can see the different classes of devices. So if I go to Imaging Device, you can see I have this P992 ProStream webcam. So if that's this webcam that I'm holding here. Now if I double click on it and I go to this tab that says, see it says 9, it was streaming webcam. Notice the driver. It tells me it's a Logitech device. It's utilizing the driver version that it downloaded from Logitech is this version. Now this is important because what happens is sometimes Logitech may release a new driver software that basically tell Windows how to use this device more efficiently or adds more features to it. And if you really want the new version, you can just click Update Driver and it can search for it. Or if you downloaded it, you can browse and find it. But this is driver installation. For this exam, you really don't need to go and how to install drivers. Just know that there is such a thing. And where do you get drivers? All right, that's a question. Where do I get drivers from? Drivers are generally gotten from the manufacturer's website. And I'm going to show you that in this video. How do we get a driver? So let's say you have a device that you plugged in, like let's say my tablet. Okay. Now the drivers are already in there, but we'll walk through the steps on how to get it. Let's say you have a tablet, like I have a Wacom tablet. All right. So if I go to the overhead cam and I look at it, you can see it gives me the model number. All right. Kind of hard to see that there. What's the model number there? We got CH, what is that? CTH-480. All right, so it's a Wacom tablet with that number. So what I'm going to do here is I'm going to go, and the best place to gather drivers is from the manufacturer's website. You'll always get the latest driver. So I'm going to go, I'm just going to Google it. I'm going to say Wacom TUOS drivers. Seems like a common search. I'm going to go in here. Okay, it wants me to put this in. It wants me to put in the, you just put the model number in there. CHT-480. We saw was the model number. We are going to search for that. CTH. All right. OCD kicking in there. Nope. Typed that wrong. CTH-480. Yep, you got the pen. It says older one. 23. This is a pretty old tablet. And notice it's driver. Driver for Mac, driver for Windows. So if I want the driver, I would literally say download driver, confirm the download, and here's the driver. So notice the driver is just an executable file. And to install it, I would just click on it, and it would start installing. Okay, so here it is. I would say accept, and it's basically installing the driver for this little device that I have. Now I already had the driver in here, so I'm not sure if I can cancel this. If not, I'll install it later. So drivers, when you're doing driver-based installations, okay, you should get the driver from the latest manufacturer, from the manufacturer of the latest version. Sometimes when you purchase hardware and you try to install it on the machine, it may say install correctly, but it doesn't really work so well because Windows may have an old driver for it. And sometimes Windows just doesn't have a driver at all. You got to go do the step to make it work. Okay, now other ways to install certain hardware. That's going to be utilizing what's called IP-based peripherals or web-based configuration steps. IP-based peripherals are going to be devices that you got to connect through an interface. For example, the other day I went and I bought a door lock, and the door lock is an IP-based. It connects to the wireless network, and I can control the door lock. So I can actually take out my phone and unlock my door right now. Those are going to be called IP-based peripherals. A lot of them are known as IoT, Internet of Things. We'll talk about that in another section. You would have to connect to the web interface and do a web configuration steps. This happens especially when you're configuring things like the wireless router we're going to be configuring later on. Of course, you'll see I have to connect to it on a web interface. And when I'm done, then I actually have to follow some steps to get it set up through a web interface. In other words, there's no driver. It doesn't install on your computer at all. It just stays out on the internet, or it stays on your network. All right, so quite a lot of things there. I really want you to know the driver installation thing. That's something we're going to cover more when you become a technician and you're really doing this work. You're going to have to always get drivers. Sometimes it's easy, you just plug it in and it works, and sometimes you have to go to the manufacturer's website and download the driver. In this video, I'm going to be talking about processors. In particular, the 3 different types of processors that's mentioned on your exam. So there are 3 kinds of processor. You have your ARM processor, your 32 bits, and your 64-bit processors. Now we want to go over those, and you want to understand why you have them and where they're used. So let's get started. The first one we'll talk about is actually ARM processors. Now ARM processors are mostly used in phones, mobile devices, small devices like your thermostat would have them. Your car will have them. Your camera will have them. Your webcam will have them. Almost all computing devices that doesn't carry either an Intel or an AMD processor is probably going to run some kind of an ARM processor. So they're incredibly popular for smaller devices. And I want to show you a list of ARM processors. So if you ever saying, hey, Andrew, is there a lot of these things? Well, here's a list of them that we have here. So I am Wikipedia list of ARM processors. And if you're looking at this, it's just a lot of processors. So this is a Samsung, and the Samsung is using the Snapdragon processor on this particular phone. So this is basically running a ARM processor. All your Apple devices also will run these kinds of ARM processors. I know Apple made a brand new M1 processor, but for now, we'll just go with ARM processor. The other thing that I want to talk about is what's called 32-bit versus 64-bit processors. So when we look at a processor, all right, your CPU in particular, right? So you take this off of here, take this out. This is our processor. Now when you're thinking of a processor, right, you want to say, what is this made of? A processor is made of what's called transistors. Transistors is like a light bulb. It's a mechanical component that basically carries a charge of either a 1 or a 0. Computers reads binary digits. And the reason it reads binary is because processors are 1s and 0s. They're either on or off. Those transistors is either a on or off. The more transistors these chips carry, the more faster they can process, the more 1s and 0s they can intake at any given moment. Nowadays, it's not uncommon to have billions of transistors on a processor. This one probably had millions and millions of transistors on this particular processor. This is an older processor. Now, one thing that we want to talk about when it comes to processors, not just the transistors, but it's also known as the bus width, or 32-bit or 64-bit processors. A 32-bit processor basically means that it can intake up to 32 bits of data at a time, versus a 64-bit can intake 64 bits worth of data. Now this bit matters. You see, a 32-bit processor, for your exam, to put it bluntly, doesn't handle a lot of RAM. If you have an old 32-bit processor, and I have a list of them here, old 32-bit processor like a Pentium 2, really old, even up to Pentium 4s, Pentium Pro. Notice how old these are. If you have some of those older processors on an older machine, then they're only going to be able to handle up to 4 gigs of RAM. Now, if you have a 64-bit processor, 64-bit is exponentially larger. The numbers are too big to talk about in this video, but they're exponentially larger when it comes to the amount of RAM it can hold. Because if you remember from the diagram I gave you, the RAM itself will feed data to the processor. If you have a 32-bit bus here, it can only take in 4 gigs of memory at a time. But if you're basically using a 64-bit processor, which is all modern processors today, almost every processor you're going to buy for the last 15 years or so, Intel AMD processors, they're basically going to be a 64-bit processor. And that means it's going to be able to take data from here and put it into here very fast. It means it supports a lot of RAM. For your exam, just remember, 32-bit versus 64-bit. 64-bit just means it supports a lot of RAM. That's what you need to remember for your exam. Now, not because you have a 64-bit processor means you're going to get 64-bit performance. You're going to be able to utilize all the RAM. You have to make sure your operating system is 64-bit. You have to make sure that the applications are 64-bit. Now, almost all OSs made today are going to be pretty much 64-bit. All your applications pretty much are going to support 64-bit. So if you have an application that is very intensive, like video editing software, and it's a 32-bit, it's not going to utilize all the RAM on the machine. The way to check this, let's go back to my desktop, is we are going to right-click on the Start button. We're going to go up to System. And in here, it says About. Okay, so right now, you notice I'm running i7 processor. I have a lot of RAM, 64 gigs of RAM. And you notice that system type 64-bit operating system, 64x64-bit. If it was a 32, it would be an x86. 32 bits are not known as x32. They're really known as x86. Those are 32-bit nature. So this is a 64-bit processor running on a 64-bit operating. So I could take advantage of 64 gigs of RAM. If I had 64 gigs of RAM installed on the machine, and I had a 32-bit operating system, it would only show 4 gigs here. All right, because the operating system can't take in more. So the bits matter, the 64-bit versus the 32-bit really, really matters on this exam. Okay, make sure you understand that concept for your exam. You should get a question on the exam allowing you to differentiate between 32-bit and 64-bit. Remember, 64-bit just allows more memory on your computer. In this video, I'm going to be talking about GPUs and cooling. How do we keep system components cool? Well, as you can tell, I have a device here, the video card that I explained to you guys earlier. This is a dedicated GPU or video card that we would call it, that would offload the graphics processing instead of having your CPU do it. You have this device. And this device runs really hot. The CPUs run really hot, so we keep them cool. Now, before I get into this, I want to bring back up my old desktop. It's not very old. It's actually a pretty new desktop. Let's bring back up this desktop, and I want to show you guys with the overhead cam how, when you're looking at the inside of a computer, what are we using to keep the inside cool? Well, when looking at this, in order to keep it cool, we're going to use a variety of fans. You can see a fan that's right here. Now this one, a little bit hard to see there, but there's a fan right here, system case fan, that's keeping some of the components cool. You also have this processor. Underneath this is the processor. Notice you have a fan, and you have this giant piece of metal. This is keeping the actual CPU very cool. You see, when it comes to a computer, the enemy of a computer is cooling. CPUs get very, very hot. Because they're transistors and they basically are like light bulbs, millions and billions of them, that turns on and off, the CPU can get very hot. And if you get very hot, it'll burn out. So what you have to do is you have to keep it cool. So what they do is they put this metal piece on top of the processor. The processor sits down onto the motherboard, and then this metal piece called the heatsink sits on top of it, and this fan keeps this metal piece cool, and the coolness of the metal transfers to the processor, hopefully keeps it cool. If the processor overheats, the machine will probably shut off, reboot. For all the machines, the processor will die out. Nowadays, though, they have some good fail-safe mechanism inside of them. Now, speaking about cooling, one device that always needs a big cooler, and you're going to find when you're looking at devices, is called GPUs. So when you look at a computer and you're determining, okay, I want to play video games, I want to do massive graphics processing, all right? You got to show those video games to make sure they look nice. Having the CPU do all the work to process the graphics can overtax or overburden the CPU. And what happens is that gamers or CAD designers or people that does movie editing, what they're going to do is they're going to offload their processing from the processor to a device that would literally come in, and now for me to install this, I got to take all these wires out. Would come in and would sit into this case, and then they would connect everything right here. All right, so they connect all the monitors here. So instead of the monitors being connected to the back of the machine here, show you that if you can remember. See all the monitors. We got the DVI, we got the VGA, we got a HDMI port. Instead of the monitor being connected, it would go through here. So all your display would be coming out of here. This is a GPU, or graphics processing unit. GPUs always carry, if you look at a lot of GPUs that are out there, they're very big, some of them are very long. They always have a bunch of fans on them, all right? And on the bottom of these fans are massive heat sinks. You can see the heat sinks directly through it, like right through here, there are heat sinks underneath them. If you look at the bottom here, you can see the heat sink, that big metal part. These fans are keeping that cool, and underneath them is the actual GPU. So, video cards, by the way, these are really called video cards, but they carry the GPU. So why do we want to do this? Because that way the processor is not left processing all your graphics. The processor has enough work dealing with your operating system, dealing with the application that you're trying to access, the internet background, all the background applications that you're using. So why not offload get a dedicated processor for it and let it process the graphics separate. The problem again, once again, is cooling. So how do we cool it? We use heat sinks and fan. The last part about cooling I want to talk about is something called water cooling system. In the A+ class, we'll go more into this, but there is a different cooling system, water cool versus air cool. So water cooling systems basically utilizes components with a little reservoir of water that keeps the water cool and it circulates around the computer. Why would you do that? Because it's more efficient. It's a lot quieter. So the computer I have on my desk is a water cooled system. And it's a really powerful machine with a good video card, but you really don't hear it because the water cool keeps it really, really quiet. Okay, make sure for your exam you understand what a GPU is and how we keep them cool. In this video, I'm going to be covering motherboards, firmware, and RAM. Let's get into it. So, one of the most important components you're going to find in any computer, or the most important component, is the system's motherboard. I want to show you what it looks like when it's all set up within the case, and then I have one that's already taken out, something really simpler to look at. And I want to show you the BIOS and the RAM on the machine. So let's take a look at this desktop that we have in front of me. Let's clear up the space here. So this desktop that I have in front of me is already built. It works. It was running a few hours ago. So hopefully when I finish this video, it still works. But on this desktop, what I'm going to do is I'm going to open up the case. Now opening up the case here, it's a little notch on the side here. We're just going to pull that and slip it out there. Now there were screws that held it in the back. Now if you're really interested in watching me take apart the computer, put it back together, changing all the components, taking them out, putting them back in, talking about each component more in depth, that's going to be your A+. For this one, you just really need to know what basically they are and what they look like. So I'm going to take this out of here, and what you can see inside, this entire inner working of a computer. Now it looks like a lot of mashup of cables that's within there. What I want to do is I want to identify some of the major parts on this machine. Hopefully you've got a good view there. Let's go back to the overhead cam. So this is inside of the actual computer. And there's a variety of things here that we want to be able to identify. Now this one is fully connected and it's fully working. It's fully functional. All right. And then I have a motherboard here that we're going to be explaining to you. So right now inside of here, what you're looking at, all these spaghetti of wires, this comes out of this device. This is known as the PSU, or the power supply unit. This device, lots of wires are coming out of it, and wires are plugged directly into the motherboard. It's also plugged into the hard drives. It's plugged into the fans. This basically device powers up this entire unit. In fact, when you connect your power cable, you connect it to the back of this device. And again, to take this device out, putting it back in, that's going to be in the A+. So the A+ class, I actually use this machine to take it apart and put it back together 100 times in the class. So in this one, you got your power supply unit. Here you have drives. This one has a DVD. It has a DVD drive. This is the hard drive on the actual machine itself. And we're going to be looking at hard drives and stuff like that a little bit later. But what I want to look at in this video is going to be a couple things. All right, in here we have this unit. You see this here? This is called a heatsink. This thermal looking, this weird looking big piece of metal here, that metal is covering up the CPU of the actual machine. So the CPU, it lies underneath this. Here you have your RAM. All right, this is going to be RAM. So this is easy to pop out. All right, now again, if you want to learn how to take this out and all this good stuff, please look into the A+. This is a RAM stick, all right? This is RAM on the machine that we're going to use in order to store our programs. To pop this back in here, not hard to put in at all. You should always change your RAM, especially if you have a desktop. That's back in here. The other thing we want to talk about is going to be the BIOS. You notice there's a battery here. This is called the CMOS battery, BIOS battery. The BIOS is a chip on the motherboard that stores computer settings, like the time and date, for example. Or if you go in, you can change the BIOS on the machine, change the boot order, change configuration on the processor, and so on. When you do that, what happens is that the settings is stored with this little battery. So if you ever work on a computer where the clock keeps going back, You change state, you come back, you turn our computer power back on, it goes right back to an older time. You need to change that battery. Now, that battery lasts us a long time. I haven't seen one of those die in 10 plus years. I mean, I've seen machines be running 10 plus years. The battery don't die, but it's something for your exam. So you can see a lot of different things. So the motherboard is this giant board at the bottom, this board that sits into the case. The CPU is plugged into it. The RAM is plugged into it. The hard drives are plugged into it. You have a variety of expansion slots coming up here. This is going to be a variety of expansion slots. You got your PCI expansion slots here. So this motherboard, it's all fully connected. Now I want to show you a motherboard that is not connected. Let's put this one down. Yes, I am very slow. Yes, I know I'm very slow. I'm old, that's why. If you're laughing at me, when you get old, you're going to be the same way. And I'm fat, and that doesn't help. Okay, so here we have a motherboard. Now this is an older motherboard, and I told you guys, this motherboard is 15 years old probably. And you say, Andrew, that's too old. Well, the components don't change. All the motherboard the different form factors, all motherboards will carry RAM, they'll carry CPU, they'll carry some kind of BIOS, they'll carry some kind of expansion slots, they'll carry connectors for hard drives and so on. They'll all have those things. But this one is a really simple motherboard I use a lot when teaching to demonstrate, because the older thing is just simpler to look at. So I want you guys to look at this. So on this particular one, this is your RAM. Okay, this is the RAM. This here would be your CPU. We spoke about this in a previous video. This is the CMOS, okay? Or the BIOS of the machine, the firmware of the desktop. This is where that battery goes. We don't have the battery. This is where that battery would go. One of the things that people ask me is, how does a computer work? All right. A computer stores data in the hard drive. Hard drives are connected directly on hard drive connectors. In this computer, there's SATA connectors, SATA ports right here. Your hard drive would connect here. This machine is older, it does support older IDE, so you can connect older IDE drives here, but most of the time nowadays you have SATA connectors, you also have solid state connectors. We'll talk about hard drives later. Your hard drive stores your data permanently. When you want to output to a display, you want to send data out to the monitor, right? It's a VGA connector. This is that old parallel port I showed you guys before, a serial port, really old. So you connect a monitor to this port. When you want to access a program, it pulls the data from this port from the hard drive. It then flows into the RAM chip. Data comes into the RAM. This is why RAM is important, because it's called the program that's going to be running. And then the RAM and the RAM will now send it to the processor, where it's processed and pushes up for display. This one doesn't have a video card, but if it did, it can send some of the data to the video card, which is generally would be plugged in here or here. These are called expansions and AGP slots, old AGP PCI slot. And then it's outputted directly through this port, and you'll see it on your screen. So that's basically how a computer works. Okay, it's not something that's very complex. So watch once again in this view. So you connect your hard drive in one of these ports. You say, hey, can you open, let's say you want to open a video game. All right, so you double click, you go to start, you open your video game. The hard drive is connected here. It pulls the data from the hard drive into the RAM. The RAM will now shoot it over to the processor. Why does it not go from hard drive to processor? Well, because the processor of itself, the hard drive itself is very slow. So it puts it into a chip that's faster than RAM. RAM, again, holds all your running programs. The processor gets the data, processes the data, and shoots it out to your video card. And you can see it on your screen. If you have an attached or an external video card, it'll then shoot it through that video card here instead of on the onboard video card that we have here. We spoke about processors in a previous video, but the motherboard itself, this is what they look like. All right, on the motherboard, it's a very simple thing. you have what's called expansion slots. This is where you would plug in those video cards, your sound cards. You have where you would put your RAM. All right, and this is really easy to upgrade. You have your CPU. You have hard drive connectors that we're going to be using to connect to hard disk, SATA connectors. You have all IDE connectors here. If you have your CMOS battery, your CMOS chip itself. If you're wondering what this chip is here, that's all white. This is called a chipset. Chipset is like the spine. They call this the brain of the machine. This is the spine. This is what coordinates all the action between the RAM, the CPU, and the video display being pushed out. There's something called North Bridge and South Bridge. You don't need to know that for this exam, but that's what it is. So this is a motherboard. If you want to learn more about this, the one I'm going over is just it's too much for your exam right now. If you want to learn more about this type of stuff, when you're a technician, you're going to have to be replacing these things. You're going to have to be changing RAM, especially troubleshooting hard drive, or replacing failed hard drive is common. Replacing failed power supply, and computers are very common to blow up. At that point, you got to get your A+. All right, but for this course, it's all you need to know about these things. In this video, I'm going to be talking about storage devices, and particularly different kinds of hard drives that are out there, different devices that we can use to store data. I'm talking more of a long-term storage. Your RAM is known as volatile memory. Volatile memory means that when if you turn off your computer, you lose it. So here I have our RAM chip. So whatever is in this RAM chip, if I turn the computer off, I lose all the data. It's called volatile. Non-volatile memory is when you turn the computer off, you keep the data that's there. That's going to be things like your ROM, your read-only access memory, or also your BIOS, which is your ROM. Remember I showed you the BIOS? So this is the ROM chip, okay? Read-only memory, which means whatever is here, when you turn the computer off, you unplug it, you don't lose it. Same thing with your hard drive. It's non-volatile. So when you unplug the machine, you still keep your data. So if you pick up your desktop, you unplug it, you walk away, you save something on your desktop, it's saved on your hard drive. So that's what we're talking about in this section, is this non-volatile memory. Now there's a variety of ways to store data. One way we could do it is by using traditional hard drive, HDD, hard disk drive. Hard disk drives is going to be your traditional hard drive like I have here. This is a traditional spinner-based hard drive. I call it spinner because there's an actual mechanical disk in here that spins. For your A+ exam, when you get there, I'll show you. I have one of these where we take it apart and you can actually see the disk and the platters and everything. But know that this is a normal hard drive. This here is relatively cheap and you get a lot of storage. The problem is that it's relatively slow. Comparing to what? Well, I have here what is known as a solid state drive. This is a brand new solid state Western Digital solid state drive. I say the solid state drive, and I'm just going to open it. This has not been opened. This is the first time this is actually being opened. And so we're going to put it in the machine. So I want to show you guys how these things are connected. These are connected using SATA cables, and you can connect either of them using the same type of cable. Solid state drives are very, very fast. They don't have a mechanical disk that spins. So imagine you want to access data. The disk has to spin, grab it, spin, grab the data. So that the mechanical disk is always spinning for the mechanisms, also known as the head, to grab the data. This is very slow, although almost all of our computers have this stuff. For our newer machines, we're going to have a solid state drive. These are just chips, basically like RAM chips that you have on your motherboard. And they're very fast. If you ever install one of these, you'll see a massive difference between your old-fashioned spinner drive and your solid state drive. Now, I want to show you in the overhead cam, how do we connect a hard drive? Well, again, if you want to learn more about this, you're going to take that A+, okay? So this is called a SATA solid state. These are called SATA connectors. And it's the same connector here. And you notice this is a 1 terabyte solid state drive. This is a 1 terabyte hard disk drive. They connect the same way. So here's a SATA cable. And on this motherboard, we have a SATA connector. And all it is basically, now of course this is much harder in the computer. So I'm going to take this cable and I'm going to connect it into that slot. have one connected there. And then I can now use it to connect to my hard drive. Just like that, it's connected. You would need to say the power cable from the power supply, or I can connect this little device. And you can see the difference in size. They have the same amount of storage. You're all 1 terabyte. This is a whole lot faster, night and day faster than this spinner drive. Now, the problem with solid state drives is that they're just expensive. Currently speaking, solid state drives are really, really expensive. A 1 terabyte solid state drive, $100. 1 terabyte hard disk drive or HDD spinner drives, $30, $40. Getting a 2 terabyte drive can be really expensive. Solid state drive comes in 2 form factors. There is this one, what's called a SATA form factor, and there's something called NVMe, non-volatile memory express. So I'll show you guys that. I have a picture of one here. This is an NVMe drive. It's basically, this is a 256 gig NVMe drive. These are the fastest. You must have an NVMe connector on your motherboard, but this is going to be the fastest solid state drive. You notice it says SSD on it, so it's a solid state drive. It's an NVMe solid state drive, incredibly fast. If you're looking to up your performance on your computer, you're going to get one of those. If your motherboard supports it, you're going to have a relatively newer motherboard, maybe in the last 3 or 4 years. And if it's in that borderline 4 or 5 years, you're probably going to have the higher end of your PC back then. But that's what it is. The other one I want to mention is you're going to have thumb drives, USB thumb drives, stored data called thumb drives because they're generally the size of your thumb. This here we went over already. So this is going to be some of the storage devices you're going to need to be familiar with for your exam. In this video, I'm going to be covering NIC cards, NIC, Network Interface Cards. NIC cards, or Network Interface Cards, is what we're going to utilize to connect our computers to a network, whether it's a wired or a wireless network. So if you're at home right now and you're just surfing the internet on your laptop on the couch, there's a wireless interface card on your computer that's connected to the wireless access point in your house. If you're at a gaming desktop and you have a cable plugged into the back of your computer that's plugged into a switch or your wireless router, that's going to be a wired network interface card. Let's see the difference. So here I have the motherboard, and you notice this motherboard here has a built-in NIC card. So this is where I would connect. So here's the network cable that we saw earlier. This is where I would connect that RJ45 cable into, and then I would plug this into the router. So this here would be what is known as an on-board NIC card. Now, if you want to add, let's say your computer doesn't have you want to add wireless to your desktop, which is something pretty common. And you realize, oh, my desktop just doesn't have wireless. Well, it doesn't have it on board. Laptops generally come with the wireless cards built into the onboard system. But a lot of desktops don't. In fact, they have what's called an add-on card. An add-on card would look like this. This is an add-on card, a wireless NIC card that is an add-on. And this one here, not something super old, but I think this is an N wireless NIC card. And basically, on the motherboard, you would have to have a specialized slot. So I'm not going to go into all the different slots on the motherboard. Keep that for A+. And you just basically plug it in, and you would have the ability to have wireless connectors. So this would be an add-on card. Another variation of an add-on card, instead of having to go plug it into the motherboard, is something that looks like this. This is a USB add-on wireless NIC card. So this here would just plug directly into your desktop, or if your laptop doesn't have wireless and you want to add wireless to it, this would be the way to go. You can see that this is a relatively pretty small device. It's a TP-Link. I bought this device to teach my ethical hacking course with because it's one of the only devices that Kali Linux picks up. Take my Security Plus, I talk about this. So is my CEH class. Okay, so you have different type of NIC cards. You have that wired NIC card. You have the wireless NIC card, right? Connects to the wired network. You have them can be onboard, built onto the motherboard, or you're going to have to get some kind of an add-on. When working as a technician, you should understand different kinds of internet connections that are out there. Like which one is faster, DSL versus cable or versus fiber optic? Which one allows you to work in a rural area versus the other one? So CompTIA gave us a variety of different internet connections that we should be familiar with. Now, you don't need to worry how to set these things up or configure them for this particular course. We'll look at more of that in the A+. But let's take a look at it. So we got fiber optics, cable, DSL, and wireless internet. Now, when it comes to internet connections, the first one up you have were dial-up internet connections, like I connected on my 56K modem using a good old-fashioned telephone system back in the 1990s. The 56K was really, really slow. In fact, to download one MP3 would probably take me 10-15 minutes. Nowadays, it takes seconds. So we have evolved from that. All right, so we don't have those kinds of old internet connections anymore. What happened was to get broadband internet allows you to run multiple signals on a single cable. Broadband internet, one of the first ones that came out, was known as DSL, or digital subscriber line. So DSL is basically internet, broadband internet or high-speed internet that basically runs on good old-fashioned telephone wires or telephone line. DSL was widely available because basically if you had a telephone line running to your house, you could have gotten DSL. It wasn't very slow, but again, it wasn't very fast. DSL was in the megabits. You could have got DSL 2 megabits, 3 megabits, 4 megabits, 6 megabits down, and your upload was pretty slow at around 1 meg or so. Now, another widely available internet connection that came out was cable internet. Because so many neighborhoods and houses already had cable lines running to it, I'm talking coax cable, like cable TV, people were able to get internet through their cable TV. I remember having Time Warner cable internet connection. This was a lot faster than DSL. It was relatively cheap as it was going through your cable provider. Then came the fiber optics, such as Verizon's Fios, Google Fiber, and so on. This allows you to get hundreds of megs and gigabits of internet connection. For example, in my house here, I have the Fios internet connection. Fios internet basically goes at, for me, 1 gigabit. For businesses, you can get multiple gigs. When it comes to other types of internet connections, we're going to have wireless. Now, wireless is great because, hey, there's no wire connected to it. You're already familiar with this because you're familiar with cellular Wi-Fi, cellular wireless. This is what you're going to have in your 5G, 4G, and 3G networks. This allows you to have from a few megs in 3G and 4G to gigabits of connections in your 5G cellular network that you're probably going to have on your cell phone that you're paying your cell phone provider at. Another one you can have is radio frequency. Now, radio frequency, this one is going to use antennas where you must have an antenna in your house and the provider has an antennas facing each other and you're able to communicate and get internet this way. I haven't seen much of these implemented. I saw a few of these implemented in business in New York City. We have an antenna placed by the window and another antenna placed by a provider able to connect. Getting popular is satellite internet. Now, satellite internet has been around for a while and it's used in really rural areas. In where you don't have any cables, you don't have any major distribution points or access points to connect to like you would need on a cellular network or cell towers. As long as you can see the sky, the antenna can see the sky, it can connect to the satellite and give you internet. Generally, it was considered very slow, but nowadays we're having satellite internet that is getting faster and faster for relatively a cheap amount. So this means that you can probably get any internet anywhere that you can pretty much see the sky. And there's a lot of satellite services that are coming out that's going to basically allow that. Okay, so these were some internet connections that you should be familiar with. One of the first broadband was DSL, ran on telephone lines. You had one that ran on cable lines, such as your cable connections. Then you had one that ran on fiber optics cable. Fiber optics cable gives you the fastest connection out there, as fiber cables, which uses a glass or a copper core, are very, very fast cable. Then you had the variety of different wireless, some cellular that we use in our cell phone. Some of us that live in rural areas may have a satellite connection or even a radio frequency. In this video, I'm going to be talking about storing data, but not locally storing it like you would on your hard drive. I'm talking externally from your computer. Let's get started. So, you got a computer, you got a bunch of data in it. You got it on your hard drive, right? Your hard drive, you got a 2 terabyte drive, you got a bunch of pictures, you got music, you got videos, and you say to yourself, okay, I don't want it on here. I want to store it somewhere else. Maybe something that's more redundant, that if one drive fails, you don't just lose all your data. So in this situation, we're going to use a couple of devices. We can use a NAS or a file server, or we can even store it in the cloud, in which case you store it on somebody else's network. Let's get into this. So a couple of terms here we have to know: NAS, file server, and cloud storages. Let's see if we can differentiate them. The first thing up we're going to talk about is something called a NAS, network attached storage. Okay, NAS, network attached storage. So what a NAS does is basically a box that's connected to your network, that's just a dedicated storage device. It's like connecting a hard drive, taking a hard drive and plugging a network connection into it. It doesn't have an enclosure for it. I have in my network something called a Synology box. I'll show you guys what that is in a second. It's basically a box of hard drives that I connect to my network, and I store all my pictures and my movies and my music files on there. So it's not on any computer. That way I can access my movie files or my music files from any computer in the house. Another one is a file server. Now, file servers are really going to be used by businesses. In a business, they're going to have a big tower computer, and I'll show you guys one of them, that they put hard drives into, and all the people in the office shares data from that particular computer, known as the file server. This machine is serving up files to everybody. Now, technically speaking, a NAS is a smaller file server. But the file server is going to be a dedicated, real full-fledged computer server versus a NAS, just a really dedicated storage device. Another thing that you can store data on is going to be cloud storage. Now, it's 2022, and you're probably using some kind of cloud storage to store your data. For example, you may be using Google Drive to store data on Google's cloud network, or you may be using, my favorite one is Dropbox, that I use to store all my data in. And these are pretty much free that you can use to store data in. So when you're thinking of all these types of storage, you have to think, okay, do I want to keep stuff on my computer? No, you want to offload them to something like this. So this is a NAS, and this is going to be a Synology 2-disk bay NAS disk station. So this is just a box. It's not very big. It's actually a very small box. And at the back of it, it basically carries, as you can see, just a box of 2 hard drives in it. And it carries a couple of Ethernet ports on there that you can use to connect your computers to. You connect your network to, and then your computer would then connect to this to store data. I use this to keep all my pictures and my music files on, and my movies. So if I'm sitting at this machine, I can watch a movie. If I'm going to that machine, I can watch a movie right off the NAS in the house. The other one is going to be a file server. So a file server is basically a server computer that you purchase from a company like Dell. These machines are going to be dedicated machines that's going to use to serve files on your network. They're going to run a server operating system, and they're going to have a bunch of hard drives configured in a highly redundant array. If you want to use things to store your drive in one of those cloud storages, you're going to use something like Google Drive in order to store data on the cloud. By the way, when people say cloud, they literally mean somebody else's network. A lot of times when we say, oh, we put my data in the cloud, there's not many big cloud providers. There's basically 3. AWS is Amazon, Google Cloud, and Microsoft Azure's cloud. So Amazon controls the network, Microsoft controls the network, and Google controls the cloud network. So people say, all right, put my data in the cloud. It means basically you're storing it in Microsoft's network or AWS network or Google's network. So when you use things like Google Drive, or you're basically storing it in Google's network. Dropbox, for example, runs on AWS or Amazon's cloud systems. So I'm basically, when I use Dropbox, I'm basically storing my data in Amazon. In this video, I'm going to be going through a variety of different devices that you should be familiar with for your exam. Now, most of you that have used the world of computers or play games at home probably already know most of this, so let's knock this out pretty quickly. Now, if you don't, I will be going into it. So the first thing that we want to know is basically the purpose of mobile phones. Nowadays, things like mobile phones are really just handheld computers. Mobile phones allows you not just to make a call, but send text messages, check the internet, and can basically do anything your desktop or laptop can do just on a smaller screen. So mobile phones are absolutely great because it seems like a lot of us can't get off of these devices. But these things are really just general purpose computers with the ability to make a call nowadays. Following this up is we're going to have tablets. So here I have a Windows tablet. Now, tablets basically are giant mobile phones. For example, if you have an iPhone and an iPad, you'll notice the iPad is basically a large iPad, a large iPhone. You have an Android tablet and an Android phone, such as this. This is an Android phone. Basically, it's just a large phone, except it doesn't have the ability to make calls. This is a Windows tablet, so it's just a smaller version of what I would have on a desktop. Now, laptops. Laptops are, of course, going to be basically like desktop computers, except they're smaller. Laptops are going to run generally in a lower power mode, but they are going to allow you to do basically everything you could on a desktop, except it's portable. It comes built with a screen, bunch of connectors, but it's probably not going to be as fast, and it's probably going to be, if you want the speed of a desktop, you're probably going to spend a lot more money. When you're working in businesses today, you're probably going to work on what's called a workstation. In a business, you have what's called servers and workstations. A server is basically a device that will serve the data or process the data for you. And there's a variety of servers in businesses nowadays. You have database server, you have file server, you have a print server, you have a web server. And these are dedicated servers that serves up different things. For example, a database server will run a database. A file server will give out files to everybody on the network. A print server will have a bunch of printers connect to it so people can connect to that to print to different printers. So servers basically serves the data in the network. Now workstations is where the user sits and gets work done. It's basically just a desktop computer, generally with a specialized operating system, such as not Windows Home, but Windows Pro would be installed, so it could be managed more efficiently in a business network. The other one here we have is going to be gaming console. Now gaming consoles such as your PlayStation 1, the last gaming console I had was a PlayStation 2. And after that, I really didn't play much games after that. It's called console games. My son still does, but gaming console nowadays, such as a PlayStation 4 or PlayStation 5 or whatever number they're up to, are as powerful as some of the most powerful desktops that are out there. In fact, I heard finding one can be difficult. But gaming console nowadays are basically high-end computers at a pretty cheap price. They come with massive GPU in them, and they're able to display and process graphics very, very fast. All right, these are going to be some of the devices that you should be familiar with for your exam. In this video, I'm going to be talking about a term that you're probably going to hear a lot of in the coming years. It surrounds you, and you need to know it for your exam, and that's called IoT, also known as the Internet of Things. IoT devices are basically any device that can connect to the internet. If you think about this around you right now, what doesn't have an internet connection? IoT basically refers to every device that connects to the internet, such as what? Well, if you think about it, your thermostat, if you have like a Nest thermostat, you can connect to the internet. I have the Nest thermostat. I can turn up and down my temperature in my house with it. Your security system, if you have an ADT system, you can turn alarm and disalarm. Your modern cars all have IP address. Tesla cars can download updates from the internet. IP cameras, you can access your camera system from your phone. Streaming media devices, even medical devices such as X-ray machines can be monitored or can actually do work remotely on an internet, on some kind of network connection. So there's going to be a variety of home automation devices. Your appliances, your fridge connects to the internet. Can you think of something that doesn't connect to the internet? Things like what? Your toothbrush. There is such a thing as a Bluetooth toothbrush. Your shoes. There's even a coffee cup that has Bluetooth to monitor the temperature. All of these devices that are now connected to the internet to become more quote-unquote connected means that they could be managed, accessed, and monitored remotely, which is great because now I can turn off that lamp over there because I don't want no more light without getting up. I can brew coffee in the morning by just going into my phone and say brew coffee. I can turn up and down the stove or the oven in the stove from my phone. Now, what this means, this is great because it allows more connectivity and ease of use in life. But with this comes a variety of complex technology because some of them will run on Wi-Fi, some will run on Bluetooth, and then there's a variety of different kinds of IoT protocols we'll cover in another class. But it also brings a lot of security problems because if all these devices are becoming more connected to the internet, it also means that more hackers can access them. Back in the, I drive a pickup truck, a big old pickup truck. It has no connections in it, has no remote connection, and no hacker can hack my car. But if you're driving this brand new Tesla car with your always on internet connection, can somebody hack into your car and run you off the road? Well, they can't do that to my big old pickup truck because, well, it doesn't really have any internet connection on it versus the modern cars that do. So this is, of course, going to create some kind of security issues as we go forward in the future. But for your exam right now, just know what exactly is IoT. On my desk, I have a wireless access point and a switch combination. This is my sonic wall we've been using throughout this course. This is also, once again, it's a firewall, but it also is a switch. It is a access point. So if I take this network cable that's plugged into this device, and I was to plug it into this laptop, I get on my other laptop and I plug that into this device. Now I have two computers that can communicate. When you set up a network, something small like this, and again, I can have wireless devices talk to it. Maybe I have another wireless laptop or a tablet. So I would have my laptops, I would have my tablets, maybe my phone can connect to this, and we can all share resources like files or pictures or movies or something like that within my little room here, within my actual little house. When you set up a network within your house, within a building, within a single building, it is called, in the world of technology, we call this a LAN. Now, a LAN, known as local area network, is basically a network that is defined as something that is limited to a single building. So a network within a building, within a floor, within your house would be considered a local area network. So know this term for your exam, local area network. Now, the opposite to a LAN is known as a WAN, wide area network. Wide area networks is networks that spans the entire globe. It's large corporate networks. So let's say you have an organization that has a building in New York and you have another one with one in Texas. And they connect these two buildings using some kind of leased dedicated line hosted by an ISP or some kind of line provider. And now you have people in New York talking to people in Texas like they're basically in the same network. This is known as a wide area network. And if you're saying to yourself, well, I have a LAN because I have a network at home. Have I ever used a WAN? Well, one of the biggest WANs out there, or again, wide area network, is the internet. The internet is the world's largest wide area network. A WAN is not limited to really any boundary. It's as wide as your imagination. It's the biggest network we have. The internet is a global network. It is not a network that is confined to a building or to a city, to a state or a country. It's basically the entire world. So know that term for your exam. A LAN is confined generally to a single building versus a wide area network has really no boundaries and it's basically a global network. In this video, I'm going to be talking about a pretty interesting topic and something that you're probably all use already, or you are using it because you're watching me on some kind of streaming media. And that's going to be the basis of packet transmission. And what this is how exactly does data transfer between a network device and a computer, or between a computer to a network device and to another computer? How exactly do we get internet? Well, it's a pretty complex topic, and I'm going to try to keep it real simple, just enough for your exam in this video. So the first thing we want to talk about is what is used to transfer data. Well, in the world of technology, we use protocol. Okay, a protocol is defined as a set of rules that people will follow, or the computers will follow in order to communicate. So a protocol is basically the language we are speaking. It's the definition of the communications that's happening between me and you. Right now, I'm speaking English and you're listening to me in English. We must all follow the rules of English, that this word means this and this sound means this. That way, when I communicate, you can understand. In the world of communication, the protocol that we use, that you guys should be familiar with for your exam, is going to be TCP/IP, Transmission Control Protocol, Internet Protocol. TCP/IP is going to be the protocol that we use to communicate between computers. all computers in this world right now, every single, from your laptop, desktops, to your mobile phones, to your IoT devices, they all run this protocol. That's how we can communicate. Think about this. If you're speaking German and I'm speaking English, can we communicate? Let's say I don't know German and you don't know English. We probably cannot communicate. We can't speak communicating. But if I know English and you know English and I speak English and you speak English, we can communicate. TCP/IP is basically the language that we communicate in the world. Now, TCP/IP is known as a protocol stack. It's not actually two protocols. It looks like it's two. It's Transmission Control Protocol and Internet Protocol. Well, these two protocols are basically made up of many other protocols that we use in the world of communication. This will cover more in courses such as Network Plus and a little bit in A+, but we're really going to expand on the concepts of TCP and the concepts of IP in those courses. But for now, just remember that we communicate in today's world. Computers communicate to each other using a protocol named TCP/IP, or Transmission Control Protocol / Internet Protocol. To elaborate a little bit, IP, the Internet Protocol, is responsible for routing of data. This particular protocol is what we're going to use to route data across the internet, okay, across your network. It's going to allow data to go from your internet service provider, from Google's web server to your internet service provider to your house. It basically routes data. IP is famous for giving you an IP address, a logical address assigned to all hosts on a network. Transmission Control Protocol, this one does quite a lot. This one checks to make sure when your data comes to your machine, it's received good. If there's any errors, it's going to be able to fix it. And there's a few more things, but that's basically the gist of it. So just remember, the basis of packet transmission is going to use a protocol called TCP/IP. And when data is traversing a network, they're called packets. So what leaves the port is called a packet. So packets leaves the port onto the cable, and the packet arrives on your machine. In the world of technology, we actually don't say data is traversing the network. Packets are traversing the network. When you look at network scanners, these are going to be software and devices that actually looks at network traffic and actually go in and see the network traffic itself. That's going to be something that's looking at a packet, right? They don't say data, they say packet analyzer, protocol analyzer. All right, so don't forget, guys, we use TCP/IP to communicate on our network. It's the protocol of choice throughout the world. If any device wants to communicate on the internet or in a network, they must have TCP/IP installed, which almost every computer on the planet do. In this video, I'm going to be talking about device addresses, IP addresses, and MAC address. Let's get into this. So I have my phone, okay? I have a wireless access point that I have here. And I have my laptop, okay? So you can see the setup here. So let's say my laptop is joined to this access point. So this access point basically allows this is the wireless network receiver, and the phone is also joined to your wireless. So you probably went into places before where can I join your Wi-Fi? To take your phone and join the Wi-Fi. But let's say my laptop is also joined to the Wi-Fi. Okay, but let's say I want to share data. So I want to send some data from my phone to my laptop. All right, but let's say there's 10 other computers. Let's say there's 10 other machines that's joined to this wireless network. In order for data to know where it's correctly going, there has to be some kind of addressing scheme. Think of when the post office sends you mail. In order for the post office to route the mail correctly to you, you got to have some kind of address, right? You have a house address in there. So in this setup, in our networking today, we must have addresses. Now, in the world of IT, we have addresses, and we basically have two kinds of address. We have what's known as a logical address. A logical address is an IP address or Internet Protocol address. We spoke about IP previously. It was part of the TCP/IP protocol stack that we're using to communicate in the network. Computers will also carry what's known as a hardware address. Hardware addresses are basically known as a MAC address, or Media Access Control. That's a number that's assigned to your NIC card by your manufacturer. Now, I don't want to get into the specifics of IP addressing and MAC addressing in this course, but it's something we get into in A+, and especially in Network Plus and things like Cisco. But I'll give you the basics of what they are in this video. So once again, every device in a network must carry an IP address, our Internet Protocol address. Every device must also carry a MAC address within the network. An IP address is known as your logical address, CAL, and this is known as a physical, PHYSIC, a physical address. An IP address is something that we assign, okay? As the administrators of the network, we assign the IP address. The MAC address is assigned by the manufacturer of that machine or that particular NIC card. Every single computer or computing device that's built in this world carries a unique MAC address that's assigned by the manufacturer. So for example, let's say Samsung, well, this is a Samsung phone. Let's say Samsung made this phone, and on this phone there is a MAC address for the wireless NIC card built inside. Who assigned the MAC address? Samsung did. But the IP address that the phone gets within my network is assigned by my networking device. As your career goes up and you become a network administrator, you will determine your IP address and scheme. And in this video, I want to show you what does an IP address looks like and what a MAC address looks like. So an IP address is basically an IP, we should say version 4 address, okay? I want to point that I got this version 4 and version 6 addresses. For this video, I'll just keep it to version 4 because that's what we mostly still use, especially in internal networks, although version 6 is really starting to replace it. But for an IP version 4 address, it's basically going to be 4 numbers, and it's represented as x.x.x.x, and each number is between the numbers of 0 and 255. And if you really want to know why, take the Network Plus class in A+. I'll explain that to you in more detail. So an IP address basically looks something like this. It'll be like 10.20.30.1. That would be like an IP address. So, and again, this is something that your company is going to assign, or if you're the administrator, you're going to be assigning it. There's ways where you can manually assign the address. That's called a static IP address. And then there are ways where you have something called the DHCP. DHCP, the Dynamic Host Configuration Protocol. This is a particular protocol that's configured by an administrator that automatically assigns IP addresses to your network devices. So if you're at home right now and you just connected to your wireless network and you already got an IP address, that's what's giving you that IP, that protocol called DHCP. The other one is going to be a MAC address. So an IP address, by the way, is a 32-bit address. A MAC address is going to be a 48-bit address. It's written in a hexadecimal, and it's written as digits. Each one of those X represents a hex. Can you remember from the beginning what those hex were? Can you remember that? All right. So it's a 48-bit address. And basically, you're going to have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 4 is 32. We'll do X one more time. And XX. So it's a pretty long address. It's actually broken into 6 different pairs of numbers. So you have 1 pair here, 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 1 pair here. Total it, each one of these X represents 4 bits. Now you're probably saying, Andrew, what the hell is all of that? Can I see it? Well, I'm going to show this to you on my computer, my actual IP address and my MAC address. So let's take a look. I am going to go. Now, you don't need to know commands for your exam, okay? You do not need to know commands for your exam once again, but you will for other certifications. So I'm going to do ipconfig /all. Okay, so now I don't really want you to worry too much about commands here for a second, but I do want you to notice that on this computer, I am connected to the FiOS home router, so I'm connected to my FiOS. I have my IP address, notice 192.168.1.80. This is a preferred, it says preferred because it's a static IP that I put, I manually hand typed this in. But you notice that I also have this MAC address. So remember I told you, it's basically 6 pair of hexadecimal numbers. See it here? So notice you have A8, A1, 59, 29, 111C. This is going to be my MAC address or my physical address on the actual machine. So, and if you have multiple NIC cards installed, it's going to give you one for all of them. Remember we looked at that TP-Link adapter, wireless NIC card in a previous video? So this one, it's not really configured yet, but I do have, notice wireless, it's the TP-Link. And notice this one also has an address. It's not connected to any network, so it doesn't have a, and because it's not connected, it does not have a IP address. So it needs to be connected to have that IP address. I don't want you to worry too much about the actual formatting of these numbers or exactly how to type in IPs. That we're going to get to as we move up in our career. But I do want you to understand that devices on a network must have an IP address, logical address, assigned by the administrator generally within the network, and the MAC address is assigned by the manufacturer. It's not something you're going to assign. I've never really had to assign one in my 20 plus years of doing this. It's given by the manufacturer and it's there as the physical address. In the previous video, I told you that every single device on a network must have an IP address. Did you also know that every single web server on the internet also has a unique IP address assigned to them? And when you want to access a website, you have to know that IP address. Isn't that so? Is it? Probably not, right? Because you're saying, I don't know any IP address to any websites. Well, your computer does. You see, in order to access any website on the internet, you must know its IP address, or at least your computer must know its IP address. In order to access any resource on a network, you must know its IP address, or at least, again, your computer must. In this video, I'm going to look at something we call DNS, domain naming or domain name server. Some people say domain name server, some people domain name and service, domain name server, service. There's a variety of different meaning. Let's just say domain name server for now. DNS is a service that's used to translate between a bit more than likely a domain name and an IP address. So when you want to access something like google.com, your computer doesn't actually need to know what is Google's IP address. So you don't need to know it because your computer will then use the service to find it. You see, this is called URL to IP translation. The URL, or Uniform Resource Locator, is https www.google.com. That is Google's URL. Your computer will take that URL, give it to the DNS server. The DNS server is going to say, oh, you're going to google.com. Here's the IP address. And then your machine goes right to Google. So your computer doesn't, and you don't need to know IP addressing. Why? Because we use DNS to turn those URLs into IP address. I'll show you what I mean. So let me just exit this here. And let's go back to my desktop. Where's my desktop? Here we go. So at my desktop here, I'm going to go to my command prompt. I want to show you something. Watch. You see, if I ping google.com, now ping is a command that we use when we are trying to determine if a host is alive. I want to show you something. Notice when I pinged it, it didn't give me google.com. It gave me an IP address. You see this right here? That is the IP address of Google. If I copy this, Control-C, and I open up a web browser. Okay, I have Edge open here. All right, if I open this browser and I go to, I just put that address. Notice how I'm just typing that address in there. Then what am I going to see? Let's take a look. Notice it's Google. Did you see that? So watch again. I go here, paste that address in there. I'm just going to go ahead here and press enter. Notice it's Google. So this is every time we access, every time we're on a computer and we go to a URL, yahoo.com, google.com, bing.com, amazon.com, anytime you go to any one of these URLs, you're basically going to its IP address. Now, the service that's translating between that IP address, the domain name and the IP address, that is DNS. All right, so note for your exam. DNS is when we're going to translate between domain names and IP addresses. In this video, we're going to be talking about protocols. So earlier, I spoke about the main protocol that we're going to use to communicate on our network. TCP/IP is the main suite of protocols that we're going to be utilizing to communicate within the network. Now, I do want to point out TCP/IP is not just two protocols. It is the name of the suite of protocols. In fact, in the world of technology, when you want to communicate, remember, protocol means speaking the same language. When you want to communicate to do certain tasks, like transferring a file, you'll use something called FTP, File Transfer Protocol. When you want to just transfer a web page from one computer to the next, you'll use the Hypertext Transfer Protocol, or HTTP. When you want to send an email, you'll use a simple Mail Transfer Protocol to send emails. In other words, anything that you want to do on a network of sharing resources, whether it's sharing a print job to a printer, a file to a user, connecting to another user's desktop, even making a phone call using a VoIP or voice over IP computer or software, you're basically going to have to get a protocol to do it. Now, in this video, we're going to talk about 4 protocols that we should be familiar with for exam that you're pretty much going to use all the time. And there's 2 tasks we do all the time on computers nowadays. We surf the internet and we send emails. So we're going to look at a protocol used to transfer a web page, HTTP, and protocol used to send and receive emails. So the first thing we'll take a look at is what is known as HTTP, the Hypertext Transfer Protocol. This is a protocol that you have on your computer, and so does a web server. So Google have an HTTP server, or basically a web server, we should call that. So this server has web pages on it, and you want the web page. So this protocol allows that web page to be requested and transferred from that web server to your workstation. So the Hypertext Transfer Protocol basically allows you to transfer web pages. Now, when you go to a website, you always want to make sure you're using HTTPS. If you use an HTTP website, it means it's not encrypted. That means anything that you do on that website, hackers can see it. So if you're going to a website that doesn't have an HTTPS, I'll take a look at URLs in a few minutes after I come off of this slide. But I'll show you guys what I mean when I say we should always look for that HTTPS. HTTPS means secure, so it's a secure version of it. Now, when it comes to emails, these 3 here are email protocols. All right. POP3, or Post Office Protocol, and IMAP, Internet Message Access Protocol. POP3 and IMAP are both used to receive emails. So you must configure one of them in order to receive emails from an email server. So the email server is configured with IMAP or POP3, and you're going to configure your computer to join and receive emails from that email server. Now, POP3 is the really old one. Okay, really old. No one really uses that because it doesn't synchronize with the web server. It just takes all the mail and then there's nothing left on the server. In today's world, we almost always use IMAP when setting up emails. IMAP allows you to synchronize with the web server. So you can configure IMAP on this machine to an email. I can configure IMAP on my phone. That way, if I send an email here, I can see the sent items here. If I check an email here, it also tells me it checked here. If I was using POP3, if I download all the emails here, I'll never see it here because all of it is here. So we don't use POP3, we use IMAP when setting up emails to receive emails. If you want to send an email, that's another protocol, Simple Mail Transfer Protocol. This one allows you to send emails. So when you're configuring an email client, I'll show you in a minute, you have to configure either POP or IMAP, and of course an SMTP to send. There's only one sending protocol, but there's 2 receiving protocols. So you need 2 different protocols, one to send, one to receive. You know, if there's one thing I tell my younger students, is in the world of IT. Oh my God, there's so many protocols that are out there. It's going to drive you crazy. Before we go though, let's take a look at a little bit of a hands-on, a little quick lab here to show you where these protocols belong. So the first thing I want to talk about is when you go in to a URL. So if I go to yahoo.com, and now it doesn't want to show me the full URL until I click on it, but I can see into this URL, I can see right here, it says HTTPS. You guys see that? This means that this one is secure. You want to make sure that when any website you go to is secure. So if I take out the S, it'll go right back because this site defaults to that. If you ever go to a website that doesn't have an HTTPS on it, a lot of times the browsers will give you an error. It'll say something like, oh, this site isn't secure. Are you sure you want to go there? And you shouldn't. Almost all websites on the internet nowadays should have an S at the end of its HTTP. That means it has a certificate installed, and that certificate is going to help with the encryption process needed to encrypt the data between you and that website. The other thing here we'll take a quick look at is configuring mail. So I'm going to go to Start, open up my control panel, and in my control panel I have this thing called Mail. Now I do have a few email accounts that is configured on this machine. This is how we would set up like Microsoft Outlook, by the way. So if I go here, I have two. I have Instructor and Instructor 1. So I'm going to go here and I'm going to say New. And I'm going to say I want to manually set up the email because I want to show you that it's going to access that SMTP. Notice it says POP or IMAP. Notice you can't select both because how are you receiving your emails? Is it POP or IMAP? A lot of times the email servers that is sending out, giving you the email, will only support POP or IMAP. Now most of them pretty much support IMAP. Really nobody uses POP anymore. So when I click Next, I now have to put in my name, my email address. Is it a POP or is it an IMAP? Okay, so if I select POP, if I select IMAP, it wants the name of the server. So this would be like imap.server.com. And then SMTP, notice I have to put in the SMTP. This is going to allow me, it says outgoing. That doesn't allow me to send email. So if I configure the incoming correctly, I'll be able to receive the email. If I don't configure the outgoing correctly, I won't be able to send anything. And vice versa too. So you would put in smtp.server.com. This is just some made up names. And then you would put in all this information, click Next, and it'll set up the email for you. You know, working in IT, protocols drive you crazy because along with protocols will come port numbers. And then that drives a lot of younger IT folks crazy because so many protocols, so many port numbers that we have to know. We will cover more of those in later certifications. But for now, these are the 4 protocols you need to know for your exam. When you're working on a network, you're going to have a whole lot of devices that creates a network. Whether they're switches, routers, firewalls, modems, and so on, that you're going to have to set up a network. And in this video, I want to talk about these devices and give you a brief overview of what they are. Sometimes I'm going to look at some business end devices and we'll look at some home devices also. Let's get started. So the first thing up I have is I have a list of devices that I'm going to talk to you guys about. The first one up I have is considered a modem. So a modem is also, it stands for modulation, modulator, demodulator. Modems originally were meant to convert analog to digital and digital to analog. So you would get a 56K modem. A 56K modem is an old device back in the days, in the 1990s, when we connected to the internet using dial-up, actual telephone lines. The data coming through the telephone lines were basically nothing more than analog signal. The modem would then translate that analog signal to a digital signal for the computer to read, as the computer can only read digital. So that's where the word modem. Modem is not actually a word, it's actually an acronym. It stands for modulator, demodulator. Analog to digital and back from digital back to analog. Nowadays though, we use modems like cable modems. Technically a cable modem is not a modem. But nowadays when we say modem, it's just a box that's used to bring the internet to our house. From there, we can then split that traffic up. they would use a router. Routers are used across the internet in order to connect dissimilar networks and used inside of large organizations to connect dissimilar networks. In a business today, we're going to have many networks that are set up. You may have a separate IP network for sales, a separate one for accounting, separate one for management, separate one for IT management. So you have a router to connect them. Now routers can, a lot of you guys may think of a router as the modem that you get internet from. Well, that device that you have at home is a combination device. A lot of you guys have a device that looks like this, like a sonic wall. This is a router. It is a switch and it's an access point. Switches allows you to connect computers together. A switch basically passes traffic from one port to the next. So if I connect one computer here and I connect another computer here, the switch allows data to traverse the network cable into the device and then back out into the next device. So the switch allows them to communicate. A wireless access point is basically a switch, a wireless switch. It allows computers to connect to these antennas and it allows them to communicate. This device is basically a 3-in-1. But this device is also a firewall because firewalls are used to protect your network from people breaking into your network. You need firewalls so hackers coming through the internet, they're going to hit this device. This device is going to say, you know what, you're not coming in here. I'm going to block you out. Now, these are combo devices. These devices do them all. It's a small business device. You put it in your house. It has a router built into it so you can connect that WAN of the internet to the LAN of internally. It has a switch so you can connect computers to it. It has an access point so you can connect wireless computers. And it has a firewall to protect your network. The all-in-one device, right? Okay, so those are the descriptions of the devices that you should understand. Router connects dissimilar networks. A switch allows you to connect computers within the same network. An access point is basically a wireless switch, allows wireless devices to communicate, and a firewall will protect your network. Now, before I leave this, I decided to show you guys something. I said that this sonic wall is a combo device, right? Has many different functions, a router, a switch, it's a firewall. But in big networks, you don't have anything like this. In big networks, you have dedicated routers, dedicated switches. And I have some of those enterprise class equipment right here. And I want to show you this bad boy. Now, this one is an older device, but this is a Cisco 2800 series router. And this router is what you would plug in your internet, and then it would bring internet to the internal organization. And this thing is massively heavy, incredibly heavy, too heavy for my hands. So this is what it looks like. It's an old device, but trust me, they haven't gotten much smaller. So this is if you've never seen a Cisco router, this is what they look like. 2800 series Cisco router. Notice it has a power thing there. It has an Ethernet port on it, but it's in the back where all the magic happens. This is where you plug in interfaces. Now, we do use this to teach our Cisco classes, but this is where you would plug in the internet line. So this one can support a variety of, and you can see this interface right here, could support a variety of WAN lines. Different kinds of internet lines would come in here, and this router can support many of them. As you can see, we have many slots not being used. So a variety of different internet lines can come in here, and the organization would get internet that way. See, if you've never seen a Cisco router, they do come smaller, and they come a lot bigger. Some of them looks like a fridge, like those double door fridges. Some of them looks like that. So, and this is actually a small to mid-sized business router. Now, a switch. Oh boy, that thing is heavy. A switch. When you're thinking of a switch, I showed you this one. This one only has a couple of ports on it. In fact, this one has about 4 working ports on a switch. And there's a couple other ports there. One's a console port and a couple of WAN ports connected to the internet. But in a business, you need a lot more ports than that, right? In a business, you're not going to have 4 machines. You're going to have 50 machines. Well, here is how many ports is this one? 24 port Cisco 2900 series switch, I believe. Yeah, this is a 2900 series Cisco switch. Something like this would retail when they're brand new. Would probably retail for a few $1,000s. So would be the router. They retail for a few $1,000s, and you can notice all of these ports, and they're highly managed. You can really configure these in there. So in big businesses, this is what we're going to use to manage our systems. Now, if you really want to learn to configure these kinds of devices, especially these Cisco devices, Cisco routers, Cisco switches, that you're going to learn Cisco. Take your CCNA. Your CCNA great certification to get as your IT career progresses. But before you do that, get your Network Plus so you can get your basic concepts of understanding how networking works. And then you can go in and study how to configure these giant monster devices that I'm standing next to. In this video, we're going to be talking about wireless, and in particularly the different kind of wireless standards that are out there. And if you're currently using a wireless network, how are you going to secure those wireless networks? So what I have here is my Sonic Wall. This is Sonic Wall we've been seeing all the time. This Sonic Wall is a firewall, but it does have an access point built in, and it does allow for wireless connections onto it. Right now it's powered on, as you can see. And I'm actually connected to its web interface, and I want to go through some of the wireless settings with you, and I want to show you what your exam wants you to know about configuring these kinds of devices. Now, for this exam, you don't want to go in depth into this. This is going to be much more covered in A+, but I do want to review some of the settings with you, and I do want to review some of the things you should know for your exam. So let's take a look at the exam objectives. So the first thing up is you should know that wireless network is based on the IEEE. IEEE is the organization of where we make all types of standards for electrical equipment. IEEE 802.11. So 802.11 specifies the standards that we use in wireless networking. 802.11 comes in a variety of types. You have A, B, G, and AC are some of the standards that are out there. For example, the wireless standards of A and B are very old. A and B, for example, B was 11 megabits, which is very slow. G was 54 megabits, which was getting faster, and you had a few hundred megs on N depending on the connection, and you can even get over a gig on AC. It's very fast. A lot of us connected to wireless networks here in 2022. If you have some kind of a newer device that's been around in the last, I would say, 4 or 5 years, you're probably going to be using N and AC. You'll see that when I get into the configuration of this device, you can select the wireless standard you're using. Generally, the newer the standard, it allows more speed, more bandwidth through the line. As 11B was only about 11 megabits, which is very slow. But back in the days, you didn't have really fast internet. If you go back 20 years ago, the fastest internet was about 4 megs, 3 megs on a DSL. Cable modems were 6 megs, 10 megs. So if you had 11 megabits on your Wi-Fi, it was fine. They are going to come with speed limitations, again, depending on the standards. If you use an older standard like N versus AC, you're going to get slower speeds. Interference and attenuation. So attenuation is the longer you go away from the access, farther you are away from the access point, the slower your speeds get. Attenuation sometimes refers to cables. The longer a network cable is, the slower the speeds get, as it just takes longer for the data to traverse that longer cable. Same thing here with wireless. If I'm, like my notebook is directly underneath this access point, it's going to get a full connection with a very high speed. But if my notebook is very far away from this access point, it's going to be a very slow speed. So you want to be closer to it. All types of things can interfere with wireless signals, such as a concrete wall. Brick walls are major things. Different types of machinery and interference can affect different kinds of wireless standards. So you don't want to put too much obstacles in between it. So if you have your access point on another floor and you're directly on top of it, like let's say somebody's upstairs and is trying to connect to this, they're probably going to get less of a signal than somebody standing 20 foot away on the same floor, even though it's only 10 feet up, because of the floor of itself to get past for the signal to get through the floor in. Because there's multiple layers. There's sheetrock, there's a concrete, could be, there is thick pieces of plywood and all types of flooring material. Okay, so that's going to affect the signal. The other thing here we want to talk about is how do we configure our wireless network. Now, one of the things we should understand is something they call the SID. The SSID, the Security Set Identifier. When you click and you join a wireless network, that is called the SID. So when you click and you see the wireless network name, that's the SID. Okay? The SID is just basically the name of the network. You want to change the SID. Now, I didn't change the SID on this one. You're going to see that. Change it so you can be able to identify it and your users should be able to identify it. Change the default password on the router, the access point that you're using, because the default password on this, I think, was admin, or it was admin and the password was password. So if you're talking good security here, and you can have the best encryption, but if you have no real password on your device, they'll just log into the device and change your encryption. So you don't want that. When you join a wireless network, you must use some kind of encrypted session. Encrypted sessions ensures that the data that's transferred between me and my computer, the data in the air is fully encrypted. If there's any bad guys scanning the airways, what they could do is they can decrypt your traffic. They can actually go in there and say, oh, this here, I'm going to decrypt this traffic and I'm going to read your data. So they can steal all your information, your credit card data, your username and passwords to different websites. So you don't want that. So you want to encrypt the data. Now, how do you do that? Well, if you leave it in an open method, that's going to ensure that everyone can read your information. But sometimes you can connect to open networks and then join, and then it becomes an encrypted network. A captive portal is a very popular thing. If you've ever been to a coffee shop, especially in hotels, you join the network and you get that pop-up screen that says, welcome to Sheraton's Wi-Fi. And in order to do it, put your room number in, put your last name in, and then you can join the Wi-Fi for free. Or sometimes they may even charge you. It says, hey, in order to join our Wi-Fi, you got to pay us. That's called a captive portal. And that's just some form of authentication, identifying you or giving you some information. But what we want to do is we want to encrypt it. Now, there are basically three main encryption protocols that you're going to use. And there is a fourth one that I'm going to add here that's not listed in your exam objectives. It's called WPA3. So let's go through them. The first one is wired equivalency privacy. And WEP was one of the first wireless encryption protocol that we had when we created wireless. When I remember early 2000s, a lot of people had wireless, and the moment wireless would come out and people started utilizing it, they needed to be encryption so people don't steal people's data. Well, they created WEP. WEP was cracked almost the moment it came out. There was problems with its initialization vector, the encrypted parts of its encryption basically, that allowed people to break into your wireless and steal your data, steal the passcode to join your wireless network. And nowadays, it's really easy to crack. In fact, if you take my Security Plus class, there is a video where I show you how to crack WEP, just like that, in about 40 seconds. There's a lab I do, is a video of the entire lab where I enable WebP on this router access point. I connect to it. I use Kali Linux and just a few commands, and I show you how easy it was to crack a very big WEP key. Don't use WEP. When WEP was cracked, WPA came out, and WPA is a much newer standard, much better than WEP, harder to crack. Now, WPA was basically, the original one was a fix of WEP. It didn't last very long, as they eventually would make WPA2. This has been around for a very long time, and it's still being used widely today. It utilizes a type of encryption algorithm known as AES, or the Advanced Encryption Standard, which is technically unbreakable in today's world. WPA2 has been around for a long time. 99% of us is probably utilizing it. But I want to point out that there is such a thing as WPA3, which is the upgraded version of WPA2. So in today's world, we want to make sure we're using WPA2 and or WPA3. So let's take a look at the configurations of a wireless network. I always like to show you guys more of a hands-on approach. So I've already logged in to this device. All right, I've already logged into this device. And here I am at this Sonic wall. Where is my... Here we go. So here I am at my Sonic wall. So I'm going to go to admin. I'll put in the password. I'm not going to tell you what that is. That's a secret. Like, you should never tell your password. So this is this actual device. This is what its interface looks like when you want to configure it. Now, when you come to configure it, I'm just going to go to manage. I don't want to show you the overall settings. So when you first log in, it comes into this monitor interface, in which case you can see how many people are connected to it. You can see the throughput, how much data it's sending and receiving. I'm going to go to manage, and I'm going to go down here to wireless, and we're going to go to basic base settings. And in here, we can see that the radio row. So right now, it is an access point. It's allowing people to connect to it and then gain an internet, if I did have an internet connection connected to it. The wireless settings. So we're going to enable the wireless radio adapter so these antennas can work. And you notice the radio mode. And this is what I was telling you guys about. This is going to be your wireless standard. So you can see how you could select. Now there is frequency channels that I'm not going to get into in this course, 2.4 and 5 gigahertz. But you'll notice you have N, G, and B, G, A. You have NGB. You have A, so AC only, 5 gigahertz, AC only. This one also supports N, A, and AC. So variety of different standards you can select depending on the channel that you want to go with. For now, I'm just going to leave it as more of a mixed NGB connection. If I had wireless AC adapters in my house, I would have probably just gone with the 802.11 AC. The other thing here I want to point out is the SID name. So this is the name of the network. You notice that when I want to join the wireless network and I click on, where is my wireless network? Here we go. You'll notice how I joined this wireless network. It says Sonic Wall C55. Notice it's the same SID. So your SID is going to be the name of your actual network. In here, I can go to security. This is what we were talking about before. We were talking about the encryption of the data. So the authentication type, you'll notice you have web. You have open, and I said you don't want open. Open is basically going to allow anybody to join your network and just steal your data because your data is not encrypted and anyone can just join it. WEP was said was cracked, and there is WPA2. So most at home, we're going to use WPA2 with someone that's a pre-shared key. Notice this one doesn't even have an option for WPA, as it's not really used anymore. Why do we still have WEP? Well, you see a lot of wireless routers, access points still supports WEP. Why? Well, because WEP is actually used on really old legacy devices, and old legacy devices doesn't support WPA or WPA2, so a lot of them still have WEP installed. Okay, so you can actually go in there. I'm going to put WPA2. This one does not support WPA3. I said so this on your standard, and this would be your pre-shared key. This is where I would put in that quote-unquote Wi-Fi password, you guys call it. This is known as a pre-shared key that people would need to join the network. So if they know that key, they can click on your network and they can put that key in. But you should have at least WPA2 on it. Okay, so this is a good introduction here to wireless configuration, wireless access points, and things we should know about wireless standards and how to keep them secure. In this video, we're going to be talking about operating systems, different types of operating systems, and what will the operating system do for your computer. You see, every time you use a computer, whether it's something as your mobile phone, something as your big desktop, your laptop, your tablet, or basically any kind of device that carries a CPU in it, they will require some form of an operating system. Now, there are many different types of operating systems out there that we need to know for our exam. And they're going to fall into a couple categories. The first thing up we're going to have is the one you're probably using the most of. You probably spend too much time on your phone. Ever heard that before? Is your mobile operating system. Now, mobile operating system is going to be things such as your Android operating system that you're going to have, on your Android-based device, like I have a Samsung device. You have your iPhone OS, or the basically operating system that powers up on iPhone. Those are going to be the two most popular operating system when it comes to mobile devices. The other one here is going to be workstation operating systems. So workstation operating systems is what you quote unquote use to get work done. Now at home, you're probably going to have something such as Windows 10 Home Edition. At work, you're probably going to have something called Windows 10 Professional or Enterprise Edition. What this is that these version of Windows, such as Pro and Enterprise, adds more functionality to be managed in a larger network, such as joining a domain. Server operating system. This is going to be such thing as Windows Server 2003, really old, Server 2000, 2008, 2012, 2016, and so on. So you have all these different versions of Windows Server. But server operating system is not just on Windows. By the way, workstation operating system is not just on Windows. You also have your Mac OS X that Mac users use on their workstation. Other server operating systems that's non-Microsoft based is going to be things like certain versions of Linux, like Red Hat Linux. Enterprise Red Hat is a famous one. You also have different versions of Unix or FreeBSD, or BSD is a very popular Unix operating system that powers up a lot of different servers that are out there. So server operating system is going to be things, they come in mostly a lot of times in variety of Windows, Linux, and Unix. Is how you're going to get these operating systems. For your workstations, you're probably going to have mostly Windows and Mac OS X. For your operating systems, for your mobile devices, you're going to use things like Android. And of course, if you're using that iPhone, you got your iPhone OS. Embedded systems. So embedded systems are basically going to be operating systems that is built into the computer that boots it up. And this is not something that you're going to be installing. Let's say you get like an ATM machine, or you get something like like a washing machine or a brand new fridge that has operating systems built into them. Those are going to be embedded OS. I know an ATM machine that ran an embedded version of Windows on there. So embedded OS is basically embedded into the computer's, quote unquote, the RAM chips on them. In other words, they're not really like on a hard drive. The other one here is firmware. So firmware is basically going to be a BIOS of your computer. So your BIOS of your computer, when you put it on, you can go into the BIOS and change the setting. The BIOS, the firmware, is really what's talking to that lower level hardware. And your operating system talks to the BIOS in order to control the hardware. Another type is what we're going to have in cloud-based systems. And if you do virtualization, a hypervisor. Hypervisor-based operating systems is something that you install on the hardware, like you would on Windows, and then put virtual machines on it. Famous things of this would be things like VMware ESX would be a famous hypervisor-based operating system. You can also download Microsoft's Hyper-V standalone. So what these are basically operating systems that you install on your big server boxes, and then you put virtual machines on them. So these are some different types of OSs. Now, when you're thinking about an operating system, what does the OS do? Well, all operating systems are going to do a variety of tasks, basically everything that's listed here. That's going to include interface, is the interface between the applications and the hardware. So the operating system sits between all the applications we're going to be using, such as your Word, your browser, Excel, PowerPoint, and the hardware itself. So the operating system is like that middleman between the applications and the hardware. It's allowing the application to utilize the hardware. So let's say you're a gamer and you're playing your games. Your game requires direct access or good access to that video card and that heavy-duty CPU and RAM that you have. So what you need is the operating system to control that access. If the operating system is giving problems, you don't have the right OS, maybe you have a 32-bit OS, you can't access all the hardware. It's going to do disk management. It's going to allow us to manage our hard drive, ability to plug in a hard drive and format that hard drive. It's going to have the ability to partition those drives, connect drives, and access files and folders from different drives that we have that were plugged into our computers. Now, we did review hard drives such as solid state drive and magnetic media drive, such as a normal hard drive. And the operating system is going to allow us to mount those drives and use them. Process management and scheduling. So process management and scheduling is going to be when we have all these different processes or tasks that we have running. We can go in and kill those tasks if needed. The operating system should have the ability to stop a task. Let's say you open something like Notepad and you don't want it anymore. There should be somewhere in the OS to go in and kill it. At the conclusion of this video, I'm going to show you some of that. Application management, the ability to install application and uninstall application. You probably installed a few apps on an operating system before, even if it's just your phone, and then you would just hold it, press on the app, hold it, and then say uninstall. Memory management. One of the main things the operating system should be doing is managing the memory effectively. Now, I talked about 64-bit versus 32-bit operating system, as 64-bit can handle much more memory than a 32-bit one could. Good memory management is essential to you to correctly utilize all the RAM that is in your computer. Now, operating systems back in the days wasn't very good at this. We had to manage page files and things like that, but today they're pretty good. Every time you plug a device, think of plugging in a mouse, a speaker, a keyboard into your computer. The operating system is going to make sure to get those drivers, or you might have to install it and manage those devices. Another thing operating systems should be doing is access control. What this is the ability to control access to files and folders. Now, on a corporate network, you might go to a server and try to access one of the files, and the operating system will be like, nope, you don't have access to this type of information. Operating systems has the ability to encrypt data. When I get to file formats, I'll cover that. And by being able to encrypt the data on the drives, anybody that steals the machines, or if a hacker tries to get into the machine, you wouldn't be able to get it because it's encrypted. So it does do access control, which is controlling the access between the users and the objects, which is basically denying me access to the folder. And then, of course, encrypting the folders with good encryption. All right, so these are going to be some of the things that we want to be familiar with operating system. When it comes to your exam, be familiar that there's different types of operating system, and it controls all access to the computer, including managing your hardware, such as memory, and all the applications that's installed. In this video, I'm going to be talking about file systems and features. Now, when I talk about file systems, I'm talking about the ability to quote-unquote format a storage device, such as this memory stick or an external storage device or an internal hard drive, and be able to utilize it. When you first purchase a hard drive, like right out the box, when you first get it and you mount it into the computer, you can't actually add data to it. You have to first format it into a quote-unquote file system that the operating system recognizes and can store data on. Without formatting it, you can't store data. Now, most of these jump drives or USB sticks that we purchase already comes pre-formatted. But when you purchase one of the bigger hard drives, like I showed you, the 1 terabyte drives that I showed you in previous videos, if you use one of those drives, you're going to have to format it in order to use it. Now, the way when we format it, we're basically going to select a file system. And depending on the file system, it's going to depend where it's being used and if there's any limitations. So in this video, I want to briefly go over some of these file systems with you. So some of the file systems that we have, if you're on a Windows box, you're basically going to use NTFS is the default one which we're going to be using today. The new technology file system is a file system that's been around for quite a while, in the 1993s, I believe. NTFS allows you to have very large partitions or disk sizes, and allows you to have security, such as it's going to allow us to encrypt files, compress files, and set permissions on files. So when you format something as NTFS, it doesn't give you the option to compress it, which makes the file smaller on the drive. Encrypting it, when data is encrypted, anybody that steals your drive and tries to access it wouldn't have the opportunity to. It allows you to set permissions on the file. Permissions, so hey, Bob can access it, but Mary can't. Journaling, NTFS will do this too, because it's going to allow to track changes that's happening on the drive and be able to revert back. So journaling just means the ability to track changes. Certain file systems, such as NTF, such as FAT32, another file system format that was popular for lower versions of Windows. Think Windows 95, 98, Windows, even up to Windows XP, FAT32 is pretty common. But FAT32 is a file system that's highly compatible with a variety of different OSs. You can format something as FAT32 and use it on a Mac, use it on a Windows. But the problem with FAT32 is that it has a lot of limitations. It doesn't support disk spaces of more than 32 gigs. So we can't use that here because this is 128 gigs. So it does have a limitation of a file size of the disk size of 32 gigs, but it also has a limitation of the file size of only 4 gigs. You can't have a file bigger than 4 gigs. Now, if you have a DVD, a Blu-ray movie that's 10 gigs, you can't store it on a FAT32. So it does have limitations, and some of them will follow naming rules. Like when you're naming a file on that particular drive or that particular file system format, you may not be able to use certain characters. So some of them does have this. So going back here to the file system, NTFS is really just a Windows thing. All right, you can use this in Windows, and this is mostly going to be used on Windows servers, Windows workstations, because it has compression, encryption, permission all on there, and it allows you to set security. FAT32, you can use this on Windows and on Macs. You can use this for. It does have a lot of limitations. It doesn't support anything more than 32 gigs in size, and it doesn't support file size, individual files of more than 4 gigs. To overcome these limitations, they made a newer thing called exFAT. exFAT is very popular because it basically removes the limitations of FAT32, and it still allows you to interchange between Windows and Mac. If you're on a Mac machine, you're probably going to have the hierarchy file system. By the way, FAT stands for File Allocation Table. The hierarchy file system is mostly going to use on your Mac OS. This is generally for Mac OS. Extended 4 is going to be used on Linux OS. If you have your Linux box that you're using, L-I-N, let's just put Linux OS here. So on your Linux OS, you're going to have that extended 4. Now, what I do want to do is I want to show you what I mean by formatting a drive. And I want to show you, before I leave this video, some limitations when you're using something as NTFS versus FAT. So I am going to plug this in. So the desktop actually sits right on my table here. And I am going to plug this USB stick. All right, you guys can see it out there. Okay, so I am going to go in here to, I'm in the Explorer here. This is the drive that I just plugged in there, okay? This is that Lexmark USB stick that I plugged. It's 128 gigs. It comes out of 117. I want to show you guys something. When you want to use a drive, format the drive erases it and prepares it to be used to install file and folders. I'm going to right click on it and I'm going to say format. And you'll notice it's going to give me 2 formats. It's going to give me NTFS and exFAT. Now it doesn't give me FAT32 because this capacity is at 117. If it was under 32 or 32, it'll give you that option. If I go in here and I say exFAT, quick format, I want to show you something. This will be really quick. Look, it's formatted already. So now it's an exFAT formatted drive. How do I know? Well, if I right click on it and I go to properties, you'll see it says exFAT. If I open this and I create a folder, test folder, I'm going to right click on this and I'll go to properties. And I want you to notice something. It has 3 tabs: general, sharing, and customize. If I go to advanced, I just have compression is not checked, but I can encrypt data on it. But notice it's just 3 tabs: sharing, general, and customize. All right, just watch me, bear with me here. So I told you that exFAT is the upgrade to FAT. Okay. Now watch what happens if I format this to NTFS. I'm going to say, hey, let's format this to NTFS. Now, if you're using a Windows box, especially like Windows 10, all of your drives are pretty much already formatted as NTFS. Click OK. Click on close here. I'm going to right click on this. I'm going to open this up. Notice, by the way, when you format your drive, it erases everything. It prepares it to be read-write. So don't go formatting drives. You're going to lose all your data. Let's create this test folder again. I'm going to right click properties. And I want you to notice a new tab pops up. See, now we have a security tab. Now we can go in and set permissions. I can go in here and say, well, I don't want everyone to access, but I want Bob to access and not Mary, or only Bob alone. So you can set permissions. If I go into the general, I go to advanced, you notice compression is now available. And I can also encrypt it. So what this is showing me is that the file system that you're using really can help determine a lot of the features that you're going to get with certain file system. You're going to be able to get things like encryption, compression, and security while using NTFS. You may not get those in other file systems. In this video, I'm going to be talking about file management. So when you manage a computer, when you're using a computer, you should be familiar with what is known as file and folders management. Because using a computer on a day-to-day basis, you're going to generate a lot of files. You're going to save pictures, you're going to save music files, you're going to save Word documents, you might save your homework in a text file or something like that. And you should be familiar with things such as folders, also known as directories, file types, extensions, and permissions on them. So this is a quick video on this. So if you ever made a folder, you've done this. So in this video, I'm going to show you, hey, what's a folder and how are we going to make it? Then I'm going to show you file extensions and the file types and extensions that you should be familiar with. And then the permissions of how to set them. So let's go into this on here. And you know what? We'll just do it at the desktop here. Where am I? Here we go. All right. So I want to just create a folder. So when you're looking at a desktop, you go ahead and you make a folder. Let's call this my homework folder. So homework folder. So let's say you have a folder. So a folder is basically a container that's going to allow you to store files within it. Store folders inside of folders. So if I go in here, I'm going to make a folder called homework, and then I'm going to create a new folder inside of it called math homework. So in here, I'm going to have all my math homework. Now, in this folder, when I open it, you can create files. So in here, you can save files. So let's say you're using a Microsoft Word document. And this is homework. This is math homework. And I could save this. If I know how to spell homework would help, right? So I'm going to go ahead and save this. File save as. Go down here to browse, and we're going to select the desktop where we saved it. And here we have the homework folder, and here we have math, and we'll say, okay, this is a math homework save. So I'm going to close this out. So in here, you notice, you saw it there. If I double click on this, I go to math, and here's that math homework document. Now, this is basically what a folder does. This is what a directory is. It is a place where we are going to store files. Now, in here, you're going to have a variety of file types. Now, I have already file types put on to see the file, what's known as the extensions. If I go to view, okay, you see right here, there's something that says file name extensions. This is something you're going to want to be familiar with as your career grows. So if I go to file name, you notice it doesn't. Now, by default, this box is not checked. So if I go in here and I check it, you notice that the extension of a Microsoft Word document is .docx. As your career starts to grow, you're going to become more and more familiar with the different extensions that are out there. For example, if I make a new Excel file, where is Excel? Somewhere around here. You probably saw that before I did. Here's a new Excel file. .xlsx is an Excel file. So if I open this here would be an Excel. If I make a text file, that would be a .txt. So as your career progresses, you're going to have to start to learn file extensions. So the moment you look at a file without having icons like we have on these, because sometimes you may be looking at them at a command prompt and you're not going to see an icon. So the moment you look at them on a command prompt, you can say, oh, okay, so that is a text file. That's a Word document. That's an Excel file. That's a Microsoft project file. Executable programs are going to be like a .exe. So .exe is a program, an application that you're going to execute. You see, if I go to things that I have downloaded on this machine, you'll notice the Wacom tablet driver we downloaded before is a .exe. So that would be a file, an executable program. Now, one thing I do want to mention to you guys is when you're setting up on larger corporate networks, what they do is they set permissions on the file. So Bob can access it, but Mary can't. To do that, let's say you want to set permissions on your math folder. Maybe only you can access it. So you would have to right click on it. You would go to properties. You would want to make sure that you're stored on an NTFS. If you remember in the previous video, we talked with file system format. If you don't have NTFS, you can't store it. So I'm going to go to security. And in here, you can set permissions. Now, I'm not going to set it. This is something I teach more when I teach Security Plus. We'll get into this. But just know you can set permissions on these folders. And when Mary logs in and she tries to double click on it, let's say access denied. This is mostly done on a file server that's being shared across a network, by the way. So the thing here I want you to get out of this, remember, folders are used to store and manage files on your computers, including all the folders. When you have a folder in there, you should be familiar as your career starts to progress, you should become very familiar with different file extensions. Now, your exam doesn't have a list of them that you need to know, but as your career progresses, you're going to know .docx, okay, that's Word, .xls, okay, that's an Excel file, .exe, that's an executable file, .bat is a batch file, scripting file. You're going to eventually learn these things. And then eventually, hopefully you get up to the security part of it and you start setting permissions on folders. For an operating system to stay running, you're going to have a whole bunch of little tiny programs that's running behind it in order for it to run properly, or in order for it to do all of its function. An operating system is not just one giant executable file that just runs on your computer. In fact, it's a whole bunch of little programs that's running in the background of your computer all the time. Even if you think, your computer's not doing anything, I'm not using it, I'm not downloading anything, I'm not on the internet or anything, it's still utilizing a ton of resources in order to keep itself running. Those little programs that are running, more than likely is going to be a service. Services are basically little programs that we run in the background of our computer in order to make certain things work, make the OS does its function. Every time you go to File and you say Print, there is a service in the background called the print spooler that controls access to all the printer. If that service isn't running, you can't print anything. But it's not something you start or you install, it just comes with your operating system. Also related to services is something called a process. This is going to be a small program that's running. So if you open like Microsoft Word, it'll create a process with Word. Or if you open like Notepad, it'll create a process with Notepad. Sometimes these services themselves run a variety of different processes. Now, the operating system will manage the drivers. And I went over this with you when we did hardware. When we install hardware into our computer, we have to install the drivers. Now, I did go over this in the hardware section. One thing I am going to show you right after I'm done here is going to be utilities, in particular the task schedule. The operating system has a variety of utilities to manage itself. One I showed you earlier was the utility of Device Manager. It does have a variety of command line utilities, and I want to talk to you about Task Scheduler. This allows you to schedule tasks on your computer to run at a specific time. And then the last thing here we'll take a look at is interfaces. Anytime you use a computer, there's generally two interfaces. The Graphical User Interface, or GUI, G-U-I. Now, things like Windows and Mac is famous for having really good GUI. Linux, on the other hand, doesn't have the best GUI out there and misses a lot of functions, depending on the distro of Linux, by the way. So they're very good at their command line. Now, Windows has a command line, Mac OS has a command line, all your different versions of Linux and distro. Even Mac technically is a Unix operating system. So command line is going to be that black screen with white text. So I want to show you guys a couple of different applications that especially like task scheduling and where to find services and processes in your operating system. You better understand what I'm talking about. Where is my desktop? So here we go with my desktop. So what I'm going to do is I want to show you guys the first thing up, your services. So your operating system runs a lot of services. To get that, I'm going to right click on Start. I am going to go up here to Computer Management. Now this is going to take a couple of seconds to open there. And I'm going to go to Services and Applications. And you see Services. This is all the services that Windows has in it. And you see it says running. This computer is not really doing it. I'm really just running PowerPoint and a video software, video editing software on it. And you can see all of these different services that are listed here. And as your IT career go on, you're going to learn more about them. And you're going to learn specific information on different services that are out there. So the one I was talking to you guys about, it's like this one, the print spooler. And it, like right now I wouldn't be able to print because the print spooler is turned off. Now I disabled this thing for a reason in a previous class I was doing. So this is a service that you can right click. I can go to properties and re-enable the service. Now automatic means that when I restart the machine is going to start. And then I can go ahead in here and start the service. And now I'm running a service that I have. Now I talked about processes. Processes, I'm going to right click on my taskbar and I'm going to go to Task Manager. This is going to show me all the processes that we're running. So like right now I have Chrome open here. You can see it is a process here. So I can go in here and kill this entire process. I can right click and say End Tasks and just, there you go, it's finished. And here are all the different processes that I'm running within the computer itself. So this is going to be my Task Manager. Now the other one that's mentioned in our book is something called Task Scheduler. So I'm just going to go start typing in there. By the way, when you're looking for an app in Windows, the fastest way to do it is just go to Start and start typing it. Task Scheduler. This is a software that you can go in here and you can create a task. And what this does is that it's going to allow you to create a task to run at a specific time. So you can have a certain application execute at a specific time and date of your choosing. So let's say you want a certain executable, maybe because it cleans up your operating system, to run 2 o'clock in the morning. You can go in here, set this up, and you can allow that task to run. You leave your computer on at 2 o'clock in the morning, so you have to be up for it. Maybe it takes a long time to run. The other thing that was mentioned in this presentation was GUI. So what you're looking at is the graphical user interface. If I go to Start and I say RUN, I say run and I type CMD. Now, you could have gone to Start and type CMD. I'm just so used to going to run. And I press Open. This is the command prompt. So from here, you can do a variety of things. Like you saw me run ipconfig, and I can run a variety of utilities on this computer. I can pretty much control most of Windows from it. So that would be a command line. All right, very good. So quite a lot here was covered. Services, processes, drivers, utilities, we looked at a few, and the interfaces. So remember, when using an operating system, don't think it's just one big program. It's a whole lot of programs that's running in order to keep your computer running efficiently. In this video, I'm going to be talking about different types of software. In particularly, we're going to take a look at productivity software, collaboration software, and business software. Let's get into this. So as you're using your computer on a daily basis, you're basically not really using the operating system much. You see, operating systems are more like storage containers and the ability to manage applications. It's really two of its main functions. It stores your data for you, and it's going to manage your applications. As throughout the day today, we interact with these applications. That's what we're using. So for example, what are you guys using most of the time? You're probably on a web browser somewhere, such as the Chrome web browser or Firefox web browser that you're using to surf the internet, right? But there's a lot of other software that we use to do work. For example, productivity software. So productivity software are going to be things like Microsoft Word. Microsoft Word, standard word processing software that you can use to type documents. Spreadsheet software like Excel allows you to do calculations and functions on it. Presentation software like PowerPoint that's going to allow you to basically create an entire presentation to present to audiences like I'm doing right now. The other one is going to be visual diagramming software like Microsoft Visio. Microsoft Visio utilizes something called stencils. These are like templates you're going to use to create visual diagrams. I'll show you what that looks like in a second. Collaboration software. Well, you have to collaborate. You have to talk to folks around the world. You're probably going to be using an email client like Microsoft Outlook. We also have a web-based email client like Gmail. Conferencing software. You guys may have heard of Zoom or GoToMeeting. That way you can connect and view each other's camera and have a conference with each other. Instant messaging software like Facebook Instant Messenger. Who remembers AIM? Very long time ago. AOL Instant Messaging software. Online workspaces, similar to how you would have like Zoom software and document sharing. You can do this with cloud services like Dropbox. So this allows you for me to create a document and then send you a copy of it or share that document. Other software you can have is what's called business software, like database software. Now, coming up later in the course, we do have a section on databases, and I'll show you a little bit of Microsoft Access that's used to create a very simple database. But you do have more complex database systems like Microsoft SQL or Structured Query Language Systems. Project management software like Microsoft Project that's going to be used to manage a project, all the different tasks it takes to complete a project. Business-specific applications. It's not uncommon to have a business with their own custom application. Here at TIA, we created our own custom application to manage our schools. So this is something that's very specific to your business that you're only going to get in that business. And then accounting software. I'll show you one of those, like QuickBooks. QuickBooks is very powerful and popular accounting software. It's going to allow you to take payments. It's going to allow you to invoice your customers. It's going to allow you to pay your bills and track all your accounting tasks. QuickBooks, Peachtree are popular small business accounting software. Now, I do have a few of the software here to demonstrate, and it's really, if you've used computers before, it is very, very basic. Very basic. Because I'm pretty sure that all of you guys have used, at some point, all of you guys have used Microsoft Word, Excel, PowerPoint. So let's go take a look at this here. Let's take a look. Here we go. So the first thing up I want to show you guys is going to be, let's take a look at a word processor. So this is Microsoft Word, right? I'm pretty sure you guys are familiar with this. This is where you can type, if I could spell type would be helpful. Type a document, right? And you would save this. I did this already for you. The other one here you have, this is a spreadsheet. This is Microsoft Excel. So spreadsheets allow you to run calculations and manage large data. And then a big part of Excel is not just storing the numbers in here, but it's the ability to make a function, such as a sum function, and add up the numbers. Now, this is not an Excel class to teach you what I did there, but this is basically a function that adds these two numbers. Whatever I put in here, it adds it here. If I go in here and change 6, continues. So this would be considered a spreadsheet. The other one here I have to show you guys is your presentation software. So this is creating slides like I have as I'm presenting the course to you. You can go in here, you can add slides, make a new slide, put a title, add bullet points, point number 1, and so on and so on. The other one here we have is going to be, this one I want to point out to you, as people have gotten questions on this one. You see, in the exam objectives, there's something called visual diagramming software. This is Microsoft Visio. Microsoft Visio is a diagramming software. It allows you to create what you see here, things like basic network diagram, but it allows you to create like flow charts, functional charts, organizational charts, and it used this by utilizing a variety of different block diagrams that you can put together. When you create a good diagram, you can then save it as what they would call a stencil, and you can then reuse this stencil. So let's say you make a network diagram and you save it as a stencil. You can then reuse that stencil to make a new network diagram building off of that one. So you can make like a default one and then just keep adding to it as time progresses or keep changing it. So that would be called a stencil, is used on like a Microsoft Visio document. When it came to collaboration, here's your email, right? You guys should be using Microsoft Outlook to send and receive emails. Good collaboration software. Another one I have here is going to be, now when we're coming into business software, I do have a couple. I have this is Microsoft Project. This is tracking all my tasks. So in this one, I'm setting up a network. I have to purchase the equipment. It takes me 5 days to do that. I have to remove the old equipment. I have to install the new equipment and so on. So this is tracking all the tasks and how long the project will take to get done. This is project management software. This is Microsoft Project is the name of this software. I also have, in this one here, this is QuickBooks. This is one of the most popular we have in terms of billing or accounting software. In a software like this, I can go in here, go to my customer center, and you can manage your customers from here. Now, QuickBooks is also known as one of the world's most slowest software. So I can go in here and I have customers here. I can go in here and create invoices for these customers. I can receive payments from them. I can go to my vendors and enter bills from them and pay your bills. And it, of course, manages all your bank accounts. So this would be considered a banking software, an accounting software. The last one here we'll take a look at is going to be a database. Now, we're going to come back to this much more in specific when I get to database management. But Microsoft Access basically allows you to manage your databases. And this is going to allow me to store data. It's a really simple database software that you can use to make a very simple database instead of going through something complex as SQL. As you can see, there are many software that we use when you're utilizing a computer. Remember something, an operating system doesn't really have much features. You can't really sit and do much with it. It's there to be that interface between the applications we're spending time with and the actual hardware. So it's managing all that hardware while also managing the application is really the purpose of this. But most of the time as a user, we spend almost all of our time utilizing a wide variety of applications. When you are installing an application on a computer, you have to remember that there could be a variety of different ways to get that application installed on the machine. A lot of times we just download application right off the internet, we double click the executable file and we just install it on our computer. Now what this is known as locally installed applications. Now locally installed applications means that there's no network required because you could have just downloaded it and it's on the entire application installation is on your computer. Or sometimes we can be installing it from a USB stick, or if you have CDs or DVDs, you just install it right off there onto your computer. So there's no network required. It exists only to you and you alone on your computer. And all the files are stored locally, like on your C drive or your D drive or something. So basically the application is localized to you. Another way of doing this is local network hosted. In other words, there's a network within your business or within your office where the application is stored there and you access the application from one of the servers in there. Internet access is not required for this type of local network hosted application because you're not going outside your network. For you to go outside the network and access it from another person's network, then you would need internet. Some applications are going to be cloud hosted, and you've used quite a lot of these. The whole concept of like Google Maps, Gmail, those are full-fledged applications. LinkedIn is a full-fledged application. A lot of these are just hosted by a third-party provider, such as Amazon or Microsoft. And these are going to be internet-required applications. You will need to subscribe to a service, or at least get it for free. Like LinkedIn would give it to you for free. But a famous business software like Salesforce wouldn't. You would need to purchase that. All the files are stored in the cloud and all the data is stored in the cloud. Think about how much data you have on LinkedIn. You have your resume data, all of it, your certification information. That's all that data stored in the cloud. If you're using something like Salesforce, all of your sales data is stored in the cloud. Now, if they decide to close it off or you don't have access to it, you don't have access to your file. Another thing we want to talk about that you really need to know for your exam, as you should expect a question on, is what's called the architect models. And this is how application is installed. So let's say you have the application installed locally. If you have the application just on your computer and no one else can access it, this is called a one-tier model. In other words, it's just one computer there that has the application, you install it locally. This is the equivalent of downloading it, putting it on a CD and just installing it, or having it on a CD and just using it on your computer. But in bigger networks, we're not going to have that. In bigger networks, what we're going to do, we're going to eliminate this. All right. In bigger networks, what we're going to do, put back on our pen. In bigger networks, we are going to have a server hosting it. So you have a workstation, you have a server hosting the application. So in that situation, you would have to go to the server to grab that application. Whether this is a web application or just a full-fledged client application is being hosted on the server. This would now be, as you can imagine, a two-tier design. The other one is called a three-tier design. In this one, that server that's hosting this application would need some kind of database. This database would hold the data, all the records would be stored in this database. The server would then access it, and you would access the server. This is called, as you can imagine, a three-tier design. So a single tier, remember, is locally installed. A two-tier design is being hosted on a server. Three-tier design is when that server has to then go to another server to get it. N-tier, N is just a variable. This could be means 1, 2, 3, even 4 tiers for more complex setups. And it's just telling you, it could be any amount of tiers needed to get the app to work. When you're working at home, mostly, your applications are probably going to be stored locally. But don't be surprised that when you go to work or in business environments, the application are generally going to be stored on some kind of server or maybe even in the cloud where you're going to need to have internet access to access it. In this video, I'm going to be talking about configuring your web browser. The web browser is a place we probably spend most of our time on, especially in today's internet age. Whether you're surfing social media, you're doing work on something like LinkedIn or some kind of software as a platform, software as a service, web service like Salesforce or some kind of accounting like QuickBooks Online. In other words, you're going to spend a lot of time, whether you're at work, at home, you're just doing it for pleasure on your web browser. So there are a couple of things that we should be familiar with. Number one, when you use any web browser, they're going to keep a cache of all the websites that you've been to. Every once in a while, you may want to clear that cache or clear the history of the web browser. Client-side scripting. There are settings that we can put in a web browser that's going to allow us to disable certain scripts from being run. Sometimes you go to certain websites and they may execute a certain script on the browser to make the website work well. But sometimes those scripts contain malicious software and can infect your computer. In big administrative networks and big enterprises, they utilize certain software to disable that. But you can also do it with local options on your computer. Browser add-ons. You can add, remove, and enable and disable a variety of different extensions that you could have. Extensions such as, very popular, pop-up or script blockers. A lot of people install pop-up blockers, and you can just go to Google and look for pop-up blockers for your browser, and you would install them. That way when you go to a website, it doesn't pop and you don't have a bunch of pop-ups all over the place. People go crazy when they see pop-ups on their machines, and pop-up blockers is a great way to stop that from happening. Or script blockers too. One good thing is the Chrome now has incognito browser. Every time you browse, it stores every time you browse using a web browser normally, it stores everything about you. It knows everything about you. It knows where you've been. It stores where you've been. It tells all the websites who you are. But in certain web browsers, you're going to have incognito or private browser. What this does is that when you go out on the internet, it hides who you are. Nobody could see your identity on the internet. So I think this is pretty cool, especially when you're using it. In fact, something I use a lot. I'll show you how to do it in a minute. Certificates. When you go to a website, okay, you should look to see if the certificate is valid. And if it's not, the browser is actually going to tell you. We covered HTTPS, if you remember from earlier. In HTTPS, I told you if you don't see the S at the end, it's not secure. But sometimes you go to a website and it is the S at the end, but the certificate is expired or it's not trusted. This means that somebody installed their own certificate and your browser doesn't trust it. If you ever see an error that says this certificate is not trusted, don't go to that website. The certificate is not valid and your browser is not trusting that website. So it should be valid. Don't make it invalid. Proxy settings. Proxy settings is what you're going to set on your browser in order to go through a proxy server. Now, a proxy server, you've probably seen this before. You ever been to like a university or a business where you try to access like yahoo.com or google.com and it redirects you to a whole nother website that says, hey, you can't go there? Proxy servers are used to control internet access. It used to limit websites. On browsers, and as technicians, we sometimes configure the proxy settings. I'll show you how to do that in a minute too. Compatible browsers for applications. Certain apps may need certain browsers. Back in the days, it was very popular that certain applications would only run on Internet Explorer. Nowadays, a lot of the applications work across many of the browsers. But once in a while, you may find an application or a website that works best in one browser over the next. Now, there are many, many browsers out there, from Firefox to Chrome, Google Chrome, Microsoft's Edge browser, older style, Internet Explorer, Safari, and so on. Many browsers. You just have to make a choice on which one you want to use. You could be on a Mac right now and be using Chrome. When I use my Mac, I use a Chrome browser. I don't use the Safari browser. It's more of a preference. So in the rest of this video, what I'm going to do is I'm going to show you a couple of settings on your browser that we just spoke about. And my favorite browser is the Chrome browser. So here I have my Chrome browser. I'm actually going to go to the little dot there. Open this up. And the first thing I want to show you is incognito. So this is the incognito. So when you are browsing here, anything that I look for, anything that I search for is going to be cleared. It keeps you as private as possible. So this is known as private browse, so people can't see your activities. This is good. The other thing here, I want to show you a couple of options. If you go to history, and we go to history here, you can see all the things I've been on YouTube here, looking at the TIA A channel. You should be clearing your browser. This is going to be clearing the cache on the actual browser. Let's go back here to settings. A couple other options here that was mentioned. What else more we have? So let's go to extensions. And extensions, if you have any third-party extensions that you downloaded, maybe some pop-up blockers or anything, you can go in here, disable, remove them if needed. The other one here is going to be proxy settings. So we're going to go to settings. And if you're a technician and you're configuring a proxy for your organization, you would just go to system. You would click right here. And then if you have it set automatically, or if you want to manually enter it, you can do that here too. This should have to get from like your system administrator what those settings would be. Okay, so this here are some of the settings that you can do in a browser. And every browser is going to be a little different of configuration. Edge is going to be a little different than Safari, but they're all basically going to support all the different things that I spoke about. When you purchase software, you're going to want to make sure that you understand the licensing requirement. And in this video, I'm going to talk about those licensing requirements. You see, when you go out and you buy a software from the store, for example, you buy it only for you to use, and it's a single use. You can only install it on one computer, and you can use it on that particular machine. That's called a single-use software. Now, when you purchase software like this, let's say you go out and you buy a game, or you buy Microsoft Office for your computer only. It's basically just for one computer. And it's more than likely, a lot of software being sold today is what's called single platform. Single platform is software that can only be installed on one platform. Like it's only for Windows or it's only for Mac. Things like Microsoft Office has Office for Windows and Office for Mac. Now, there are some software that are cross-platform compatible. In other words, you can install them on Windows or Mac. But this creates some compatibility. Sometimes installing a software on Windows and then installing that's the application maker makes it for the Mac, it may not work as well, or vice versa. Maybe something was made for Macs, but doesn't work too well on Windows. Now, going back to the licenses, you have a single license. In other words, you can install it on one machine and just one machine. Sometimes organizations buy what's called a group license or a site license. If they have whether it's 10 users or 200 users, in that location, they can install as many times as they like, only in that site or that building. So if they have 10 buildings, they would just buy 10 of these licenses. This would probably be cheaper than buying one license for each user. Sometimes you want software to run multiple instances at once. So I install the software and I'm using it. You install the software, you're using it at the same time. Sometimes we must purchase concurrent licenses. In other words, have the software run multiple times at the same time. Open source versus proprietary. When you sell software, when they say open source, you should know this term for your exam. When they say open source, the source code that underlies the software is known to the public. Everyone can see the source code. Proprietary software like Windows versus Linux. Linux is open source. Windows is proprietary. Proprietary software, no one can see the source code. Microsoft owns it. They compile it. You don't see it. If you look at Windows, all you see is ones and zeros. You don't see the actual codes itself. Open source, you can see the code. Now, open source software is generally free. There's always a free version of it that you can see. A lot of times, vendors that have open source software, they're charging you for the support and the maintenance of that software. So remember, with open source software, you can actually edit the source code if needed. This has ups and downs. Think about this. If you have access to the source code and there's a problem, you can fix it. And because a lot of people can see it, there may be less errors and bugs and security flaws. But it also works the opposite way. If everyone can see the source code, they can discover error, bugs, and security flaws faster than they would in Windows, right? So they do have their ups and downs. Sometimes you can purchase software one-time purchase, like you would buy QuickBooks for $300, you're done. Versus subscribing to QuickBooks and paying them $20 a month for the rest of time. You would have to determine whether a one-time purchase is better than a subscription. A good example of this is Adobe. Adobe Photoshop, Illustrator, InDesign, Premiere, and all these software that they make are hundreds of dollars per software and then thousands for the entire suite. Or you could just pay $30 a month, and as long as you keep paying them, you can keep using them. That's up to you whether you find one is better than the other. It's the same software, it just depends how you're using it. When you purchase software, you're always going to get some kind of product key or serial key of the software to run. It's just a number that you're going to type in and get the software to be installed. Now, software installation best practices. Well, number one, a lot of times people install software, you click next, and you see a licensing agreement that says you agree to this. I don't know if anyone have ever read that thing. I know I haven't very much. I don't think I've ever read a full one. It's called the user license agreement, EULA it's called. And you should read that to agree to what they're saying they're going to be doing to your machine. A lot of people just click I agree and click next. How many of you read the instructions? Way too often do we install software but not reading the instructions. The first thing you should do when you download or get software from the store and you want to install it, read the directions, right? RTM, read the manual. Remember that. Advanced options. When you install in software, it may ask you, would you like to install this? Would you like to configure this? Would you like to change this? Those are going to be considered advanced options in the software. Certain software has this, some don't. Complex server software will definitely have this. So as you can see, installing software and buying software is not just a simple task as buying and installing. In the world, in corporate America, there's many options you can use. Whether it's a site license, it's a number of license, it's license per processor, per machine, per server, per workstation. It gets very complex, as you can see, all the different varieties and ways of purchasing and licensing software. Every single piece of software that you've ever used in your life, whether it was turning on a TV or using an app on your phone, was coded by someone or something. And in this section of the course and in this video, we're going to take a look at some of the programming languages that are out there that programmers or software developers use in order to code their software. Now, coding is not going to be a major part of your exam, but you may get a question or two on this particular topic. You may have to read some if statements, which I think are pretty simple, but there's some terminologies that you want to be familiar with. Maybe 3 or 4 questions on this entire section. So let's get right into it. And I'm going to be looking at different kinds of programming languages that are out there. Now, you don't have to be a master of them or be able to identify them, but you should be able to understand, okay, this is what an interpreted language is versus a compiled language. So let's go take a look at this. So right now I have a series of different kinds of programming languages that are out there. And the first one we're going to talk about is something called interpreted language. Interpreted language is this. So when people write code, line by line by line of codes, and I have examples of all of this I'm going to show you after this. When you write an interpreted code line by line, the way the computer reads it is that it's going to read one line at a time. It reads this line, then it moves to the next line, then it moves to the next line, then it moves to the next line. Those are generally what interpreted code is. It doesn't have to be quote unquote compiled. You see, computers don't read human language. It doesn't read alphabets. It doesn't read ABCs and statements. What it reads is what's called machine language, which is generally ones and zeros. So in an interpreted code, the computer reads the code line by line, translates it into machine language, and tells the computer what to do. Now, in that, there are 2 kinds of basically interpreted language. You have what's called a scripting language and a markup language. Scripting language are like JavaScript, Python, or Ruby. Maybe you've heard of some of those, JavaScript being incredibly popular, so is Python. A markup language is when they use tags in order to mark up and tell the computer or tell the instruction sets what to do with that particular command. A markup language are things like HTMLs or XML. Now, I'm going to show you guys, again, let me finish this slide, and then I'm going to show you guys actual examples of what these things look like. Another one is called a compiled language. Now, compiled languages are things like C, Java, or C++. Now, compiled languages, what these are basically, you write them in, you write all your codes. It then has to execute it compiles all the code into one giant executable file. And then it turns it into machine language in the computer to read it. So it doesn't read line by line. It basically turns the entire thing into machine language and then executes it. So compiled programming language is very famous for making giant programs. Like a lot of Windows is programming C, for example. Another one we're going to have is what's called a query language. So query language is mostly used on databases. This is going to have the ability to go out and grab information from a database. So a database is a giant software that basically stores bulk information. And a query language is what we're going to use in order to extract data, manipulate data, update data in a database. Like, for example, I have a structured query language, or SQL. The closest to machine language, which is literally ones and zeros, is called assembly language. Now, assembly language isn't really used too much in today's world. It's a very complex language. It's considered a very low-level language, and it's a very complex thing to learn. So a lot of programmers actually don't use it. It's as close as you're going to get to programming hardware, or programming the hardware to do a specific set of instructions. Now, what I want to do is I want to go through some examples of this for you. And I have a bunch of examples in it. And I want to introduce you to a very popular website that you guys should get to know. And that's going to be a website called, I forgot to put it on my desktop. This is going to be a website that we call W3 Schools. W3 Schools is a great website. If you're looking to learn coding or you're looking to get some commands going, W3 Schools is a great place to do because they have great tutorials and you can execute the code right there. For now, I just want to go through a few things here with you, just to give you an idea of what these codes look like. So the first thing I spoke about was what was called an interpreted language. And here I am at JavaScript. So I said JavaScript was an interpreted language. And here's an example of what JavaScript looks like. Now, don't get scared. Don't run away yet. Don't stop the video. JavaScript, all I want to show you is that the way the computer is going to read this is that it's going to read one line at a time. So it's interpreted and it's reading this. So if there's an error, like in this line, it'll stop the code from running. So it's an interpreted language. The other one I mentioned is called a markup language. HTML is a markup language. And you can see here, they're making a table. And in this table, you notice all these tags, open tags, close tags, open tag, close tag. So these are going to be the header of the table, and these are going to be the values within the table. When you execute this code, when this code is executed, it looks like this. It turns into a table. Now, you're pretty familiar with HTML because HTML is what powers up all your web pages. All the websites that you're going to today is in some form of HTML format with additional codes there. So this, by running this, you would get this output. The other one I spoke about was what was called a compiled language. We said like C or Java or C++. Here is C++. Now C++ is going to be a compiled language. So in this one here, you can see this is C++. And one of the most, when you start learning programming, the first thing you're going to do is output something to a screen. So here I have C++. Now, in order to run this code has to be compiled. And they actually compile it on the website. And when you run it, you'll see that it'll give me the output. So I'm saying output, hello, I am Andrew. So that was the output that I'm putting there. The other one that I wanted to tell you guys was what's called SQL. So the structured query language. So structured query language, SQL, what SQL does is that it extracts data from a database. So in this in this example I'm showing you, there's a database, and in your database you have tables. Now we're going to come back to databases later on in the class, and we have a whole section on it. But this is a SQL command. What I'm saying is select the top 3 records from a table called customers. So when I run this, it basically gives me the top 3 customers in a particular table. So what are SQL languages or query language? It's used to extract data from particular databases or data sets, we can also say. I know coding and programming may scare many people. It's not everyone's cup of tea. Trust me, I know it's not my cup of tea. I know how over my many years of doing IT, I have gone through and I've read many scripts. I've written Python scripts. I've manipulated JavaScripts. I'm not the best programmer out there. And you don't have to be in order to work in technology, unless programming is what you do. Some of us like to program and some of us don't. But as an IT technician, you should at least understand what different languages exist and how to read some of the scripts that you yourself may be writing in the future. In this video, we're going to be going over some interesting software development technique of when programmers are basically writing codes. And I want to show you guys some pretty cool stuff that you're going to see on your exam, and that's how to use what is called conditional statements or logic operations on code. If you've ever wondered, how does a computer make a decision? I'll give you a brief overview of how that works, because it's all you need for your exam. Let's get into it. So one of the things I want to mention right off the beginning is something called pseudocode. Pseudocode concepts. What the hell is pseudocode? Well, pseudocode is what programmers write when they don't want to write the actual code word for word. So let's say me and you are programmers, and we're trying to write a program that, well, if the dog is big, then the dog is very nice. If the dog is small, then the dog is not nice. You ever seen those small dogs that make a lot of noise? So pseudocode would look like this. Pseudocode would say something like, if the dog is equal to big, then nice. If, I should be an F there, if not, then bad. That's a pseudocode. I literally wrote the pseudocode for you. So what the pseudocode is doing is that it's just the way programmers think. It's not the actual code. It doesn't have all the syntax needed. It doesn't have all of the little tags that goes here and there and this and the open parentheses and close parentheses, basically all the rules that are needed in a particular language. The interesting part about pseudocode is that it's basically applied to any language. Whether this particular if statement, we can use it to apply the logic we're thinking about to things like Java or JavaScript, C++, Python, and so on. All we're doing is we're just writing out the code in easy to form, easy to understand human languages that anyone can basically read. So that's called pseudocode. They're basically easy to read. And they basically can be applied to any language. And remember, it's just something you write basically on a piece of paper, like I just did. The other one is called a flowchart concepts and sequence. So flowchart concepts is when programmers are writing, they design little flowcharts. They say, well, if this happens, then do this. And if this happens, then do this. If it doesn't happen, then do this. They're basically creating the logic of the program using a variety of boxes and diagrams. I actually have a picture of that. I'll show you that in a second. The next thing we're going to be looking at in real time is something we call logic components. Software has to make a decision. And this is generally done with some kind of conditional statement. It'll basically say something like, okay, if this person is doing this, then you should do this. If this person clicks this button, then do this. If this value is entered, then do this. For example, if they buy this product, charge a sales tax. If they buy this product from this state, charge this sales tax. If they buy this product from another state, charge this sales tax. Every piece of software has to make some kind of decision, some kind of logical operation. This is mostly done with what's called an if statement. The other things here we're going to take a look at is called branching and looping. I'll show you an example of a loop. So branching is basically when you're writing the code and there's a lot of code. So you're like, a lot of this is using these if-then statements. So it's going to be like, well, if this is happening, then jump down multiple lines of code. So branching is like, okay, I know there's a lot of code here, but if this statement is true or false, then skip down to this statement at the bottom because I don't need this code in the middle. Looping allows codes to be run over and over to form some kind of pattern if needed. That is a variety of different loops like for loops and while loops. I'll just show you an example of a for loop. So let's get in here. Let's get in here to the example section of this. So let's go back here to my desktop. And the first thing up I want to talk about is something called a for loop. Or basically a loop. Now you don't have to worry about all the different kind of loops that are out there. There's for loop, while loops. Just know what is a loop. And I'm just going to give you a brief example of one here. Now remember what I told you guys, what exactly is a loop? Well, a loop allows codes to be run over and over. For example, here's something. If I ever want the code to output 1, 2, 3, 4, what do I need to do? I would have to write a code that says output 1, output 2, output 3, output 4. Or I could use a loop to tell the computer to output as many times, as many numbers as I want in a way that increments it. So I want you guys just to, you don't have to, okay, just let me tell you guys something. You don't have to be able to write this stuff for your exam. You just have to understand what the hell it is. So I want to show you guys, this is a Java. Okay, this is done in Java. We could have used JavaScript. We could have used Python. I just used Java on this one. So, by the way, I did study Java. I took a Java class in college. So I'm not the best at it, but I understand a good set of it. Okay, so this one here is basically going to print out. So here's what this says. It says we're going to set the integer being I itself, to 0. Now, if the integer is less than 5, then increment all the way by 1. You see this I++, notice for your exams, I++ means incrementing it by 1. When you run this code, basically, it's going to start at 0 because it's equal to 0, and it has to be less than 5. So you notice it goes 0, 1, 2, 3, 4. If I go in here and I say make this 10, you'll notice that now it goes 0, 1, 0 all the way to 9 because we're saying it has to be less than 10. But if I go in here and I say, let's make it less than or equal to 10, now you'll get the actual 10. Let's see if that executes the 10. And you know, I mentioned the W3 School's website in a previous video because you can actually practice code here. I remember studying Java for other classes, and I use this a lot in demonstrations. Now, what exactly was the loop here? You're probably saying, okay, this thing can output 10. Well, the loop allowed this code to be run over and over and over until it hit its desired output. That's what it is. A loop basically allows the code to keep running over and over and over. Now, a branch statement. Branch statements, a lot of these are going to be used in if-then statements. This allows the computer to make logical guess, I should say, or we can say make logical decisions. If-then statements is something that is on your exam. You may see one on the exam where you have to interpret the results, and they're pretty easy, and I'll show you guys what they are. You see, if-then statements is basically if this happens. So if I am less than 200 pounds, then I am overweight. I'm sorry, if I am less than 200 pounds, then I am healthy weight. If I'm over, then I am overweight. A computer will consistently make decisions, and sometimes it has multiple if statements or multiple characteristics of these statements. Like it can do, well, if he's between this weight and this weight, he's healthy. If he's between this weight and this weight, he's overweight. If he's between this weight and this weight, he is obese. So this can get very complex. You don't need to know that for your exam. But I do want to show you one of these statements. Where is our desktop? Here we go. So I want you to take a look at this. This is basically an if statement. Look at this statement. And I'm just going to read it for you again. This is in Java. You should be able to read this. Now, I could have written this in pseudocode and made it easy for you, but I'm showing you the actual Java code. So if you ever see this in real life, you'll be able to understand it, and then the exam will be a lot easier. So look at this statement. They're setting the integer of time as 12. So the value here is 12. They're saying that if the time is less than 10, now the way an if statement works, the next part of it is generally going to be the true part. So it says, if the statement specify a block of code is executed, then this true. So the condition and then the true part of it. Okay, that's something you have to remember. So if this condition, if time is less than 10, then output this. This is the true part. If not, or if else is basically going to say, well, okay, if it's not that, then what it is. Okay, then do this. So then if it is less than 20, output good day. And this is the complete false part now. If not, everything else is just good evening. So let's see this. You see, if I go in here now and I say the integer of time, let's say is 5. Well, 5 is less than 10, so it should return good morning. Let's see if that's correct. Good morning. But it's also saying, well, else if the time is less than 20, then good day. So if we go in here, we say, let's say 15. Let's see what it says. I know this takes a while. It's never the fastest thing on this website. Okay, so we're saying, okay, so that's executing this statement. So it's less than 20, but it is greater than 10. Now, let's say time is 30. So we're saying now it's out of the range of less than 10, less than 20. So what is it going to tell us? It's good evening. So this is the complete false section of it. I don't need you guys to be able to write these types of code, but you should be able to understand these types of statements. If statements are used in a variety of different things, whether you're looking at JavaScript, and JavaScript is something we use quite a lot of, especially Python scripts. It's something we use a lot of in IT. In fact, many type of automation software are scripted. IT automation, like configuring a router, configure a server, is scripted. And a lot of them will use these kinds of conditional statements or branching statements in order for the systems to be fully automated. In this video, we're going to be taking a look at some programming concepts that you might see show up on your exam. Just a few terms here that we just want to quickly review. The first thing I want to review is something as identifiers. So all the different values that you're going to be entering into a code, whether it's typing in a date, adding a price, selecting an item, for example, on an e-commerce site, there's going to be somewhere to store this data in the computer's memory. Now, there's two ways of doing this. We have variables and constants. A variable is a data item whose value can change during the program execution, versus a constant is a data item whose values cannot change during the execution. So constants will stay exactly the same, versus a variable can change as the program is being executed. We're also going to take a look at a container. Containers will hold these values that you have. Now, in those values, you're going to have something called an array or a vector. Vectors are basically going to be a dynamic array. An array is going to hold a list of different variables. Now, you're probably saying, Andrew, what the hell are you talking about? I decided the best way to show this to you, the best way to explain it to you is actually show it to you what it looks like. So here I am. I'm back here at the W3 schools, and I want to show you something. If in the normal programming world, what you're going to have is variables, and you can see that they're saying that car1 is a variable, car2 they're setting the variable. So anytime the program references car1, they know they're talking about a South. Anytime it references car2, they're talking about a Volvo. So this here, now if you want to call car1 car2, you could literally just write this entire code out. So let's say you have 15 different cars. You can write 15 different lines. Car 3, car 4, car 5 equals this. Car 5 equals this. Car 6 equals this. Car 7 equals this. This, you're going to keep what's called declaring the variable over and over. The easiest way to do this would actually be just to create an array. So in the array, you're going to say that cars, this is an array, is Saab, Volvo, and BMW. So when they call the array or they extract data from the array, they can call any of these variables. So a container is a way to store these particular data. Now, the other one here was called a vector, and a vector is basically a dynamic array. It's an array that can change, be manipulated. Its size basically can be changed. All right, these are some basic programming concepts you might see on your exam. In this video, I'm going to look at a few more programming concepts before we leave this section. And that's going to be something called functions and object-oriented programming. I want to give you some basic definitions of this. And we're going to start by taking a look at a function. So what exactly are functions? Well, in software development, sometimes programmers just makes up their own particular, sometimes mathematical functions that they want to calculate at certain times. So instead of using what's there or having to recall certain programming codes, they just make up their own functions. And in this section, I want to show you what that looks like, as I have one that I made. So here is a function that I made, and this is done using JavaScript. So you can create your own function in JavaScript by literally using the function. So the script is called function. I created a function. It's called Andrew. You know what? In this one, I'll just call it Andy. It's called the Andy function. What the Andy function is that it has two variables, P and P2. And basically what this function does is that it's going to multiply these two numbers. So anytime I am going to run this function, it's not Andrew anymore, it's Andy. Anytime I run the Andy function, I have to give it two numbers, and it's going to just basically multiply these two numbers. So if I go in there and I say this is, let's say 5, and this is 20, then to run this function, I get 100. Now, anytime the function is called, so if I'm coding the software, every time I need to multiply two numbers, I don't have to write it out. All I have to do is say Andy, give it the two numbers, and boom, it calculates it, because it knows that this function is basically going to multiply the two numbers within the brackets, within the parentheses themselves. So this function is something that we can reuse over and over and over. Now, when it comes to reusing code over and over, there's a class of programming that you should be familiar with, and that's called object-oriented programming. The most famous one of this is going to be like Java. What it is that instead of having code, instead of rewriting code, so let's say you're programming a piece of software and every time you want to print, you have to write out a code function for print. In object-oriented programming, basically you write blocks of code, store them as object, and then you can call the object back. When you do this, there's two things you should be familiar with, something called properties and methods. So properties is basically the variables within the function. Let's say you have a cat, for example. The cat has 2 eyes, it has 4 legs, and it has a tail. That would be the properties. Let's say that's your object, the cat. And it has fur. So that would be your object. Now methods is what can you do with this particular object. Well, this object method should be like, it can run, it can jump, it can eat, and it can say meow. That would be methods. So methods is basically how you're going to be using these objects, and the properties is what the objects are about. Don't expect a ton of questions on this topic, but as you work through your IT career, you should be familiar with some of these terms. In this video, I'm going to be going over databases. So if you have ever used any application before that pulls up data or stores your information, that's being stored in some kind of database. A database is basically a piece of software that does what it says it does. It stores data. It's a base of giant amount of data. Almost every software you buy, so if you go to Amazon right now, Amazon has a giant database of all the different products that it sells. It also has a giant database of customers' information. If you go to Hotmail, it has a giant database of all the emails you receive and all the user accounts. So all software basically that we use has some kind of database that powers it up. A lot of times the database is separate from the application software. So the database is stored on one server and the application is stored on another end. So what's known as the front end and the back end. So if you ever hear some front end and back end, front end is just the application interface itself, and the back end is where the data is actually stored. A lot of times these two are even separate tasks, as the application programmers programs the application front end, makes the user interface, does all the code, and database administrators makes the database to store the data and all the fields and all the records that the data will have. The application will then utilize the database to present a nice, beautiful front end like you would have on Amazon.com. So what I did in this video is I actually made a database, and I actually want to show you a really simple database using a relational database called Microsoft Access, which is a very simple database software to use, and you'll see that in a few minutes. Now, you don't need to know how to make a database. You don't need to know how to write SQL commands for this exam. But what you should do is understand, hey, this is a database and these are some characteristics about it. So the first thing we're going to take a look at is, what is the usage of a database? Well, we want to be able to first create databases. There's a wide variety of database software that are out there, from something as simple as Microsoft Access to complexity of Microsoft SQL, or you guys probably heard of Oracle. That's also very famous, MySQL, NoSQL, and a variety of different databases that are out there. So we're going to take a look at all of these different things in this section. But what a database is basically going to do is allow me to store data. It stores data in what is known as tables, and I'll show you that in a minute. We can import data from other databases or data sources, or we can type it in ourselves. Once the data is in the database, you can then query the database and extract useful information from the actual database itself. Reports are then able to display information that the database has given us. All information stored in a database are called records. Records are the individual data sets. So, for example, in Amazon right now, your record would be your first name, your last name, your address, your credit card information. A record of the product would be the product name, the product price, when the product is available for ship. So records are the individual data sets that are there. Databases are stored on large servers. A database can be something that's a few megabytes all the way up to terabytes of data for giant data sets. So you're going to need massive storage. And of course, the bigger the database, the more processing it requires. Now, databases, there's a variety of them. You could store, instead of having a specialized piece of software to store your data, such as a database, some people store them in flat files. This is going to be like storing data in a text file. It's probably not the best option, as it may not allow multiple people to use it at any given point. Think about this. When you go to Amazon, there's millions of users using that database at any given moment. It's not scalable. Text files, as they become bigger, they become slower to work with, and adding data just becomes cumbersome. So a database will give you good speed, good scalability, and allows a lot of users to use it, and it can store a wide variety of data versus its flat text file that won't. So let's take a look at everything I just covered in a easy to understand format. And what I'm going to do here is I'm going to show you guys Microsoft Access. You don't need to know Microsoft Access for your exam at all. Okay, this is just a demonstration to make you get an understanding of what it is. So this is Microsoft Access. It's Access 2019. And in Microsoft Access, it has tables. Remember something for your exam. When you store data in a database, it's stored in the tables. So right now I have two tables. This database is very simple. This database is a database of students and what class they took. It's a very simple database. So I have a table for my student, and you notice my database has a table and it has two students, Bob and Mary. So Bob Jones is student number 1, Mary is student number 2. This is their address, this is their age. These are called records. Okay, these are the records within the database. So I can go in and add a new record. Let's add a record for Chris. So Chris, let's say his last name is Ram, like me. His address is 333 Street. And can't spell street now, that's fine. Chris is 18. So we just added a brand new record into our database. Now, all databases has tables. That's where the data is stored. You can continuously type and type. Then you see how it's storing this information for me. Then you're thinking to yourself, hey, doesn't this look like Excel? It kind of does look like Excel, but it's vastly different. This is not a spreadsheet where you can just execute formulas on. This is just a place to type information in there. So this is where you would store the data. Another good part about this is that, you see, if I go into this one here, I can show classes that was taken by some of my students. Remember, student 1 was who? Student 1 was Bob. This is student 1. His ID is number 1. And Mary was 2. So if I go into class table, I can see student number 1, student ID 1, took Excel and Word. Student number 2 took PowerPoint. One good thing about a database is that it allows you to query the data, extract useful information. So I have a query right here. You see, if I open, let's close this table, close these tables. If I open this query right here, you can see it's telling me that Bob took Excel, Bob took Word, and Mary took PowerPoint. It's giving me that useful information that I want out of a database. It's great to have data, but if you can't extract and see the information, it's not very useful. The other thing here I have is a report. So if I go here to reports, I can double click on this and I can see a nice display of all the students that took took classes from us. And you can see it's a nice printable format and it looks good. So I can go to print preview and this is what it would look like if it prints out. So this would be considered a report. Now, if you're wondering, so this is a database, and what's a flat file? Well, a flat file is basically like a text document like this. So this is just data in a flat file. It's not very scalable. It's not fast. It can get cumbersome to use. You don't want to store data in flat files, although a lot of data in today's world, especially in specialized application, is still stored in flat files. Okay, this is a brief introduction to databases. Let's keep going. I'm going to show you more information and some more complexity within this database. In this video, I'm going to be talking about different structures of databases that you should be familiar with for your exam. And predominantly, we're going to be talking about relational databases, as those are the most popular ones. You've probably heard of things like Oracle, MySQL, Microsoft SQL, and I just showed you Microsoft Access in the previous video. So let's get into it. So when it comes to relational databases, there's a few components that you want to be familiar with, something called the schema. Now, the schema of the database is basically going to be the actual layout, the design of the database. The tables we mentioned is where you're going to store the actual data in the database. So we store data in tables, and tables is made up of what is known as rows and columns, or records and fields. And I'll show you guys that in a few minutes. And then constraints. There are certain constraints that we can apply to a database that's basically going to limit the type of data that we want to input. For example, you may have a a field in the database where there's phone numbers and you don't want anybody typing letters in there. Or you may have a field that has numbers. It's like someone's age and you don't want somebody putting in the ABCs in there. So what I'm going to do here is I am going to show you guys, where is my database? I'm going to show you guys Microsoft Access that I have here. Now, in Microsoft Access, what we're going to have is basically a relational database. And I want to show you guys these tables. So if I open up the student table, you see first name, last name, and address. So first name, last name, and address, all of this here would be considered fields. If we go Bob, Mary, and Chris, those would be considered records. So we have fields and records. Now, in a database, in order for the database to uniquely identify every single record that is out there, it needs to have a very unique field, and that field is called a primary key. You see, if I look at the design of this database, so I'm going to click on this here. This is called Design View. This is the design of when I'm making the table. This is what it looks like. You'll notice that next to the ID field is a little key there. You guys see that? It's hard to see that, but it's a tiny little key there. That specifies that this field is known as the primary key. Now, the primary key is a unique field that identifies each record in that table. Every table should have that. So look, if I go in here, and this one for me is an automatically generated number. So if I go in here and I add Tom Hanks. So Tom Hanks lives on 555 Street. You notice how it automatically added this in here. You can't have repeated numbers, and these numbers are unique to that record. You can't have two people with the same primary key, or two records with the same primary key, as it uniquely identifies those particular records. It's like when when the United States government is ready to call you, they don't call you by your name, they call you by your social security number. When the database is calling Tom Hanks, it's not going to call Tom Hanks the record, it's going to call the number 5. It knows, okay, that's Tom Hanks. So you can't have a repeated value there. One of the things that people should understand about a relational database is that it's called relational for a reason, because the data is actually related to each other. And the tables are related. And I want to show you something they call the schema of the database. So I'm going to go to Database Tools, I'll go to Relationships. And this is basically the schema of the database. This shows me that there's two tables. We have a student table and we have a class table. And this is what's known as a one-to-many relationship. So one student can take many classes. And they're basically relating this primary key, the student ID that I showed you, to a student ID field in the class table. This is known as a foreign key, this student ID in the other table, and the primary key is the one in the student table. So to better illustrate this, you see if I go into the class table and I add, so Tom Hanks was what, number 5, right? So let's say Tom Hanks took an Excel class. Let's just put this day. He was number 5, so I can just put that in there. Notice this student ID is not a primary key on this table. It's the foreign key of the relationship between students and classes. So that's the difference between primary keys and foreign keys. The next thing we want to talk is constraints. So you notice that this age field here, if I come in here and I didn't put 1 for Tom Hanks, but what if I put A, B, C, or ABV? It doesn't take it. It's like, hey, this field only accepts, let's say he is 50. It only accepts numbers. So there are constraints that we can apply in this. Now, when you're looking at these kinds of relational databases, they can get a lot more complex. The good thing about Microsoft Access, it's very easy to use. You don't have to use database commands, which I'll show you in the next video. There are database commands, or known as SQL commands, used to manipulate the database. But in Microsoft Access, it's doing it for you. It's writing all the commands in the backend to create that database for you. The other term here I want to mention in this video is going to be structured versus semi-structured versus non-structured. When data is stored in a database, it's structured, and depending on the database, it could be semi-structured. In other words, semi-structured is the data has tags, it has fields in it. Non-structured data is everything else. If on your computer right now, you have pictures, you have text files all over the place, you have emails stored on your email system, you have music files, movie files. This is data on your computer that doesn't really belong anywhere. It's just there, and this is called non-structured data. So that type of information would be considered non-structured data. Other types of databases we have here is going to be known as key value and documented database. Let's take a look at what these are. So one of the most popular implementation of these databases are called NoSQL. All right, NoSQL. Now I'm not going to get too much into that, but I do want to show you key value pair databases. So a key value database, basically it's not relational. It's basically data that is stored in what is known as a key value pair. And oops, this is AWS. And this is an example of it. It's just storing data. It's saying, okay, this is basically a primary key, and here's the data that's assigned to it. Key value pair is very popular because it allows you to extract data very fast. Another one is called a documented database. Documented database basically stores data as documents, quote unquote, but they use a specific, for example, a specific one like a JSON file. So this here would be like a document that's stored in a JSON file. And JSON, by the way, is essentially JavaScript object notation. It's able to extract and retrieve data from this. So there are a variety of different databases that are out there. The most common one you're probably going to encounter is a relational database. Although we have things like NoSQL databases that are becoming popular, such as those key value systems. But as time is moving on, relational databases are still the most popular. In this video, I'm going to be taking a look at SQL commands. Now, anytime you use a SQL database, any type of SQL database, whether it's MySQL, MS SQL, Microsoft Access, there's actual commands that you have to put in there to make it work. Now, you're probably saying, Andrew, you didn't put any command when you use the Microsoft Access because it actually writes the commands for you. That's more of a utility. Microsoft Access has a beautiful interface that makes it really easy to use and create tables. But in actuality, there are actual SQL commands that are being run. For your exam, you should be familiar with some of these commands. I'll start out with here at the bottom, the data definition. Well, this is going to be about manipulating the actual database file itself. For example, the create would allow you to either create an entire brand new database, or it can also be to create a brand new table in that database. Alter it would be able to alter a table. So for example, you may have a table with 3 columns, but you want to add another 4 or 5 columns to it. Drop, you can delete a table or you can delete an entire database using the drop command. Permission would be used to edit permission on the database. So this guy can have access, but that group can't, or that group could and this guy can't. Now, when you're actually using the tables themselves and adding and removing data, you're going to be using these commands here at the top. Select will be able to extract data or select certain records from a particular table. Insert will be able to add records to a table. If you remember, we had add Tom Hanks to that table. That's the insert command. The delete would be able to delete a record in a table, and update would be able to update a record, such as if we go in and we want to change Tom Hanks' address or his age. Delete is if we want to delete the entire Tom Hanks record. Insert is maybe we want to add Tom Cruise now to our database. And select would be to extract or just pull certain information from our database. I actually want to show you guys a couple of these commands here that is working. So look, I have the drop command. So we said drop table. You can also drop the entire database. This one here would be used to delete an entire database. But I'll show you guys here drop table. So I'm going to run this, try this myself. You notice that we have a couple of tables here. We have shippers, suppliers, products. If I run this command called drop table, look what happens. You see shippers is right. If I run it, you'll notice shippers is gone. It's not there. All right. Why? Because it just deleted it. So when you run that command, it deletes that particular table. The other one here I'll show you guys is what's called a select statement. So this was one of the ones I said you can use to grab data from a database. So let's try this one. So in this one, we have a table. So this one is select the customer name and the city from customers. So if we look at the customer's table, we have their first name, their contact, the address. But if I run this command, run SQL, so hold on one second, let me restore this. So if I say run, so I just want the customer name and the city this time. So when I run this, now I only get these two fields. So the select is able to extract certain data you want from that particular database. The other commands here, you need to understand what they are. You don't need to go about and being able to write them or even do what I just did there. I just did that so you have an easier understanding of what these are. Now, when it comes to managing these relational databases, you have to understand access methods. We have what's called direct or manual access. This is when a programmer sits in front of the actual database itself, the database software, and sends commands directly to the database saying, hey, create this table using the create command, drop this table or delete this database. You have programming methods, in which case you have software, and this is more than likely how you're going to access databases. You have software like a website. Anytime you go to a website and let's say you go right now to Amazon and you create a brand new user, you create a new account to buy something, it's an insert command being sent to the database. So that would be a programming way. Databases have a variety of interfaces, like I use Microsoft Access Interface. There's a variety of different interfaces, like if you use Microsoft SQL Studio, you'll be able to access database, create tables, using something similar to how I used in Access, and you can also build reports from there. Now, export and import. Sometimes you dump the entire database to like a flat file or to another database. That would be called a database dump. This is exporting the database. Sometimes we import data from other databases also. A backup. I'm not sure what to tell you here other than you must have a backup. You know, there's an old saying in IT, no backup, no restore. It's not if your system will die, it's when it will die. Make sure you always have a backup. Now, backups can range from something as simple as just copying it to another hard drive or an external hard drive to complexity as storing it in the cloud and depending on incremental or differential backup, which we'll learn about in another course. But the point is you must back up your database, because if you ever lose your database, you're going to lose all of your data. In this video, we're going to be talking about the CIA. And no, not the Central Intelligence Agency, but IT security, CIA, which is something you're going to hear a lot of as your IT career progresses. In the world of cybersecurity, CIA stands for confidentiality, integrity, and availability. It's the pinnacle of all security. It is what we try to accomplish. It's the main goal of security. Keep data confidential, keep it from being altered in any malicious way, integrity, and making sure the data is available when needed. So in this video, I'm going to be going through the definitions of these terms and some attacks against them. And it's really important that you know these terms and the attacks for your exam. Now, IT security is, of course, a red hot topic in today's world. You should expect a good portion of your exam, if not 1 in 5 questions. I think this is 20 or 22% of your exam. So expect a good set of questions from this section. So let's get right into it. So the CIA, confidentiality, integrity, and availability. Let's start off with the first one of confidentiality. Confidentiality is really keeping private data private. Only authorized subjects should have access to the data. Subjects versus objects. Subjects are users. Objects are basically things they're trying to access. For example, file and folders. Subjects are you logging into Amazon website. The object you're trying to access is that shoe that you're taking a look at. Confidentiality is to ensure that only the authorized subjects has access to the authorized objects. So, for example, only you should have access to your account information. Only you should have access to this file on the server. Only the people in the accounting department should have access to the accounting database. So these are all examples of where confidentiality is needed. Most of the time when people are thinking confidentiality, they're thinking privacy. They're thinking, oh, that's my data and only I should have access. In fact, most of the time when you guys think of security, you're probably thinking confidentiality. Now, there are some attacks against confidentiality that we should be familiar with. The first one is snooping or eavesdropping. Now, snooping and eavesdropping is basically listening to conversations. As data is going by the network, hackers can listen in, sniff the data, sniff the data, and then if the data is not encrypted, they'll be able to read that data in front of them. Snooping can be things like you're typing data on your keyboard and somebody's behind you and they're watching you type data on your keyboard. You may type in some sensitive information. Go to Amazon right now, type in your credit card, and I'm standing behind you. I can basically steal all of your credit card information. Another one is called wiretapping. So wiretapping is basically listening to your conversation. Wiretapping, they do this to phones. So that if the government suspects you of doing some crime, they may wiretap your phone and listen to your conversation. This is an unauthorized entity listening to your conversation. Some people may wiretap you for illegal reasons. Sometimes you may have a jealous boyfriend or girlfriend that wiretap your phone and is listening to your conversation and you don't even know about it. That would be an illegal version of wiretapping. Social engineering is a giant topic. Social engineering, for your exam, just remember, it's more humans trying to hack or steal data from humans. Social engineering is somebody manipulating you into giving them a password. Let's say I call you up from the help. I call you up and I say, hey, I'm Bob from the help desk and I'm trying to reset your password. Can you give me your password? Or can you give me your password to install a new update? It's them, somebody calling you over the phone and say, well, we're calling from American Express and your card has been hacked. Let me have your credit card number to verify that you are the person. It's me calling you from Social Security Administration and telling you that something is wrong with Social Security number. Let me have it. So social engineering is manipulating people, actual emotions. It's manipulating people themselves to gain data. All types of subsets of this would be like phishing emails, not with an F, with a P. Phishing with a P. And in this particular one, they would send you an email to click on a link to go to a banking website to reset your password, and they would steal it or put your credit card number in. Dumpster diving. People still do this. Dumpster diving is going through the actual trash, going through somebody's trash that they put in front of their house and get data from it. For example, people may not shred. They should be shredding bank statements and credit card statements. So what happens is they put it in the garbage, they go away, and before you know it, somebody's stealing that information. Somebody opens up your trash. What can they find? Integrity. Integrity is the unauthorized manipulation of data. Anytime you think integrity, think alteration of information. Remember that word. Integrity is alteration. One attack that we should be familiar with against integrity is what is known as a man-in-the-middle, or now called on-path attack. So here's the thing with integrity. Integrity is when I send you data, you're 100% sure the data wasn't manipulated. When you send data, your credit card number to Amazon, no one intercepted the data and changed your credit card numbers. When Amazon is sending you back information, same concept. No one intercepted the data. So that means that, let's say there is the Amazon web server and there is you, a user. So Amazon web server and you're sending data back and forth. But what if right here, there is a hacker? What if there's a hacker there? And that hacker is listening to all of the conversation. This on-path attack is basically listening and could manipulate the data on path, which means the data is on path from Amazon to you or you to Amazon. So these kinds of attack would generally be fixed by generally just encrypting your data. A replay attack. So a replay attack is going to be similar to this. A replay attack is when you authenticate to Amazon, it authenticates you and it saves what's called a token. That token lets Amazon know, okay, we got his password. He's all good, and it gets you back a token so you can keep using this to keep accessing Amazon. But what if the hacker grabs the token and it can then replay it against Amazon? So when you go away, it replays it as Amazon. It says, hey, I'm Bob. And let's say your name is Bob. And then Amazon is like, oh, really? Okay, Bob, keep coming, keep shopping. And it's interesting because what happens here is that you actually don't know that somebody logged into your account. Replay attack. This forms a type of impersonation. In other words, they're impersonating you and stealing your information. Unauthorized information alteration. Somebody logs into a web server, somebody logs into a file server and manipulates a file they shouldn't have had access to. This is lack of access control by the administrator. Availability. Is the data available in a timely and efficient manner? In the world of security, a lot of people don't look at availability as an important concept, but it is, because it doesn't matter how much security you have, how much good confidentiality, integrity, and integrity you have. If people don't have access to the information, it's not very useful to them. So we have to put things in place to ensure that data is always available to them. Remember, if the company doesn't have access to the data, they can't actually do their work. So what can cause problems? Well, what happens if there's a power outage in your part of the country? No one can access anything. You might need to put in UPSs, on-the-turbo power supplies, big batteries. So if the power does go down, have multiple power providers, generators, hardware failure. There's a server with the hard drive died. Oh well, if the hard drive is dead, then no one can access the machine. You should have redundancy built in here. Denial of service is an important one for your exam. Denial of service is when hackers don't want you to access a website. What they do is they send loads of false traffic to a website. Let's say you have a small web server with important data. Hackers would then send thousands and thousands or millions and millions of requests against the web server. The web server drops because there's too much request. No one can access it. The hacker group Anonymous is famous for this. They flood your web server with traffic, and before you know it, no one can access. So it's denying the service of your website to others. Hint the name, denial of service. Destruction. Somebody coming in, destroying machines or destroying data would make it unavailable. Service outages. What happens if your internet service goes out? Then no one can access anything in the organization. And if you own servers, then no one can get to your service. These are going to be some of the important concepts that we need to know for our exam. You want to be able to understand CIA, confidentiality, integrity, and availability. Now, I can expand these topics greatly as your knowledge of security grows and your understanding of it and all the great things that we do in security, such as ethical hacking. You're going to enjoy this field. I hope that many of you continue in this field of security and join me for classes such as Certified Ethical Hacker, where I'll show you how to actually conduct some of these attacks, and maybe some of you will become pen testers. Maybe some of you will become security analysts or firewall administrators. To me, security is the most exciting part of this industry. In this video, I'm going to be going through some device practices or best security practices that you guys should be following when using a computer, and all users should be following. Now, some of these are going to be pretty much common sense, and you've probably heard a good set of them before, but we're going to iterate them because they may be showing up on your exam. Let's go take a look at it. So let's get into it. The first thing up is you want to secure your actual desktop, your mobile workstation. Let's say you have a laptop. Let's say you have a desktop at work. What are some things that we should be doing to secure them? The first thing is we want to have antivirus installed on our machines. That's at a bare minimum, some kind of anti-malware software. So what are examples of this? This is going to be things like Norton Internet Security, McAfee. Windows comes with Windows Defender. That's you should have on your computer. You never know when you click on the wrong file or you open the wrong email and your machine might get infected. Sometimes we just go to websites that we aren't too sure about and they try to inject malware into our computer. Another thing we want to have is a firewall on our machine. So your computer has ports. It has 65,000 logical plus ports. And what can happen is malware can get in. A firewall would block those ports up and stop malware from getting into your machine. Now, if you're using a Windows box, they all come with firewalls. They also all come with anti-malware. Windows Defender is an anti-malware and a firewall that stops things from coming in and infecting and destroying your computer. Changing default password. You guys would be surprised to know how many hacks are done because no one changed the password. So when you buy a device out the box, for example, I remember buying wireless routers back in the early 2000s, like a Linksys router, and the password would be the username admin, password admin. Printers, username admin, password. So popular. Sometimes you're just trying to hack in, or hackers trying to hack into a device, and you just try a default password and it works because the administrator didn't change the default password. You want to enable passwords. For example, on your wireless network, you want to enable some kind of key on there. You want to put a password on it. If the system can take one, you should have one. For example, on your phone, do you have a password or a passcode set up? Or can they just put it on and they can access your data? That would be terrible. You'd want to make sure you have that on there. Safe browsing practices. What are you going to do with safe browsing practices? As a user, we have to know where to go. You have to be clicking on trusted websites. You have to understand things like if the browser says the site's not trusted, don't go. Don't surf the internet and click on random links. Know where that link is taking you. Know the website you're going to. When people send you link, don't click on links. The number one way to get a virus is through the internet, and it's through emails. Way too often we go down rabbit holes where we click on this link, you click on this link, and before you know it, you're 20 links in. You don't even know where you are. Go into forums and reading people's comments and saying, oh, this is great. You click on it, you get your machine infected with malware. Users shouldn't do that. One of the main things we can do is update our computer. We should set our machines to do automatic updates. Now, all of these things here, by the way, it's in A+. I'll walk you through the steps of installing these things and setting up passwords. For this exam, you just need to know what you should be doing. So understand this about an operating system. When Microsoft or Apple makes a product, an operating system, they write all this code and they send it to you. As time moves on, people find holes in the code. They find literal, okay, this is a hole that we can inject malware through. Okay, so it's a hole. So worm comes through the hole. If you want to remove the hole, even if you install and you put a firewall, the hole is still here. If you put antivirus, the worm gets in, or the malware gets in, and then the virus cleans it. But if you want to get rid of the hole completely, boom, the hole is done. You have to patch your machine. Patching, automatic patching, and updating the machine is IT Security 101. It's Security 1. You must do that. Way too often do I see people don't enable automatic updates because they said, oh, it's too long or it's a pain to do. If you want to keep your information secure and your system secure, make sure to put patching or updates on. Now, when you're using your device, okay, this could be your laptop, this could be your phone. There's some best practices here we want to do. Number one, software sourcing. When you get software, when you download software, for example, to your mobile phone, where are you getting that from? Is it from a legitimate source? Did you validate that source to be a legitimate? There's a lot of apps that might be out there, people sending you links to apps. Did it come from a legitimate source? Did you research where that app came from? Is it from an OEM website or a third-party website? Is it from the manufacturer or is it coming from some other manufacturer? For example, if you're using a driver, you want to install a driver to make a hardware work. Remember what drivers do? They make the hardware work. Where did you get the driver from? Did you go to the manufacturer's website and download the driver? Or did you actually go and get some third-party driver to install? Those third-party drivers may be a virus. Always get it from the original equipment manufacturer's OEM website. Research where you're getting your software. Just don't install randomized software. Anytime you get a computer, I do this all the time. Computer or phone or whatever. The first thing I do before I install anything is I'm going to remove what's called bloatware. Know that term for your exam. Bloatware is all the unnecessary software that phone manufacturers and desktop manufacturers like Dell install on your computer. First thing I do is I go to control panel, I open up the thing and I start uninstalling everything. We want to remove unnecessary software, all right? There may be a ton of unwanted, unnecessary software that's just not there. Antiviruses with small licenses that I don't need. I prefer just to use Defender. When you want to remove malicious software, you're going to need some kind of malicious software removal like antivirus, anti-malware like Windows Defender or Norton Internet Security for that. Having these types of software like Internet Security is critical for the protection of your machine because you never know when your machine might be infected. Remember something, guys, if they ever infect your machine, they can manipulate the data and, of course, steal the data and make your life a miserable hell. One of the biggest topics in IT security today is privacy. Privacy is a giant topic, and it's a topic that's talked about so much. As more and more of us utilize the interwebs in order for pleasure or do business transaction, we are basically giving away our data, and this becomes an issue. Many people are hooked to things like social media, in which case they are posted on Facebook or LinkedIn, or they're watching things like TikTok and giving away what type of data that they're using or watching. Privacy is a big concern in today's world. And when we're looking at privacy, we got to have some good expectations of it. First of all, on the internet, when you're taking a look at the internet, and you're using things like social media sites, there's something you must understand about it. This is going to sound harsh, really harsh. And I don't want to upset you or make you feel bad, but I always tell people this. People complain about using Facebook. And I'm assuming you all know what Facebook is. Using Facebook on other social media sites or Twitter, in which case, I'm not sure if you know this, but people like Facebook resell your data. So when you use Facebook and you post and you like things, Facebook knows, okay, he likes this, she likes this, he likes this, she doesn't like this, and they start to display ad. They're selling your data. They're selling your information to advertisers so they can advertise and hopefully sell you something on their website. So what is Facebook doing? Facebook is selling your information. Facebook is selling your activity across their platform. Now, people complain about this, and I tell people this. I said, listen, guys, yes, Facebook is a social media site that resells your information, but always remember, how much did you pay to use Facebook? Facebook is a free service to us. And always remember, this is the harsh part. If you're not paying for it, you're the product. It means they're selling your activities. They're selling your data. So if you're not paying for it, then something you're doing is the actual product itself. Facebook is a giant operation that needs to pay its bills. They have giant data centers and they employ tens of thousands of people, and somebody's got to pay them. And you're going to be paying, you're paying for it with your information. That's the expectation when using social media sites. We want to educate people on this. We want to educate people. Don't post stuff on Facebook that's private to them. It can go to the world. So things like that needs to be known. Email. On the internet, of course, you're going to be using email. You shouldn't be sharing information. Email by its native form, it's not encrypted. File sharing. A lot of people may be downloading illegal files. And instant messaging. Be careful who you talk to with instant messaging, because if there's something on instant messenger, it can easily be impersonated. Somebody can claim to be someone else, and you're not sure if that's the right person. When it comes to privacy, mobile application especially can be grabbing your private data without you knowing. A lot of times we install mobile applications and the end user license or the user access license that's on there when you click I agree can actually be telling you that, hey, we need to look at your GPS and know where you are. We need to grab your information from your phone and your contact information. You want to make sure that you read these information before actually saying I agree to it. That's going to be the same with desktop software, business software. Also, corporate networks can grab a lot of the information. Now, corporate networks is a whole different ballgame. When you sit down in a corporate network, the employer has the ability to monitor your phone call, monitor everything you do on their computer, from reading your emails to looking at your screen to tapping your phone. And it's fully legal if you knew about it. Now, a lot of us may go to work in a big company where they give you something like an employee manual, which lists all what they're doing. You never read it, you signed off, I agreed to it, and you just started the job. And it's fully legal for the employer to do it because you agreed to it. You just didn't even know about it. That's why it's important to read those employee manual. In the organizations, you're going to have written policies and procedures. I've never worked for a company that just didn't have policies and procedures. That's going to tell them how they're going to handle privacy. The organization should have policy written. For example, if they're going to be checking your email or wiretapping your phone, they should have written policies of how they're going to secure your private data. Don't forget, the organization got your social security number. They got your name and your address and all that good stuff. They should have policies protecting that kind of information. Now, when it comes to handling of confidential information, passwords should always stay in an encrypted, what's called hash format, so no one can get it. Don't ever share your password with people. Common sense 101, never tell anyone your password under any circumstance. No one needs to know it but you. Your personal information should be encrypted. Companies that stores them, such as Facebook, such as your corporate offices, should be encrypting your personal information. Personal information is going to be things like your credit card number, your height, your weight, your name, your address, even your health information. One term that you might see show up on your exam is something called PII or PHI. PI is personally identifiable info. Your name, your address, your phone number, your email address. Personal health information, PHI, diseases you may have, medications you may take, or is it going to be PHI? These are both private information that needs to be encrypted and protected by the organizations that collects them. Customer information that we get from our customers like Amazon, Grab, my name, my address, my credit card number should be encrypted. Companies' confidential information. This one here, companies store a lot of research and development. That new iPhone that's coming out that we haven't heard about yet. That new phone Samsung is making. That new car Ford is making. Companies' confidential information needs to be encrypted and protected. The company is going to have tons of information on its customers and its employee. All of that needs to stay secure. You know, when it comes to privacy, it's a big topic. Lots of new laws and regulations are being passed, whether it's laws such as PCI, Payment Card Industry, DSS. That's a very famous law to protection of credit card. GDPR, which is used in Europe to protect personal information. The world of privacy is changing, and organizations such as Facebook is becoming more and more larger in terms of how much data they're getting. Those companies are going to maybe even start to be regulated at some point. Let's see. But your private information, be aware when you're surfing the internet, using social media, sending out an email, working at a company. Be aware of what's happening with your private data. Anytime you go to a computer, you're going to have to identify and prove that identity to a computer. Every time you walk up to your phone, or at least I hope so, and your computer, at least I'm hoping, it's going to prompt you to enter a password or a PIN or put your thumbprint or something like that. This is called authentication. Authentication is when you're going to prove who you are to this machine. The computer is like, who the hell are you? Oh, you're Andrew? Okay, well then prove you're Andrew to me. Do you know something only Andrew knows? Do you have something only Andrew has? Is there something unique about you that makes you Andrew? Those are the three types, by the way, to authenticate. Authentication is when you prove who you are. So it's proving the identity of the subject. Subject is you. The identity that you're proving is generally your username. And how do you prove it? Well, that brings me to authentication. So before I get into this, I want to talk to you about three types of authentication. What are the three ways to authenticate to a machine? Well, let's take a look. So type 1. Now, this is going to go, by the way, what I'm about to teach you is beyond the scope of this class, but I think it's important to know, and you're going to learn more about it in your other certifications. So the first way, type 1, is something you know. Something you know is going to be a PIN or a password, answers to security questions. You ever logged into a thing and it's like, oh, where was you born? What was your name of your first girlfriend? What was your name? What was your first car? That's something you know, something only you or specific people around you may know. So, but generally, type 1 authentication is your password or a PIN. Type 2 is going to be something you have, something that you're physically in possession of. This is going to be something like an RSA token, which I'll show you a picture of. It could be a bank card or a credit card that only you have. So only you should have your bank card. And number 3 is something you are. This is something, a unique trait to you. Think biometrics. What's unique to me? My thumbprint. Only I should have this thumbprint and no one else in the world. My facial recognition like you would have on an iPhone. Eye scanners or retinas, iris scanners, hand geometry scanners. So you have all of these different authentication types that are out there. So there are basically 3 types. Something you know, PIN or password. Something you have, like a bank card or a smart card or RSA token, or something you are, think biometrics. Let's go back to this now. A single factor authentication, there's basically, when you're authenticating, you're either going to do a single or multi-factor. Most systems today, unfortunately, are still single factor. Single factor is when you only have to show one of the things. So if you come up to your computer and you only have to put in a password, that would be considered single factor authentication. In other words, all you have to do is just type your password in and you're done. Also, if I come to my phone and I just put my thumbprint in here, oops, wrong thumbprint, put my thumbprint in here and it logs me in with my thumbprint, this is also a single factor. Remember, there was 3 types. It's only using one of those types. Multi-factor, though. So in single factor, it's generally one of the types I explained. Multi-factor is 2 or more. 2 or more could be up to 3, right? So, for example, Multi-factor is maybe you're going to come out and you're going to use a password and a thumbprint to log in. So you go, you put in your username, you put your password, you press enter, then it says enter thumbprint, you put your thumbprint and you log in. This is a more secure system. Multi-factor authentication is always more secure than single-factor authentication. Some systems are really complex. You need to have 3 things. They may say, okay, give it a password, you put the password in, insert the smart card, you put the card into the system, now put your thumbprint. That's a 3-factor authentication, right? Really multi-factor. When it comes to factors, passwords, and pins, some systems has a one-time password. You see this sometimes when you log into a system. It may send you a code to your phone sometimes, or it may give you a password that needs to be reset. Tokens. Now, when you're talking tokens, there's software and hardware tokens. So a hardware token is one of these things. This is like an RSA key. Certain banks and organizations may give you out. There's a number on that key that keeps changing all the time. When you're logged in, it's going to tell you, hey, give me the number on the key. So you'll need to give them that. A software token is basically this hardware token on your phone. Basically, it's an app on your phone that displays the numbers. Biometrics, I mentioned already, things like your facial recognition, your thumbprint, eye scanners, and so on. Secure a specific location. Some apps wouldn't log you in unless you are, get this straight, you are in a specific geographical region. For example, let's say you're working in an organization, they only allow United States, people in the United States to access this data or to be authenticated to that data. Well, it checks your IP address, and if you're not in the United States, not letting you in. Sometimes to log in, you may need to answer a security question. I mentioned these. In general, when you create the account, you do this. What was your first car? What was the name of your first girlfriend or boyfriend? What was the name of your 3rd grade teacher? Security questions. Okay, here's a hot topic for your exam, something called single sign-on. This is referred to as SSO. When you go to an organization, all right, when you go to an organization, they have many servers. They have a database server. They have a file server. They have an email server. Okay, when you want to access an application that uses the database, you want to access files. You want to access a specific web page. What do you have to do? You have to memorize 100 username and passwords, right? I got to get a username and password for the email. I got to get a username and password for the database and the web application and so on. Maybe you have 10 web applications. What are you going to memorize all these passwords? Single sign-on is a technology where it utilizes one username and password to log you into everything. So you just log into this particular system, and then you can access all of these different applications, from your emails to your websites to 5 different websites to different devices on your network. This single username and password can give you access to your email, to your websites, your databases, and all your files. This is single sign-on. Single sign-on, you find them on the internet. You log into this one website. And because you log in here, the credentials, this is going to be using what's called SAML. Talk about that in another class. They then can use that to log into a variety of other websites, so don't have to put back your username and password. So single sign-on is what it says it is. You sign in once, single sign-on, sign in once, and able to access lots and lots of resources or all resources on that network. In this video, we're going to be talking about authorization, accounting, and non-repudiation. 3 important terms you're going to need to know for your exam. So the first thing up I'm going to talk about is something you're all very familiar with. It's authorization. In the previous video, I talked about authentication. Authentication is proving your identity to a system. But when you log into the system, what can you access? Can you access this file? Can you access that folder? Can you access this application or that email? What you can access is dependent on what you are, quote unquote, authorized to access. Generally, this is going to be set by your organizational policies and configured by systems and network administrators. So let's go into this. What is authorization? Well, authorization is the permissions to what you have access to. So if you can log into your network right now and you can double click on this file or that folder, that gives you have permission to that. But if you double click on a folder and it says access denied, then you don't have permission to that. So authorization is the permissions we have to these things. Now, there's a variety of different configurations on different systems beyond the scope of this class. As your career grows in IT, you're going to see more of them. the least privilege model. So here's what this is. The principles of least privilege. IT Security 101, we call this. When you set up authorization in a network, you have to follow the least privilege model. In other words, only give people the least amount of privilege they need to do their work. So let's say Mary comes to work in the accounting department and all she needs to do is make checks for bills. All right. So as the bills come in, Mary makes the check. This is called accounts payable, right? Because she's paying out all the bills of the business. Does Mary need to have access to all the customers' information? No, Mary doesn't need that because Mary never deals with the customers. So if the administrator configured it and gave Mary access to customers' information, that would be pretty bad. In other words, what's happening here is Mary has too much privileges. She has too much permissions. She should only have what's needed to do her job and nothing more. Every organization should follow the least privilege model. In other words, give a minimum amount of access. Another way we could do this is what's called role-based access based on a user account. So role-based access is this. When you come into the organization, you're playing, depending on the role is dependent on what you have access to. So what you're authorized to access. So for example, when you come into the organization, you're in the accounting department, or you're in the sales department, or you're in the finance or IT. What department you're in will determine what you're authorized to. So people in the accounting department can access accounting database. People in the sales department can access the customer relations management or the CRM. But people in the accounting department cannot access the CRM, and the sales can't access accounting. This is putting people into groups and assigning the permissions to the role. This is how most organizations work. This is how we always configure it. This is best practices. There are also a variety of user types. Sometimes you log in as a normal user. If you go to an organization and you try to change the system time or install software and you can't, would you have a normal user account type? Another user account type is like power users, which they can install software, but they can't really manipulate system settings, or administrators on the machine, in which case they can install software, manipulate, and change all system settings. Rule-based access control is controlling access into systems based on a specific set of rules. So this is mostly used on routers or firewalls. Your firewall sits in front of your organization's traffic. All traffic coming in has to get past this device. This device has rules. It's only allowing certain traffic. If the administrator wants to allow certain types of traffic in, maybe they're hosting an email server behind it, and you want to allow email traffic in or out, you have to configure that firewall. That firewall is configured with rules. This is called rule-based access control. The other one is mandatory and discretionary access control. When you log into a computer, can you change the permission of the file? Can you, the user, has the discretion to give people permission to that file or that folder? That's called discretionary. In other words, the user has the ability to set the permissions on the files itself, versus mandatory, the system and system administrator sets that up. In mandatory, only the system or system administrator is going to have the ability to set permissions on the files. And when you create it, you don't own it. It has a system owner, not a user owner, and only the system can set permission. When you use a system, okay, every single thing is logged. This is called accounting. Every single thing that you do on that computer, every click you make, every file you open, everything you deleted is generally going to be logged in log files on those machines. System administrators and network administrators will now have the ability to examine the logs on the systems, on your machines, on routers and switches, and extract them for useful data. Maybe they have analytical data. Logging is really important because it allows them to find errors or problems on the machines themselves. It allows them to track specific trends that may be happening. Oh, the hard drive is becoming full. Oh, users are going to websites they shouldn't be. This includes web browser history. Every website you go to, you think you go to the browser settings and clear your browser. If it's in an organization, they probably already tracked that and stored that somewhere else. So you deleting the data now wouldn't really help you. Non-repudiation, remember, accounting means logging of data. Non-repudiation is a really important term. You more than likely will see this on your exam. Here's what non-repudiation is. Repudiation is the ability to deny that an event has taken place. Non-repudiation is when the subject cannot deny an event has taken place. What do I mean by that? So let's say I'm a thief, okay? And I saw this big, beautiful desktop on this desk. So when nobody's looking, I came in the room, I stole the desktop, and I ran out the office, okay? Somebody stops me on the road and says, "Hey, did you steal that desktop?" The cops come, "Did you steal that desktop?" And I said, "Nope, wasn't me. I didn't steal it." What am I doing? I'm repudiating this. So repudiation is when the subject or the hacker or the bad guy is basically saying they didn't do it. They're repudiating it. They're saying it wasn't them. So non-repudiation is when they can't. So the cops come to me and says, "Andrew, you stole that desktop." And I said, "I didn't steal anything. It wasn't me. I'm repudiating that statement." Then the cop says, "Well, you know, Andrew, we have footage. We have footage of you. There's video footage of you picking up that desktop and walking out the organization." Oh, crap. Really? You have that footage? Okay, you caught me. I did it. You got me. Obviously, I can't lie now because, look, the footage is there. Now I cannot repudiate it. You see, non-repudiation is really important in an organization. If every action you do, you will be held accountable for your action because the organization can always prove you did it. They do this by doing a variety of things. For example, like what? Well, they're going to videotape you and everything that you do. There's a bunch of cameras around you. They're going to ensure that when you log in, it's only you that could have logged in. So let's say somebody steals the data and your account was attached to it. And you're saying, "Well, I wasn't me, even though it was my account. Maybe somebody stole my credentials." But how could they? It's biometrics. No one has your thumbprint. Maybe there's an electronic signature attached to it, or there's a receipt that you took the information. So non-repudiation is when the subject can't deny the action. In the world of IT security, this is something you really want, because if people know they're going to be held accountable for any and every action they take, they're less likely to commit malicious action. If you know you're going to get caught speeding every time you go over the speed limit, you're probably not going to speed. Okay? But if you know, okay, you may or may not get caught, you might just speed. That's the concept of non-repudiation. It's a really important concept because with non-repudiation, you're more than likely to get less attacks towards your organization. Let's talk about passwords. In particularly, how do we make secure passwords? And what are some password settings that we need to know? First of all, passwords are probably the worst way to ever authenticate to a machine, but it is the most used way to authenticate onto today. Biometrics is not something that we're going to utilize a lot, especially on the internet. We may use it to log into our phones and mobile devices and even our desktop, but most of the websites and apps we use on these devices are basically password based. So we have to understand some information about passwords. Let's get to it. The first thing up is the password length. This is really important. The longer a password, the more harder is it to crack. You see, in order to crack a password, one thing that hackers do is called a brute force attack, in which case they guess every single combination within the alphabet itself. Hackers nowadays can guess millions of combinations every single second. So let's say you have a password that is out of the dictionary. Well, there's only 300,000 words in the dictionary. They will crack your password like that. So because they can try millions of combinations a second, the more longer your password, the more longer it will take to crack. You see, there's one thing I want to make you guys understand. No password is uncrackable. A computer sitting calculating different variations of password will eventually guess every single combination of every single letter on a keyboard. It's just a matter of how long. Some complex password that's maybe, let's say, 16 characters that has uppercase, lowercase in it, symbols, numbers in it, may take 30 million years to crack. At that moment, it's not really feasible, but it will. So in theory, every password is crackable. What you want to do is you want to make it as so hard to crack that they don't even try. So a password length in today's world, we want to say that a good length in today's world would be at a minimum of 8 characters, and 10 is probably going to be a good one. 8 to 12, I would say. 10 is probably a good number in today's world. In fact, a lot of applications, you read older password manuals, it would have said 8. Nowadays, a lot of apps and websites specifies 10. You also want to make sure your password is complex. You see, if you don't have complexity enabled, these are settings, by the way, on passwords. When administrators configure their systems, they should enforce a minimum length. You don't want people with 6 characters. With password complexity, they're going to have some things like a symbol, a number. They might have to have a lowercase a, uppercase a. They're going to have all the different combinations on your keyboard. This would increase the complexity. So let's say your password is all lowercase dog, D-O-G. It'll crack just like this because there's no complexity to it and it's very small. Another thing we want is password history. So password history and expiration are two terms that are very confused. Password history is how many times you can reuse the same password. A lot of times password expires. Let's say it expires in 60 days. In other words, every time you log in, you got to change your password every 60 days. The problem is if you do password expiration and there's no password history, people just keep reusing the same damn password. It's not uncommon for users to use the same password over and over and over. We don't want that. So a password history, we may say 12. So in this case, they can't reuse the last 12 passwords. So every time they make a password, they have to make a different password. So that's password history. Password reuse across website, don't do it. Okay? Don't do it because this is what this is. You have one password you use across every single website. If I ever break that password or crack that password, I know everything about you. You use the same password for all your banking website and your Amazon and your email. So if I crack that password or it mistakenly gets pushed out in the wild, they can literally find everything about you and bring you down. Don't do it. There's a variety of password managers out there. So I use LastPass. I'm literally telling you that. This Dashlane. These are password managers where they store the password for you. I know it is impossible to remember the amount of passwords because of the amount of sites out there. Every site you go to wants you to put in a password. Password managers, things like LastPass, will create passwords, stores the password for you, and when you go to the website, it'll type it back in. I have LastPass on my phone and my desktop. I don't remember passwords. I have some crazy complex passwords, like 16 digits, for all the websites I go to, and I don't remember any of them because the password, I just go there, I select the site, password manager puts it in for me, my phone and my desktop. Once in a while, people will forget the password. There is a process to reset in these passwords. What is the process? Well, the process to reset a password, you might have to click password reset, you put in your email, you'll click next, and they'll send you a link to your email. That's one way. In organizations, you may have to call the help desk support line. They'll authenticate you by asking you unique information. It'll be an employee ID. They'll send you a reset link, maybe to your phone, or they'll reset it and give it to you over the phone. There has to be a way to reset the password. It is a given that people will forget their password at some point. And there has to be a way to reset your password. Before I use LastPass, you know how many times, almost every time I log into most websites, I have to reset the password because I try to make complex password, then I forget them. So make sure you get a password manager, because even though it's the least way to authenticate, it's still the most used. In this video, let's talk about encryption. So encryption is, of course, when you think of IT security, you think of encryption. It's, of course, the most talked about topic. Without the world of encryption, there probably wouldn't be security. In fact, when you think of securing your data, you're probably thinking about, no unauthorized access or confidentiality, right? When encryption is the way we're going to make this happen. When we encrypt data, plain data that's not been encrypted that anyone can read, that's called plain text. So plain text is data that you can see. The other one we have is something called ciphertext. So ciphertext is the encrypted data. So when what is known as an algorithm is a mathematical calculations on your data that outputs garbage data that you can't read, I can't read, unless you know how to decrypt it with what's called a key. So plain text is readable. Ciphertext is the encrypted version of the data that hopefully no one can decrypt unless they have a certain key. Now, encryption is used all over. We're going to use encryption when we're going across from you to Amazon. Amazon uses the SSL or TLS, Transport Layer Security, to encrypt your data. This is going to ensure that the data traversing the line, what's known as data in transit, is fully encrypted. Now, encryption is basically going to apply to data two ways: data at rest and data in transit. Data lies in three states, by the way: at rest, in transit, or in use. That means the data is actually being used. Now, encryption mostly applies to data at rest and in transit. So let's talk about this. The first one is data at rest. So when data is at rest, it's basically being stored on your computer. It's on your disk. It's on your hard drive. It's a file of itself. It could even be stored on your mobile device. In order to do this, we utilize certain forms of encryption, where we call file system encryption. This is like when Windows would encrypt files on an NTFS partition. You can also encrypt it by utilizing hardware chips, something called TPM, Trusted Platform Module. This is a chip that's installed on your computer that carries the encryption keys to actually hardware encrypted data itself. Now, data at rest encryption is very important because if somebody, let's say my phone, I have some seriously secret data, and somebody steals the phone, takes out the drive, or tries to analyze the drive, can they get the data off? No, because it's fully encrypted on the phone itself. They would have to have the decryption key. Data in transit. So data in transit is when Amazon is sending a user information. This data right here has to be in encrypted. How is it doing that? Well, Amazon is sending the data using HTTP, right? Hypertext Transfer Protocol. This transfers web information, but they're using HTTPS. Now, HTTPS specifies that it's using TLS, also known as SSL. TLS is the upgrade to SSL, Secure Socket Layer or Transport Layer Security. Learn about more of these in security class. But this means that it's fully encrypted between Amazon and the user. You can also use encryption for things in emails. There's a software called PGP that would encrypt emails. So when you send emails to people, you may have confidential data in there. You want that encrypted. When you are working from home, know this term for your exam. When you are working from home, let's say you have a home user or a home worker and you have a company. The company has a big LAN, a network by itself. The user is connected to the internet, so is the company. For the user to access, let's say you're a home worker, right? You work from home, you're one of those employees. You want to be able to access the company's information, their database, their files, their emails, and so on. What you're going to do is you will connect through a VPN. A virtual private network. A virtual private network is basically an encrypted tunnel between the home users and the company's information. What this does is that all information being passed between you and the company is fully encrypted, and that's what you want. All right, so VPNs are really important when it comes to working from home or accessing company resources. Sometimes we use VPNs between sites, between this site and this particular site. Also, we'll use a VPN. Mobile applications are basically going to use HTTPS or some form of SSL-based encryption in order to encrypt the data from them. Now, the world of cryptography is a massive world. I teach massive levels of cryptography and certifications such as CISSP, CEH, and a little bit in Security Plus. If you're interested, take those certifications. But trust me, you can't have security in the world of IT without encryption. I have always told every IT manager and system administrator and network administrator the same thing. It's not if a disaster is coming. It's only a matter of when. It's not if you're going to have a major weather event, such as a hurricane, flood. It's just when. It's not if you're going to lose power in your city one day. It's just when. It's not if the hard drive is going to blow out or its power supply dies. It's just a matter of when. And in the world of IT, you should be expecting this. When you go to work every day, the beautiful thing about IT is you never know what the hell happens. You could leave your network functioning perfectly one day and you go to work or you go home that night and boom, the whole thing drops because a system died, a switch died, a router died, there was a power outage, the system got flooded, the AC broke and flooded the server. All types of weird things happen. We have to be prepared to handle quote unquote faults. A fault is when the system gets hit. It's when the system drops. How do we build quote unquote fault tolerant systems? Systems that are capable of taking a fault. It has a tolerance of basically being broken. And in this section, I'm going to go over some of those things here, which we're also going to talk a disaster recovery plan. So one of the things here we could do is replicate systems. Systems replications means this. What data centers do is they have one data center and they replicate it to another one. So for example, Amazon, all the Amazon servers are not just in one building, because if that building ever drops, then the whole thing dies. They're probably going to replicate that to another building. So replication, all the data that's here is being replicated here. That way, if this building drops, this one stays up. Replication of this, like site-to-site replication, is not going to just be in one city. They're going to replicate it across different cities. So for example, they may have one in New York and have one all the way in Texas. That way, weather events in Texas is definitely like there's going to be different weather events in New York and so on. Redundancy, well, things will drop. Redundancy is having more than one of something. For example, power. Just don't have one line of power. If you have the main line of power from your power provider, you may have a generator or a UPS. So generators, machines that generates power from gasoline or natural gas in case you lose power from your main power provider. Networking and data lines. So for example, you may have internet lines. Instead of having one type of internet line from Verizon, you may have a line from Verizon, a Fios line from Verizon, but you may have a satellite internet from another provider. Notice two different providers, two different types of lines. That way when one goes down, hopefully the other one still works. If it's the same type, it may not work. When it comes to backup, I mentioned something earlier in the class. No backup, no restore. You should be backing up your data at all times. All data should be backed up. The files that we use, pictures, movies, music files, in organization might be data files, text files, spreadsheets, Word documents, critical data, maybe that new research project you're working on, maybe your company's PII of employees and its customers, their personal identifiable information, databases that stores mass amounts of customers' information, or organization processes. OS backup. You should have a backup of your different operating system. In an organization, don't think you're going to just use one OS. You're going to have Windows 10, but you may have different version of Windows Server. You may have different configurations of these operating systems for different machine. The way you configure an accounting machine is different than how you configure the sales machine. The accounting machines don't have QuickBooks or accounting software, but it does have a CRM. Back up your data. When you're thinking about backup, when you're thinking of, well, where do we store these backup? Just don't have a backup that's stored locally. Have a backup that's stored off-site, not just on-site, but off-site. Store it in the cloud. This is very famous. Put it in things like AWS or Amazon Web Services. A lot of people now, including TI, we store our backups in the cloud. Back in the days, people, when there was no cloud storage, you would make a backup of this data center and store it in another data center. So let's say you only have two data centers. One data center stores the backup of the other one stores the other of the other, if that makes sense. So you would basically have offsite backup. What if the whole building burns one day? And if all your backups are in that building, not only did you just lose all your machines and your data, you also lost your backup. It's good practice to keep your backups off-site. If you don't have a physical offsite, put it in the cloud. Contingency plan. When things break, what is the plan? What is the plan of how we are going to rebuild these systems? How are we going to continue working while the systems are being rebuilt? Do we have another data center that data was replicated? Instead of just talking about it and having a set of different processes here and processes there. This is how you recover this. This is how you recover this. This is how you recover that server, this router. Put it together in a big plan called a disaster recovery plan. In it, you're going to have that contingency plan in there. Now, disaster recovery plans is going to talk about data restoration. How are we going to do that? how are we going to prioritize the data restoration and restoring access to users? You should have plans in place for this. Now, let me go into some examples. When there's a disaster, when there's a disaster and the whole network drops, what is the prioritization of what's restored first? Do you restore your website first? Let's say everything is dead. Phones, websites, email, access to data. What do you restore first? The website, the data access, the email, or the phone? Every organization is different. Every organization has different prioritization. This needs to be determined. When you're restoring access, how do you restore that access? Is there a method or a procedure that has been documented? God forbid, what if the IT security person died in the accident or the disaster? What if the building burned and no one knows how to restore access? How do we restore access? In what prioritization do we restore access? And is there a procedure or an authorization document, such as, do we need a sign off to give this person access now that this person has passed away or is not available? And then how to restore data and where to restore it. In the world of disaster recovery, I'm going to go a little farther than your exam would. The whole concept of disaster recovery plan and the whole concept of how do we build a plan that if the organization gets hit with a major disaster, hackers breaking in, weather phenomena or events, how do we respond and make sure that the organization keeps running and people don't even know that our systems were down? These are plans that need to be put in place, and we need to have good fault tolerance systems, UPSs and generators, clusters in case servers drop, another one can kick in, called failover clusters, data replication between buildings. This topic can get very big very fast. Just keep in mind that when you're working for an organization, it's not a matter of if you're going to get a disaster, it's just when, and you always want to be prepared.